반갑습니다.
Hello everyone, I'm very pleased to meet you all. I'm President Ko In-seok of Seoul Institute of Technology. As COVID-19 pandemic spreads around the world, it is changing everyday life of the cities as well as people's lives. And I believe that all of you are having some difficulties and some inconvenience, but also we are enjoying a new convenience, meeting everyone virtually. We sincerely thank all of you for attending the 2020 Seoul Big Data Forum, which is held online at Seoul On Video Conference Hall of Seoul Citizens Hall today and tomorrow. According to the National Statistics Office, for the first time in 2020, the population of the metropolitan area exceeded the non-metropolitan population, with 25 or almost 26 million citizens residing within Seoul area. The problem of Seoul metropolitan area that is expanding with rapid urban sprawl, as various factors are intertwined, making it difficult to respond to the problem in traditional way. AI, big data have rapidly developed in recent years, thus emerging as a new alternative. Of course, the use of big data for problem solving requires collaborative approach, but we can also use other things in order to resolve those issues like climate change or other issues. We need to use scientific methodology, and also we need to explore and apply a new insight. In that sense, once again, collaborative approach is required. The Seoul Big Data Forum is held for the second time after last year. It is co-hosted by Seoul Metropolitan Government, Seoul Institute of Technology, University of Seoul, Seoul Institute, and Seoul Digital Foundation to provide knowledge and experience. I sincerely hope that we can share our experience and also views.
이번 행사 중에 서울의 빅데이터
The forum will provide an opportunity to take a step forward by signing a business agreement or MOU between the Seoul Metropolitan City Government and four big data related organizations to publicize and implement big data governance in Seoul. Scholars from home and abroad are joining us today, and we have with us Professor Yandiak Shumiker of Kyoto University, Professor Konstantin Kunto-Costa of New York University, who will be giving us keynote speech to talk about the directions for the utility of big data in times of urban crisis. In each session, we'll look at research and application cases based on big data, such as pandemics and urban science, AI, and big data-based urban innovations, urban sensor network, and urban life innovation through big data, and discuss the role of public. I believe that today's forum will definitely give us a precious chance. Lastly, I'd like to sincerely thank President Seo Sun-tak of University of Seoul, President Seo Wang-jain of Seoul Institute, Chairman Lee Won-mok of Seoul Digital Foundation. Thank you once again. My special gratitude goes to Acting Mayor Seo Jong-yup of Metropolitan City Government for giving us video congratulatory message. And also all the citizens of Seoul, thank you for virtually joining us today. Thank you.
That was President Ko In-seok of Seoul Institute of Technology. He stressed that the data is the power of this time of our lives. And it was a great opportunity to listen to President Ko In-seok to open this event. And now we would like to invite Chairman Lee Won-mok of Seoul Digital Foundation through video. Let's have a look. Good morning. My name is Lee Won-mok, Chairman of Seoul Digital Foundation. First of all, I would like to extend my gratitude for Seoul citizens as well as prominent scholars attending this Seoul Big Data Forum 2020. This year's forum is hosted by Seoul Institute of Technology. I thank President Ko In-seok for hosting this wonderful event. My thanks also go to the organizers, including the Seoul Institute and University of Seoul. Today, the hyperconnected society has emerged. Digital transformation and the speed of innovation have been accelerated. Accordingly, we have more issues that we need to concern together. At the core of such changes, there's data. At the Seoul Digital Foundation, we collect data created and collected by Seoul citizens. Based on that, we decide the location of social infrastructure, develop AI models for citizens' safety, and conduct research in various areas by utilizing big data. Big data is a big discourse, which is related to business administration, statistics, industrial engineering, and other areas, which requires cooperation. Seoul's smart city ecosystem is managed by numerous professional organizations. Today, we have all these organizations at this venue to further discuss urban issues. That's why this is furthermore meaningful. It is time to collect all our energy and wisdom amid data innovation and row the boat to move forward together. Seoul Big Data Forum 2020 is the beginning of such move. Through this forum, I hope individual organizations that used to use only the limited resources that they had can discuss various topics that they didn't use to solve. Also, I hope this will be an opportunity to nurture smart city policies of Seoul metropolitan government. In the area of the smart city in Seoul, digital competition and innovation will be encouraged and big data utilization. Thank you very much.
네, 고맙습니다. 빅데이터 중요성을 다시 한번 역설해 주셨는데요.
It was a great opportunity to remind ourselves the importance of a big data. Thank you very much for your kind remarks.
기관입니다. 서울시립대학교의
Next, we will hear the welcoming speech of the co-hosting institution, President Seo Soon-tak of the University of Seoul. Hello everyone, I am President Seo Soon-tak of University of Seoul. I'd like to welcome scholars from home and abroad joining us at the 2020 Seoul Big Data Forum, a place of knowledge sharing to map out the future of Seoul utilizing big data. Big data has been deeply rooted in human life in the 21st century as a keyword, and unlike before, it is rapidly increasing, such as making urban policies and solving city issues. Seoul Big Data Forum was held in 2019 for the first time, and this is the second forum we are hosting. All of you joining us today will experience the process of using big data to cultivate the city and also producing consensus of opinions and discussions from conflicting positions on a way to overcome crises such as pandemic. The common theme of this forum is very, very timely and urgent as we are faced with COVID-19. The theme Urban Crisis will be addressed during these sessions. We hope to also address crises faced by the cities and countries trying to find ways to wisely solve crises through innovative utilizations of big data. Furthermore, we look forward to in-depth discussions and explore new insights on the innovations of the future city and reorganizations of urban city and its relationship with the big data. Our imaginations of the future city will also increase the true value of Seoul, and I hope that today's forum can provide a great opportunity. Finally, I'd like to once again express my sincere gratitude to the members of the organizers who work hard to host today's forum, and also all the members joining us today. Thank you.
네, 고맙습니다. 따뜻한 말씀으로
Thank you for warm remarks to welcome all the participants and audience. Thank you again.
이렇게 많은 기관에서
We have numerous organizations prepare for this wonderful event in the era of technology and innovation. Last, I would like to invite President Seo Wang-jin of Seoul Institute through video. Let's have a look.
안녕하십니까?
Good morning. I am Seo Wang-jin, President of the Seoul Institute. I'm delighted to co-host Seoul Big Data Forum last year and this year. Please allow me to sincerely appreciate Professor Konto Costa and Schumacher for the keynote speech. In each session, we have international prominent experts. Also, for the success of hosting this event, we receive great support from Seoul Institute of Technology, Seoul Digital Foundation, and University of Seoul. I thank all of you. COVID-19 has been an unprecedented crisis for the whole world. As we gather to live, interaction between various individuals and organizations creates values and leads innovation in big cities. However, these big cities reveal their vulnerabilities against COVID-19 and are striving to respond to such crisis. K-quarantine or S-quarantine have become an example of best practices of Seoul, the capital of Korea, in order to preemptively tackle COVID-19. The city, however, is also threatened by many challenges. Meanwhile, we don't stop fighting against enormous pending tasks. In the era of new normal by the pandemic, we strive to find vision and alternatives with the help of collective intelligence. In the course of that, development of ICT and science and technology are leading the sudden changes in the era of pandemic, which are witnessing at the moment. In particular, big data and AI are actively utilized in city policies, which keeps daily lives of citizens going. A new way of value creation and innovation growth are possible and will be possible thanks to such technologies. In this regard, power of big data in time of urban crisis, the topic of today's event, is extremely timely. Korean and international researchers will share their research achievement in order to affect the big data-based urban policies in international cities while finding new ideas. In particular, this year, Seoul Metropolitan Government as a policy body is participating with us. This will enable us to proceed with more practical discussion. A year later, another Seoul Big Data Forum will be held. I hope we can see each other not only meeting online, but having all experts put together their wisdom. Thank you very much.
네, 고맙습니다. 이렇게 네 개의 공동 주관 기관과 또 관계자 여러분.
We heard the four co-hosting institutions welcoming and opening address. And also, we have with us Acting Mayor Seo Jung-hyup of Seoul Metropolitan Government to congratulate the opening of today's forum.
반갑습니다.
I'm very pleased to meet you all. This is Acting Mayor Seo Jung-hyup. First of all, I'd like to congratulate the hosting and opening of the 2020 Seoul Big Data Forum. The forum is aimed at identifying the infinite potentials of big data in an era of crisis and seek the role of the public. The forum is very significant as it is co-hosted by four institutions that are the think tank of the Seoul Metropolitan Government. Thank you all to the relevant people involved in hosting the forum and also speakers from home and abroad. Once again, thank you. In the era of fourth industrial revolution, the Seoul Metropolitan City government has focused on the big data as a key element to solve urban challenges while achieving innovation. As a representative example of Seoul's hit product is Owl Bus, which has become the foot of citizens operated during the late night hours. Even in the COVID-19 era, big data was the first contributor to the K-quarantine. Throughout the struggle against unprecedented epidemic, the central and local governments have used big data as a compass to predict virus spread and establish quarantine measures. Despite the accelerations of the contactless daily activities, big data is driving digital innovations in various fields directly connected to citizens' life, such as transportation. Furthermore, in an era of uncertainty called post-COVID-19, big data will increase the predictability of an administration, save citizens' life from disasters, while establishing itself as an essential resource to ensure the survival and growth of mankind. We hope that today's forum will be a place of meaningful discussions to highlight the value of big data and its applicability. Seoul Metropolitan City Government will continue its effort so that it can be repositioned as a global big data capital. Thank you.
Thank you very much to have another warm reward. That wraps up the opening ceremony of 2020 Seoul Big Data Forum, and soon we will begin the keynote speech. And we have two prominent speakers in the area of big data. data. And after a short break, we will start at 10 a.m. So please be with us when we start the keynote speech.
The end of the opening ceremony, and we'll move on to the keynote speech will be held with two speakers who are the great scholars in the big data field after a short break. The forum will begin at 10 a.m. So I'd like to introduce the keynote speech in Korean. Thank you very much for your cooperation. 기조 강연 잠시 소개를 해드리겠습니다.
I would like to introduce the two keynote speakers. First, Professor Konstantin Konto-Costa, the author of the book called Urban Intelligence from New York University, and Professor Jan Deok Schumacher, who is actively doing his research in the urban activities by utilizing big data. In particular, we are running this event in a hybrid manner of online and offline, and this will be led by Professor Lee Hee-jung from Seoul University of Seoul with us on site. Please be with us and with the great speakers of keynote speech, and we will be back at 10 o'clock.
And give us your interest to the forum. Thank you. 교육시간 함께 해주신 여러분 고맙습니다.
Thank you very much for joining us today.
네, 여러분 편히 쉬셨습니까? 여러분께서
I hope you enjoyed your break and you are joining us at the 2020 Seoul Digital Data Seoul Big Data Forum.
기조 강연 순서 진행을
We would like to start the first keynote speech. We are going to have these two speakers online, followed by discussion with the moderator. And the first speaker is Professor Konstantin Konto-Costa from New York University, and the second speaker is Professor Jan Dirk Schumacher from Kyoto University. In particular, we are running this event in the hybrid format, and we would like to invite the moderator, Professor Lee Hee-jung from University of Seoul, who is with us on site. So soon we will begin, and I would like to introduce Professor Lee Hee-jung. She's a professor at the Urban Engineering at the University of Seoul. She studied urban engineering at Seoul National University. After that, she achieved a PhD in architecture and urban landscape from University of Seoul. She used to work with Aji University before, followed by Seoul Development Institute, and she was the head of the Urban Design Center, and she's also the member of the urban planning committees. And Professor Lee also is the director of the Seoul National University, Seoul University.
안녕하십니까. 서울시립대
Good morning.
이정 교수입니다.
My name is Lee Hee-jung.
여러 가지 온라인으로 이렇게 세미나를
You are joining with us at the hybrid format of the event. However, we have a lot of participants and audiences, and probably we have some overseas audience. Maybe it's late in the evening, their time.
감사의 말씀.
But once again, thank you very much.
오늘 기조 세션은 그 도시 위기
Our keynote session is the topic under the strategic city innovation with the big data in the urban crisis.
코로나로 인한 여러 가지
Due to COVID-19,
상황과 또
we are in so-called untact situation, and amid the pandemic circumstances,
온라인으로라도 빅데이터 포럼이
we are still glad to have all the speakers online, and it is
보람과 영광으로
our honor and privilege to listen to these wonderful keynote speech.
이제 학자를 모시고
So we have two speakers for the keynote speech
기조 세션에서 마련했습니다.
as our keynote session.
먼저 연사분들께
First of all,
와중에도
once again, we would like to thank all the speakers
영상을 녹화해 주시고
who recorded their video for their presentation, and I know that you will be with us online on air to discuss some questions. Professor Konto-Costa is from New York, which is a great and big city, and he's from the Marin Institute of New York University. And with various publishing activities, he published books in urban informatics and urban science, and he is such a pioneer in these areas.
오늘도 아마 이런 새로운 연구
And I am sure Professor Konto-Costa will introduce some directions and what he has achieved with the great potential of urban science. Also, Professor Jan Dirk
실제 다양한
has conducting various international academic activities, and he is highly interested in Asian region. And in Japan, currently he is collecting and researching various big data under various projects. Last year, he participated at our first Seoul Big Data Forum. So I'm excited to have Professor Jan Dirk again.
첫 번째 강연으로 이제 뉴욕대학
First, we would like to invite Professor Konto-Costa
강연을 듣도록 하겠습니다. 그러면
for our first keynote speech.
영상을 먼저 만나.
Let's have a look at his video.
Hi, I'm Constantine Canacosta, Professor of Urban Science and Planning at New York University, where I also direct the Civic Analytics Program and the Urban Intelligence Lab. I would very much like to thank the organizers of the Seoul Big Data Forum for the invitation to speak to you today about some of our work using big data analytics to address some of those serious challenges facing cities in the 21st century. Specifically, I'll discuss some of our projects as they relate to climate change and sustainability, resilience, and social justice. We're all very aware of the statistics around urbanization across the globe as more people move into cities looking for new opportunities and improved quality of life. But with this rapid urbanization has come a number of challenges that can only be solved in cities. And whether these be issues of urban management and operations such as waste collection, crime, issues of resilience and sustainability and climate, or issues of social justice and equality. Cities are, of course, where many of these challenges emerge and where these challenges can best be solved. Now, I've put together a bit of a typology, a framework about how we could think about big data analytics for some of these urban issues. And roughly, they break into three different categories where we could look at operational and management issues on one hand, which lend themselves to kind of day-to-day activities and optimization of certain problems, to planning challenges that have much longer time horizons, many more stakeholders involved, and get much more challenging as competing needs and priorities must be balanced. But ultimately, this type of typology helps us frame how we could think about the types of problems that we're facing and how data and computation can begin to address some of those. And what is new in the current era, what we see that's new about an urban science and urban informatics is really the shift away from kind of low resolution survey type data into very high resolution, near real time data that we can process and understand the dynamics of the city at a much more granular level than we could in the past. So essentially moving from this kind of spatiotemporal static data, so you can think of kind of the US Census type data, survey data, moving to this more spatiotemporal dynamic data, geolocation data from smartphones, citizen complaint reports, for instance, or resident complaint reports. And this very much changes how we can think about the types of ways that we address some of the problems that cities are facing, whether they be policy challenges or challenges of day-to-day management. Now, computation alone, big data analytics alone will not help us advance solutions to many of these problems because solutions in many cases is not the right term. We're thinking about addressing these problems in a way that is dynamic, that evolves over time, and that can actually be used to improve quality of life in cities across multiple dimensions. And so there's a number of constraints that begin to exist as we try to bring data-driven methods into the urban policy framework. One is that the right data are rarely available, meaning we don't often have the data that we would like to have to address the problem at hand. And this typically comes from a problem known as digital exhaust, where we are dealing with data that happens to be available or collected for some other purpose and trying to repurpose that information to address a new question. Another major challenge for cities is actually integrating data across the different sectoral silos or the different organizational and institutional components that make up a city governance. And so this we could refer to as data tombs, where it's many times very, very difficult to extract the necessary data or integrate it across different sources and different agencies. Third, city agencies often face significant infrastructure constraints, and whether these be institutional in the sense of how decision-making is done and how incentive structures are done for employees and for public sector workers, computational challenges in terms of being able to have the right infrastructure in terms of IT capabilities, computing capabilities, and then the kind of human infrastructure component of having people with the right kind of data science skills and analytic skills that also understand in a very significant way the operations and of how a city actually functions and how a city is planned. And ultimately, a very significant difference between what we think about kind of an urban science, urban informatics, and perhaps big data analytics in other contexts is that urban problems are social problems. So by their very nature, these are much more complex, involve multiple components of human behavior, involve issues around competing values, priorities, and needs of different residents, and of course, the issues of social justice and equity around bias and discrimination that can result from differential access to services or opportunities. And so what this means is that the optimal technical solution is rarely optimal in the practice of planning. So just because we might have a model that seems to fit the data very well does not mean that we have a better way to solve the problem that we were looking at. So in our research, we focus on a number of different areas, but ultimately we're trying to bring high resolution, large scale data to bear on some of these kind of complex urban problems. So we are looking at bringing computational methods from multiple disciplines together to better understand urban dynamics. And urban dynamics across a number of different components, whether it be the mobility of people, kind of the socioeconomic dynamics of the city, or the flows of information or energy or water or waste. So I'll give some examples of how this work has played out in practice and how we've partnered with city agencies to deliver new data-driven solutions or data-driven opportunities to address some of these policy challenges in new ways. And just first, before I begin, I'd like to just acknowledge some of our funders and collaborators. We've had the opportunity to work with National Science Foundation, among many other federal agencies and city agencies in the US and abroad. And we're always looking for new collaborators and partners for our work. So one project right now that we have ongoing funded by the National Science Foundation is to look at bias and discrimination in city predictive analytics. And this really focuses on a data set known as 311, which is when residents are calling and reporting a problem that they experience. So this is a very rich data set, over 2 million calls per year, at least in New York City, and provides an important foundation to better understand conditions across the city in near real time. Now, one of the challenges here and what we're trying to unpack is that people do not report problems at the same rate. So they do not complain at the same rate. So that when cities are using these data to train predictive models about where to deploy services, where to deploy building inspectors, for instance, the challenge is that people perhaps in underserved communities may not have the same representation and thus may not get the same level of service. And this may continue to exacerbate problems of discrimination or disparities that exist among different groups in the city. And to give you a more concrete sense of this, this is some work that we did just trying to predict heating outages in New York City in residential buildings, which is a major problem especially for lower income areas of the city. So using these types of data, using new computational methods, we can assist the city agencies in determining where problems might occur so that they can more efficiently allocate resources, particularly building inspectors and others, to address these problems quickly and to address these problems fairly. Now, some of the exciting parts of this is that where these data can be used to address very specific operational problems, they also can be used to better understand kind of urban dynamics at a broader scale. So this is using that same type of 301 resident complaint data, but instead trying to understand how neighborhoods are changing over time based on what people are complaining about. And we find that we can actually use these reporting patterns and these complaint patterns to find a signature for different neighborhoods and understand how those neighborhoods may be changing over time. And so that's one example of a specific data set, that complaint reporting data set that we are using to address both operational problems and advance kind of the fundamental science of urban dynamics. There are other applications that we've been involved with, going from left to right here. So looking at applications of artificial intelligence to support homelessness services, looking at spatial analytics to see how urban greening and urban street trees, in this case, affect air quality, which ultimately, and its impact on public health. And then working with the Department of Sanitation to better optimize waste collection routes to ensure that vehicles are causing the least amount of disruption to traffic, causing the least amount of pollution as possible, while more efficiently collecting waste across the city. But I think one thing that everyone's very excited about are some of these very large new big data sources. So social media is a great example of that. This is some of our work using Twitter data to understand how the popularity of neighborhoods is changing, and to use that as a leading indicator, perhaps an early warning indicator of where gentrification may occur or where neighborhood change is occurring. And this allows policymakers to better understand where housing needs are, especially affordable housing needs may be, and better attend to the needs of residents in areas that might be experiencing rapid growth, for instance. Another data set that we work extensively with is geolocation data, and this can be derived from multiple different sources, whether it's kind of Wi-Fi activity or GPS locations from smart devices, for instance. And this gives an example of some of our work to try to understand localized patterns of mobility across the city, so that we can begin to get to a real-time census of the city and not necessarily just rely on census information, for instance, for us as we begin to use that insight to improve both the management of the city day-to-day and longer-term planning strategies as well. And one example of how we're using some of this geolocation data is to better understand the impact of natural disasters on different neighborhoods across the city. And so here we're using smartphone data to understand how mobility behavior helps us understand how people respond to and recover from natural disasters. In this case, this is Houston in Texas. And so we're specifically looking at how the impact of Hurricane Harvey in 2017, which is a major hurricane that hit the city and caused massive amounts of flooding, how different neighborhoods were able to respond to that, and how the impact affected neighborhoods across the city. And so this is very important, not only for more kind of real-time disaster management, but also thinking about longer-term patterns of how do we make the city more resilient, but make it more resilient for all of the residents of the city. So how do we ensure that there is fairness and equity in where we are allocating resources to improve how cities can respond to and recover from natural disasters as they occur? And a current project that we're working on that's funded by the National Science Foundation is actually using very similar mobility data to better understand how neighborhood activity and something we call exposure density has led to the increase in infectivity risk of COVID-19. And so this actually is showing activity from January of 2020 through April of 2020. This is actually data from Seoul that my colleague Dr. Bo-Young Hung has put together that allows us to see and understand how activity patterns are changing and how that changing behavior impacts the likelihood of being infected with COVID-19. And this also provides us a very interesting opportunity to look at the neighborhood scale and develop very targeted public health responses and policy responses to improve outcomes in terms of COVID-19 risk and infection. And in particular, we're very concerned as we look at cities in the US right now on the disparities in the impacts of COVID-19. So how poor communities, minority communities are disproportionately feeling the brunt of the disease, and how we can use these types of data tools to improve localized responses to improve those outcomes across the city and across different neighborhoods. So right now, so it gives you some example of how we're using different types of data. Started with looking at 311 data, which is a kind of resident reporting data, how we're using social media data, how we're using geolocation data to address, again, both operational issues facing cities, longer-term planning issues facing cities, and then to just better understand the dynamics, the science of the city, for instance, the dynamics of the city, and how the function of the city, it moves and changes over time. I'll spend a few minutes here now talking about our work, specifically around climate change and how we're working with cities to use data-driven methods to improve climate action and energy efficiency in cities to reduce carbon emissions. And this is a major challenge for cities around the globe. In New York City, one of the leaders in kind of sustainability planning has adopted an 80% reduction goal by 2050 in terms of carbon emissions. And this is a very ambitious goal, and one that is a function of not only kind of the need to reduce carbon in terms of its impacts on the planet, but also the reduce the strain on the energy infrastructure within the city as well. And so there have been a number of policy tools that have been introduced and policy interventions that have been introduced over time, beginning with very powerful but relatively simple policy intervention known as Local Law 84, which was a requirement that buildings had to report how much energy they're using each year. Now, this seems rather straightforward, but this was data that was not available prior to the introduction of this law in 2010 and 2011, but provides an incredible resource to really understand where and how energy is being consumed in buildings across the city, and then ultimately how you could design better policies to address it. And so we see this evolution of policies from this very straightforward informational policy, Local Law 84, to more aggressive policies requiring energy audits and energy retrofits. And cities across the country in the US and many cities across the world have adopted very similar policies, making for comparative analyses and other ways to kind of share best practices, and developing new ways of using that information to, again, design very specific and targeted policies to improve the efficiency in cities. And many of these policies that we're talking about rely on information disclosure and transparency as a way to shift decision-making, to shift behavioral choices. And we've seen examples of this in other sectors, and I present these pictures here to show what's happened when, in New York City, for instance, required restaurants to post how many calories are in their food, or letter inspection grades for the sanitary conditions of a restaurant. So this type of information disclosure allows the consumer to make more informed decisions about where they will eat in this case, or what they will eat. But from a broader perspective, from how we're thinking about it in terms of energy, it gives both the owners of the buildings and the users of the buildings more information to determine how best to make investments to improve the efficiency of that building, and how best to make decisions about using energy efficiently when you're actually in occupying that space. And so a fundamental piece of this was the integration of data across multiple different sources across the city, where we were pulling in energy use data, as I mentioned, from Local Law 84, but also very detailed property and building characteristics from the city, real estate information and market data from third-party providers, census and socioeconomic data, financial data from the city. All of these things had to be combined and integrated, which is no small task, and usually a very important piece of the data processing pipeline is simply accessing these data, standardizing them, integrating them across different silos. And once we have this information, it's not simply enough to have the Python code or a CSV file of the data. It has to be made available and accessible to folks who may not have those types of skills. So one of the early projects we did in partnership with the City of New York was to take some of this energy benchmarking data, as you could see on the left, and build an interactive visualization tool so that people could actually understand and look at and compare how their building performs to other buildings across the city. And the links are provided here if you'd like to go and take a look. And this tool provides an incredible amount of information because all of these data have been integrated and now provide a more accessible framework for people to understand how their building should be performing, how it is performing, and how it compares to others across not only energy use, but greenhouse gas emissions and water use as well. And now that we have this repository of all of these different data sources combined, focusing on energy and carbon emissions, we're able to kind of track and monitor progress towards these ambitious energy and emission reduction goals. And this is a critical piece of the process, is really being able to use these steps to understand how well existing policy is working and where new policies should be implemented. And as part of that, we're able to also evaluate policies at a much quicker scale than we could in the past, so that we can rapidly evaluate how well a policy is working and determine if it needs to be changed, if it's working as intended, or if it needs to be entirely replaced. And this is some work we recently did looking at the impact of a mandatory energy audit requirement in New York City on reducing energy use. And as a piece of this, we're able to also understand, as we look at the landscape of energy use across the city, we're able to understand what the impacts of those that energy use is on different communities across an area. And so in this particular case, we're looking at how much does energy use and energy inefficiency impact lower income groups in particular. And we found in New York that this is a significant problem in terms of something called energy cost burden. So how much people are paying for energy as a part of their household income for the year. And so what this again allows us to do is think about more targeted policies, not just spatially, but targeted policies based on need and based on priorities of opportunity for groups that may be vulnerable or experiencing undue burden and hardship. And so as we think about how we use these data to address these policy issues, we're also thinking about how we can use these data to advance our understanding of the form and function of the city. So here we use the LiDAR data, which is an incredible data source that provides very high resolution 3D data or 3D imaging of a city. And we were able to use that point data from a LiDAR flyover that was done in New York City to recreate the 3 dimensions of every building in New York City, which then allows us to compare this back to energy consumption and other data to figure out how the morphology of the city and the morphology of a building impacts its sustainability. And when we put all of these pieces together, as we did in this case, we can start to develop dynamic models of carbon emissions at very high resolutions. And here we combined high resolution traffic data, the building energy data, to develop an hourly model of carbon emissions across New York City at a very high resolution grid level, so down to almost the block level. And we hope that this can then be used as a tool to better understand emission dynamics, carbon dynamics across the city, how the climate is changing over time at different time scales and spatial scales, and be able to provide more insight into policy development over time. So I've covered a lot of ground here, but I'd like to just close with a few thoughts on this kind of emerging urban science that we see and kind of using big data to address urban challenges. And there are a number of tensions and balances that have to be understood and kind of acknowledged and worked through to get to a place where the use of computational methods, the use of big data in urban planning and urban management becomes something that really adds capability to existing tools and existing ways of making decisions and understanding needs across a city. So one issue, of course, is that we're combining lots of different disciplines, whether it be the urban planners with physicists and computer scientists and data scientists. So all of these different groups have slightly different ways of communicating, different ways they look at problems, different ways they think of how to address those problems. So, integrating across these different disciplines is an important concept in terms of, really creating a coherent new science of a city. And we spent a lot of time doing this at NYU, trying to build the groundwork for this by building educational programs that will build talented folks who have these skills from day one. As an extension of this, we have to think about where we start from in terms of understanding problems as a kind of urban planner might, or do we start with trying to focus on what data we have and how we could understand that data as a computer scientist or data scientist might? So there is this tension in kind of where do you start from? Do you focus on the data or do you focus on what problems to solve? And ultimately that's going to have to come to some integration between the two. And then skipping to the fourth down here, there is also a tension between state of the practice and state of the art. And this comes back to some of the challenges and constraints I mentioned earlier, which is the state of the art in terms of how we use geolocation data, for instance, or social media data, how we use more advanced computational methods or remote sensing, for instance, doesn't always connect with what city agencies are capable of implementing in practice. So there is this disconnect between what is possible in terms of computational methods and big data analytics, and what would actually be useful at the end of the day to the people who are making decisions at city agencies. So there is a kind of a tension somewhat here between what perhaps academics might want to do and what those in the public service really need. And then finally, confidentiality and privacy is a major concern, especially as we start to look at some of these geolocation data and higher resolution data. And so we have to be very cognizant of this in terms of how we manage data, how we access data, how we get permission to use data. And so these types of privacy issues are a major consideration, especially now as the use of data from smartphones, for instance, has become more widespread. While we can gain a lot of insight from this, we also have to understand kind of the moral and ethical dilemmas behind this. And we have to train our students, and we have to, push ourselves to make sure that those types of decisions and what data are being used and how they're being used are really grounded in these kind of ethical foundations, that at the very minimum we require that we protect the privacy and confidentiality of city residents. So this is still very much a work in progress in terms of how do we develop the right data management protocols? How do we develop the right standards in terms of what data can be used by whom, for what purposes, and this becomes obviously very important in the study of cities, where we are ultimately talking about impacting the lives of individual residents. So we have to be very very aware of the potential harms that can come from this, and make sure that we are doing everything we can to preserve privacy and confidentiality as we start to think about some of these new big data sets. So with that, I would like to very much thank you for the opportunity to speak today. I look forward to continuing the discussion and answering and addressing some of the questions that come up. Thank you very much.
네, 감사합니다.
Thank you very much.
정말 인상적인
It was a very interesting presentation.
같습니다. 저희 이번 그 빅데이터 포럼의 주제하고도 잘
This is in line with the topic of our Big Data Forum because he introduced various urban issues, COVID-19 related issues,
모니터링하고 관리하고
and he also suggested some projects that he was involved in with the experience of New York in the context of urban informatics by utilizing various technology of AI and analytics. Also, it was very interesting to hear some tips of management and operation of data. Ultimately, this city management will help sustainability while we are moving towards net zero. And new big data by utilizing AI could be utilized in our daily lives as suggested by Professor Konto Costa. So this is what urban science all about, and what's very interesting. And we would like to hear more from him later after the second keynote speech. Next, we would like to invite Professor Jan-Dirk Schmecker. Also, we will meet him from the video.
Good morning to you all from Kyoto, Japan. I'm very honored to be able to address you in this way at this 2020 Seoul Big Data Forum. Of course, I would have liked even more to be with you in person. I participated also last year and have very fond memories of meeting you. And I would have really liked to have more both formal and informal conversations with you. On the positive, I think that we all start to realize the potential of online life and that we can meet even without creating any emissions and other environmental impacts. Now, this online life is also connected to the talk I'm going to give to you today. I want to discuss the potential of big data to estimate and explain leisure and tourism trips, i.e. non-essential trips as we often call them, but then also our definition of what is essential trips might have changed now during this COVID year. Clearly, tourist and leisure trips have been heavily affected by COVID. And in this talk, I will use Kyoto as an example to make some general observations on tourism and leisure trips and their need for it and their motivation for it. And then I will discuss how we can use big data to not only observe, but to potentially also explain these trends that we observe. As an introduction here, you see the number of foreign tourists in Japan, a total collapse in 2020. And I'm sure these trends will not be so different in Korea. However, in terms of domestic travel, the trends look a little bit different. As a background, in Japan, I should mention that in Japan, compared to many other countries, we never had a very strict lockdown here. People were not tied to their house. And in fact, as of this autumn, people are actually encouraged to go out more. The Japanese government launched the so-called Go To campaign and the Go To Eat campaign, providing subsidies if people travel to the countryside. Well, and in fact, it's not limited to the countryside, also if people travel to the cities, as well as providing subsidies if people go to restaurants. So really encouraging for the purpose of economic recovery people to go out and to make these leisure and tourism trips. Of course, ideally, the idea is to promote travel in the countryside, and of course, also in Japan, social distancing has been promoted. But people also return to the cities. If you look at this picture from 2020, one is an own picture I took last week in one of the popular tourist areas in Kyoto. People do return, and people return to the cities. So, well, this slide once more shows a trend in how people return. This shows records from Wi-Fi sensors. I will come back to these data later, because we also use them for our own research. But you can clearly see how the tourism activities have been returning in autumn in Kyoto. To notice that autumn is one of the peak tourist seasons here, with the red leaves being really very beautiful. If COVID ends and you have a chance to come to Japan, I recommend October, November, especially November is one of the best seasons to visit, if it's not too crowded. Also here, once more a slide to just show you briefly the recovery in recreational trips. This is from Google Mobility Report data. These data, maybe many of you know, are publicly available. We can download them by prefecture. And you can see here, yes, there was a sharp drop in April, May, but the second and the third wave don't seem to affect Japan that much in terms of especially people going to recreational areas. So, why do people return to cities? Why, despite COVID fears, why despite returning crowding in some cases, why do people still come to cities? Well, and especially why do people come to popular cities such as Kyoto? Well, the reasons are in some sense, of course, obvious. I mean, firstly, I should really mention there is, of course, for people living nearby and also for people coming from, in the Kyoto case, from nearby Osaka, it's easy to go. It's the total access costs to some important attractions are fairly low compared to traveling to, for example, the countryside. Especially if you travel in groups, and of course these costs of of everyone having to travel are important, and city centers are usually easy to reach. Furthermore, of course, cities offer a large number of attractions that we do not find anywhere else. Recreational, shopping, culinary in terms of restaurants, cultural activities, and of course the history, historic buildings, temples, all of these sites we can find inside cities. I want to mention here some keywords that I feel are important in this discussion, and that are important if we consider how we tackle the estimation of tourists with big data. The keywords I mentioned here are authenticity, stories, and fame versus dynamics. And let me explain this a bit more. With authenticity, I mean often we hear keywords such as we want to have an authentic experience. We want to experience the real place. We don't just want to go to a fake place which is replicated. And to explain this a bit more, often we hear this phrase, "I've been there too." And this has a bad connotation, but I would suggest it's not necessarily bad. There's first an internal past-oriented reinforcement, as I call it here. If I hear stories of people having been to a city from my friends, from my family, maybe from my grandparents, if I'm also traveling there, this brings me a feeling of connectedness and helps me to connect to people. At the same time, I would say there is a future-oriented reinforcement of why people travel to popular places. I know that this brings likes in a literal sense on Facebook and other social media, but also in a more broader sense that I know that I have been to a place will bring me benefits in the future, in terms of I can say I've been to such places. Why am I saying this? And why do I think this is important in this discussion on big data? The point I want to make is that I think it is very difficult to distribute tourist trips. If we talk about and especially if we talk about a post-COVID society, usually the rich get richer. Destinations that are attractive, there is a reason for it, and this it reinforces itself over time. Let me explain this. Let me though also add one other important note to this. Tourism demand by far is static. Yes, there are a number of places, as for example, you see here the Golden Temple, that are always going to be popular. These are World Heritage sites, and yes, we can argue that people might not travel to the most famous places that much anymore, but still there are places that have a fame and that will always be popular. On the right, you see here a queue for a ramen shop, a noodle shop, and these are very popular in Kyoto. And some are also popular over a long time. But sometimes I see shops that are very popular in 1 year, but in the next year, the trend has totally moved. Another ramen shop has become popular. So this is just an example where I think there are very complicated dynamics in terms of where people travel and how they, for example, especially how they combine different attractions for a tour as to which destinations you visit within Kyoto within 1 day. Also, there might be some kind of demand equilibrium. Less crowding means a city becomes more attractive again. You see here pictures from Arashiyama, another popular tourist destination. And in this, they started a campaign emphasizing that now that this part of the city is empty, we can actually enjoy it. So less people, of course, encourages a bouncing back effect that it's for tourists to return. Furthermore, with COVID, we have, of course, less compulsory trips. We do things more online. And this in itself, people don't want to stay at home. This creates tourist demand. Also, we can do things now at different times of day. Again, there's ample of research showing that people need travel. Travel is a need in itself. Also, there are less constraints now in terms of pricing, in terms of tickets. If I'm commuting to work, I have a season ticket and I've already paid to visit a large amount of destinations. Now, since maybe more people will not buy season tickets anymore, I have more freedom in terms of which destination I choose. I call this here leisure trips become tourist trips, with which I mean is that leisure trips are very often combined with essential trips, but tourism trips usually don't face these constraints. And a final note for this first part of my talk is that I want to say, well, and again, this might be a phrase that we say that COVID is a chance to rethink our tourism concept, but I do believe that our research can show this. And the two pictures here show one of a reality of how crowded it is in Kyoto before COVID, and the lower picture shows a pamphlet. And shops have been complaining now that the less customers also means less revenue, and that is certainly true. But I would suggest it's probably not in a very linear, there's no linear relationship. There might be a marginal decreasing relationship between customer numbers and profit. If we have less crowding, people are able to make more tours. People are use their time more effective. People can probably enjoy their time in the city more, and more enjoyable time, better mood will also increase people's likelihood of purchasing goods. If I'm in a shop where I'm not rushed, I might be able to select a more expensive good and be able to decide to purchase it. Overall, we might have more motivated tourism. We might bring in here the more sustainable tourists. So I would argue there are a lot of potential benefits of how we can use this COVID crisis to rethink how we estimate tourists, as I will explain in the next slide, as well as overall tourist concepts for our cities. Now, the connection to big data, the topic of this forum. Modeling tourists is a large challenge. As I tried to explain in the previous slides, there are less constraints, there are intrinsic dynamics that are very difficult to estimate. And we don't just want to observe such trends. That is fairly easy with all the data we have. But we want to establish causal relations, especially for now also making predictions post-COVID. So we need to quantify objectives and the attractiveness of certain areas in order to predict how people, or which people, and when people travel to these areas in a city, for example. Tourist surveys are very difficult to conduct on a large scale, and are very often biased towards population groups. So here, really, we need to use the chance of big data. There are a number of data, and I'm sure these are also frequently used in Korea. Mobile spatial statistics give us good information about how many people are in which part of a city. But they don't necessarily explain it. GPS traces from mobile phone applications are often much more sparse data and are more difficult to get. In Kyoto, we get some data from a public transport planning application where people opt in to be allowed to be tracked. And from this data, we can observe tours that people make through the city. So, for example, this person here you see on the right, and he started in the morning, then traveled to the eastern part of Kyoto in the morning, probably had a lunch break in the city, and then moved down to the southern part, the Fushimi part of the city in the evening, and has a dinner and then returns. So we can observe these trip patterns from these data. But that's not enough. And as I tried to note here, we need explanatory variables. And I would argue that we do have a lot of this information. We do have a lot of information about so-called point of interests. And the rich information about these point of interests themselves, not just the number and the types, but for example, Google provides information about ratings. We can also get these from other social media. We know opening hours. We know number of times that people share these on Instagram and other type of social media. For example, here these are Google point of interest data for a small area of Kyoto. Within this 800-meter radius of one particular tourist attraction, you see here all the Google information that we have from other points of interest, be it restaurants, be it, for example, convenience stores, be it other facilities such as ATM machines. And on top of that, we know their opening times. We can extract, so for example, this restaurant you see is open in the evenings. And for some of these places, we can even find their live popularity at a certain point in time. There's been quite a number of recent papers utilizing such information, and they show that this information actually has a high correlation in terms of how many tourists visit those areas during times of day, but also over larger scale, such as days of week or month. Now, I want to, in the end of this talk, I want to give you two examples of research that we are doing with such data. The first research is in this first research, we try to explain tour patterns through Kyoto by using such map and rating informations. Based on a preliminary research, we grouped attractions into three categories, whether they are natural scenic attractions and temples and shrines. Then the second category is whether they are restaurants, and the third category is whether these are other leisure activities such as museum and so on. And we use here the number of attractions as well as their rating by tourists. So, for example, based on this information that we can extract from OpenStreetMap and social media partly, but here we also use Google ratings. Such data are extractable via APIs. We can, for example, find here now the attraction of different areas in Kyoto in these three categories that I mentioned before. We find here, for example, that the Gion area in the downtown is very rich in terms of attractions in all three categories, something that we would expect. And other areas at the edge of the city might be only rich in terms of one of these three categories. We then embed these data into a tour prediction framework, in which we estimate the weights for these different attractions by fitting observed tours. We further consider behavioral aspects such as a decreasing amount of satisfaction of visiting another point of interest if a person has visited such a similar point of interest before. People get tired. And as far as possible, we develop here a framework where we embed further, for example, socio-demographic information that we might be able to infer based on, for example, a starting point from where people start their tour, but also that might be observed from previous surveys. So we estimate these parameters, and just to show you briefly the results here, we can see first here the visit frequency to certain areas of Kyoto as observed and as estimated, and we compare this thirdly here to an operational case where we only show where we have a simplified model, not considering behavioral aspects. And you can see that our model improved a bit, but it's by far perfect. And I think this is what we find with a lot of tourist models compared to models for essential regular trips, especially trips from residents, where we have much better survey data, is that these models that we can do quite a lot with these type of big data, but still there is quite a lot of uncertainty because of those I would argue because of those effects, such as authenticity, such as these dynamics that are very difficult to capture. Now, importantly, we can use this information to explain tour patterns. We cannot just observe them, but we can explain tour patterns. We can, for example, now develop scenarios if we would change the travel time between certain in certain aspects of the city, such as, for example, here the Sanju Sanrindo Temple. From where and to where would we expect people to travel if we change some of the features of the access to such an area? Finally, in this research too, we use the aforementioned Wi-Fi data. I show here the Higashiyama area of Kyoto, and where we installed 20 sensors, and these sensors collect the anonymized MAC addresses of mobile devices trying to connect themselves to Wi-Fi routing, to establish basically a Wi-Fi connection. They do that even if they're already connected. Your mobile phone sends out this regular probe request, as it's called. This gives us very rich data. Of course, a lot of mobile phones provide just randomized MAC addresses, and then they're not very useful. But for example, here we found that we have 90,000, roughly 90,000 MAC addresses that we can observe at least twice. And of course, the longer the string, the more useful it is. So I need to keep the time short here. And I just want to very briefly explain what we're doing with this data. We embed them in a so-called recursive logic modeling. Again, we use here the point of interest near that we find between two sensors to explain the route that people take. So we want to find out if these points of interest can actually explain if people are more likely to travel to a certain next sensor in the area. We use for this the so-called, as I mentioned, the so-called recursive logic approach. I refer here to a very seminal and very seminal paper by Foskarau and his colleagues. And the basic idea is this is similar to a Markovian approach. So in comparison to the previous research that I showed, we now don't have to estimate the whole tourist tour in once. We just estimate the utility of visiting a next link, given the utility of the link and given the expected utility of the downstream node from where I would travel on to my destination. So we estimate this model. And our innovation here is that we say, well, we, instead of building a very complex, large time space network, we just introduce so-called stay nodes. With these stay nodes, we want to estimate the attractiveness of a person staying on a link for a longer time than it would take to travel just directly between the links without making a break. So if a person stays longer than a predefined threshold, we say he stays on the link, and we would presume that the number of POIs and that the type of points of interest that we have there actually would provide an incentive to stay longer on the link. And for the incentives, again, we use map information, and we categorize them here in these touristic areas into sightseeing and food and shops. So just to show you briefly some results, as you can see here, we don't find positive signs for these different POIs that we observe, and especially if people stay. So we confirm our expectations, and we can show now how much a sightseeing point of interest, and this is now we have to call this an average point of interest, sightseeing point of interest encourages people to take a certain route. And yeah, so the signs here are positive, and they're especially positive for stay links, which, as I mentioned, shows the attractiveness of people to actually remain, to stay, to enjoy the area. In current ongoing research, we extend this to the whole of Kyoto, where we have a second experiment where we've installed sensors throughout Kyoto. Results are this is still ongoing research, but what I do find, what I can say, what we do find is that the pure attractiveness given by ratings as well as the number of reviews that are submitted by people visiting these places can explain the amount of traffic that we observe at these centers. So to conclude, well, I hope this talk could raise some interest and bring some discussion points. I might have been too brief in some of these aspects, but I wanted to show here you an overview and some ideas that I believe are important within this discussion. So in summary, estimating leisure and tourist trips is a key challenge, requiring consideration of abstract concepts such as I mentioned here, authenticity. Due to COVID online life, less constraints mean travel patterns become even more diverse, and we need to consider that also in a post-COVID society. Observing patterns is possible, explaining tourist choices is difficult. We show the potential of map and crowdsourced data about points of interest, but there's certainly scope for further improvement. And with this, I want to conclude. I want to thank you for your attention, and I'm looking forward to the discussion. Thank you very much.
네, 감사합니다.
Thank you very much.
역시 슈메커 교수님
Professor Shumeko,
인상적인
very impressive lecture once again. I truly appreciate your great lecture.
교토에
I've been to Kyoto before. Kyoto is very attractive place, and I believe at the time there were a lot of tourists, but COVID-19 once again hampers visitors coming to Kyoto, and same applies to Korea as well. So it is really regrettable to hear that. However, new pattern, new kinds of leisure tours are appearing, and I'm sure that we can understand about the attractiveness of the city once again. Maybe this crisis is giving us new opportunities.
자, 그러면
So, ladies and gentlemen, we just heard the keynote speech by two speakers, and we'd like to invite them virtually. So, Professor Kunto Costa and Professor Shumeko, can you hear us?
Yes, thank you.
Thank you. Yes.
예. 아마 제 목소리가 두 분
Probably you are listening to me through interpretation service, and
이렇게 먼 거리로 서로가
because we are apart from each other, maybe there might be some delay between us. So please bear with us, especially for the audience who are watching us on YouTube. Please bear with us with a little bit of delay. Let's just share greetings across the Pacific Ocean. Say hello.
Hello, yes. Wish we could be there.
And hello from not that far, only a small ocean we have to cross to Japan, but yes, so thank you for having me here.
예, 반갑습니다.
Great to meet you and see you again, and it's pretty early for
상황 속에서 또 코로나로 인해서
Professor Schmecker, and pretty late for Conto Costa, and
어렵고
we have some difficult situations due to COVID-19, and nevertheless, we are gathered here to talk about some urban issues in order to find some suggestions and solutions, and it's a great opportunity. Even if it's remote, we can share our wisdom and opinions, and technology is the factor that enables us to do this all.
잘 들었습니다.
Thank you very much for your keynote speech.
차에도 불구하고 또 코로나와 관련된 이런 어려움에도 불구하고
And despite our time differences and some technical difficulties connecting you remotely once again, we would like to appreciate for your attending.
우선 본격적인 토론을
Let's dive into our discussion, but before that,
일상이라든지 또
probably we would like to hear from
상황이 어떻게
Professor Contocosta regarding what's going on in New York, regarding some COVID issues, and it is a great opportunity that we can hear somebody from New York live, and maybe just to have greetings for our audience and just share with us what is up to in New York, and followed by Professor Schmecker maybe to discuss what is happening in Kyoto.
콘토코스타 교수님부터 먼저 말씀.
Professor Contocosta will go ahead first.
Yes, thank you. Thank you again for the invitation to join you in this important forum. So coming from New York, as many know, the United States is facing a number of challenges in its response to COVID-19. New York, as a major global city, has also faced its challenges, especially back in the spring last year, when there was a very strong first wave of infections. But the city has responded as it always does to challenges and responded well, and has done a good job of controlling the pandemic, controlling infections, through some rather traditional public health measures, face masks and social distancing measures. But right now, of course, is another difficult time for New York in terms of increasing infections. I should say that our work has recently been funded by the National Science Foundation to study using geolocation data to understand patterns of social distancing and exposure risk across the city, to better understand localized and measures of risk, and also ways to introduce targeted, so neighborhood by neighborhood interventions as hotspots occur. So that work involves almost 2 to 3 million unique devices across New York City, and has really been important in understanding the disparities of risk and health outcomes across New York, because New York is very much a city of neighborhoods, and the health effects and the outcomes of COVID for different neighborhoods vary dramatically across the city, and very much so in relation to the income of residents and other factors that we see these kind of socioeconomic disparities begin to emerge. So, of course, we're optimistic that we will, be able to kind of move past this now that vaccines are on the horizon. But it has been interesting to study how COVID has spread across the United States, and how it spreads even within an area like New York City. Thank you.
네, 백신도 좀 개발이 되고 좀 조금씩 나아질 수 있었으면 좋겠습니다.
Hopefully, we will have a better outcome after the launching of the vaccination. Professor Schmecker?
Yes, thank you. Compared to, well, especially the US, but also European countries, the situation in Japan in terms of COVID has never been that severe. And partly it's a mystery to me. Partly, I guess, there is a natural social distancing. And I mean, mask wearing is something, of course, that people do anyway, often, especially in the winter month. There is though a third wave now. There are about 2,000 infections per day in the whole country. And as I mentioned in my talk, there is no these controversial topics at the moment of these go-to campaigns, so encouraging people to actually to travel and to go to restaurants. And there's actually even today was some of the newspaper headlines where if this should be continued, and that's a bit controversial topic here at the moment. No.
I believe that Japanese cases are quite similar to that of Korea. So the quarantine measures taken by Japanese government could be quite similar. We are watching carefully what they are doing.
자, 그러면 본격적으로 저희가
So let us kick off our discussion in full-fledged manner. Around, well, let me see, a certain time is allocated to us for our discussion. And let me pose a question to both of you. And please, both of you answer that question. I'd like to hear both of your views. And also, I will pose questions to each one of you in relation with your keynote speech.
질문에 대한 부분들을 좀 고민을 해보고
I've been thinking about what kind of question I need to pose, and I believe that the audience who are watching might have the similar curiosity or similar questions, so let me start that. And also, we are receiving questions in a real-time basis, and we have this chat box or YouTube box. If you have any comments, all the participants joining us virtually, you can write down the questions. I can read that to the speakers, and we can also invite them to make a comment back.
우선 제가 강연을 쭉
So, upon listening the presentation by two speakers, the thought appeared in my mind. Technology is rapidly changing. New technologies appearing. We need to come up with a new urban planning and also the urban management policies, which are also changing. In the past, things that were impossible to think about, we can do that because of the information that are available to us. So, information-based policy making is a new trend that we are experiencing. And with the arrival of the fourth industrial revolutions and smart technology, we are able to manage our cities in a better way. And COVID-19 is giving us another crisis. But once again, we are managing our city in a new way. Looking back, well, looking our 100 years of the history of the city development, the way we plan the city, and also the way we manage our cities. Based on that, I believe that something that took more than 100 years will be happening in less than that time. So drastic changes will take place in a short period of time, especially utilizations of the big data and AI. A new urban science management and urban planning will happen, and also a new way of making policies will also appear in the futures compared to the traditional way of coming up with a policy. What kind of differences will there be? So I'd like to hear your views, the traditional way of making policy for the city and urban planning with the current one. So start with Professor Konto Costa.
Yes, thank you. And a really important question and a very difficult question as well. So we are seeing incredible transition and advancements in technologies, both in terms of hardware technologies, thinking of cell phones and the proliferation of cell phones across the city, for instance, and across every resident has one now, to data technologies in terms of the ability to process and manage such large amounts of data incredibly efficiently and quickly. So, this is a kind of fundamental challenge of developing what it would be a new urban science. Is how do we bring together the more traditional ways of developing policy, the important ways of and qualitative ways of understanding a city's needs and residents' needs and developing good policy with this incredible fire hose of information that we now have. It's really beginning to see how we integrate the two has become a really interesting and a really fascinating kind of problem if you're interested in urban planning and urban policy. So there are a number of things that I see that that are starting to occur and that are kind of necessary to occur for this transition to happen. One is very much around training of the future city planner. And so data science, computer science, technology skills are going to be a core necessity of the future kind of urban policymaker. And that, of course, creates its own need for universities and other institutions to be able to develop that capability. And so then another one that's really key here, and gets back to something I said in my presentation about state of the art versus state of the practice, is how do we translate all of this information that we're able to gather? How do we process it and translate it in such a way that we can make better decisions using that information, and that we can communicate this information to a broad audience and make them or help them to understand what all of this artificial intelligence, what all of this large data or big data might actually be able to tell us, and how it might help us make better decisions going forward. And so I think those two components are really kind of key to this. And I think a third piece is, how we make policy, at least historically, it takes a lot of time. It takes time to develop a new policy, to implement it, to see how well it is working. And now with these new data sources, that process can be accelerated quite dramatically. So we can think about innovation in urban management in a way that we think about innovation in new technologies, in innovation in electric vehicles, innovation in other types of industries. We should be thinking about how do we integrate kind of this rapid innovation into a process that really requires a lot of patience and thought, that requires a lot of engagement with residents and with citizens and the public to develop what will eventually be kind of effective and equitable urban policies. Thank you.
네, 감사합니다. 시모크 교수님.
Professor Schmock?
Yeah, thank you. I think Professor Conta-Costa already made really important points here. I would, I agree, and I would add that, well, the main benefit, of course, we have through big data is that we can now actually understand many of those complex interactions that we couldn't see before. I mean, in my field, in transport, we can see impacts in one part of the city, how it would affect travel patterns in another part of the city. We can think about that also for over multidimensional networks, how these affect each other. So we can build now a huge amount of scenarios, and so working here also with some of the AI group, we can make detailed scenarios of how our cities will be like in 2050 in terms of economy, in terms of population. But at the same time, we must make sure that I think this is the task for us as researchers, that for one, some explainability of these models remains, that we don't just present these are possible scenarios, and that we will communicate the amount of uncertainty that is associated with all these. Because in some sense, these data in itself and the data availability to people itself creates a new source of uncertainty. So it creates these fast trends that we didn't have some time ago. In my talk, I referred to this ramen shop example, but I think in many cases we have that behavior nowadays is also changing much faster. So policies become better, but also people react to it faster. And there is so we must be careful in how we use it. And connected to that, I would say this, many things remain just so complex that we have to keep sometimes maybe at the qualitative level, and we should not forget that. So to keep the history of the city in a place, and how to quantify that with data is extremely difficult. And so to find the right balance in how we use AI and how we keep traditional methods that are good because they are based on the long-term knowledge of the city, that's a big challenge as well, I think.
네, 감사합니다.
Thank you.
실제 저희 나라 이제 서울 같은
In fact, in Korea, for example, let me take an example from Seoul. New technological innovation is applied to some urban policy making to create some solutions.
빅데이터 포럼 같은 경우에
So, for example, this forum of Seoul Big Data, this is Seoul City government-funded forum in collaboration with the institute and universities in order to actively respond to social needs.
빅데이터 포럼을 매년
And that's why we've been hosting this forum each year, and we plan to continue. And as Professor Schmecker mentioned,
그냥 일회성으로 참여하는
I think it's a great idea to re-invite the participants from the previous forum so that we can continue developing some urban issues and compare some differences between now and then. And I believe it's also very important to continue our wisdom sharing and insight sharing. And I'm sure Professor Conto Costa will be re-invited for our forum in order to enlarge the scope of urban-related science and issues for better information sharing.
분명한 강점도 있는
Yes, we have some advantages of data utilization by processing and enhancing the quality of data.
긍정적인 메시지를 얻어내는
We have some positive outcomes and results, which is not easy but rewarding.
지원이 있어야 된다라고 생각합니다.
It requires also technological support.
대도시 뉴욕이라든지
Cities like New York or Kyoto and any other big cities like Seoul
운영을 한다라고 하는
require
수많은 이해관계자와
a lot of stakeholders discussion for decision making and policy making, and in here there are some social impact and economic impact which we concern. So big data and urban management by utilizing big AI should have some tangible and fruitful results in order to provide some useful services for the general public. To do so, we need some considerations. We have some considerations. So maybe in such areas, this is related to urban science and probably goes beyond urban science. So in that context, let's say we will continue to utilize such technologies and improve any urban policies. Maybe I would like to hear more about that. Maybe I will start from Professor Schmecker this time.
Sorry, could you repeat exactly your question? I couldn't fully get the
In a broader context, we talked about newly developed and advanced technology for urban management. So maybe it's still in the same context, but we have some advantages and disadvantages which we need to compromise, and maybe there are some processes and consideration that you can suggest to compromise this advantage and disadvantages. So as you mentioned before, big data and the reliability of materials are important, and some difficulties and obstacles regarding policy making, maybe that's in line with what you just mentioned.
너무 어려운 질문을 드렸나요?
Maybe it's too difficult questions. So in urban planning, so using technology, what are the merits and demerits?
What are the okay? I mean, I think, of course, the merits are that in sometimes we didn't have data for many things before. We couldn't quantify things. And as also Professor Conta Costa mentioned, there is, of course, a whole lot of difficulties in terms of how we need to train our people how to use these data in terms of privacy issues, how we use them. So these are all significant demerits as well. I think it really depends on what specific application we think about. It's a very difficult question to answer, I think, in this general way. Maybe Professor Conta Costa has some more thoughts.
Yes. If I may, I think Professor Schmoker did an incredible job articulating, the one of the main benefits of thinking about urban science and all of these data, which are the ability to understand these complex systems and these complex interactions and understand resident behavior and the behavior of people who live and visit and play in cities. The things that I worry about, I think, are twofold. I see as the biggest kind of challenges or concerns. One is around the issue of fairness and bias in algorithmic decision making. So how artificial intelligence tools are used to make decisions, how those tools often exist in black boxes that are very difficult for non-specialists to understand. How those models may produce outcomes that are unfair for certain subpopulations of or parts of a city. Those kind of things, I think, are significant challenges in making sure that we're combining decision-making processes that have a data and artificial intelligence component, but with human intelligence, with kind of people on the ground who understand these processes, who understand the needs of different communities, who understand the realities and the challenges that people face day to day. So we can't just hand everything over to AI, and that will not produce a city that I think any one of us wants to live in. The second challenge and the second concern that I have, as I mentioned in the talk a little bit, was this issue of privacy. We're starting to see widespread use of geolocation data. I do this in my own work. I know that this is being done in many cities, and many researchers are using this type of information. The concern is, who controls that information? How much do I, as a resident of a city, get to control how that information is used? Those kind of things, I think, are perhaps the bigger downsides of where the future may take us if we rely too much on data, too much on technology, and kind of shift that responsibility that we have to the residents of the city to kind of honor that privacy, to honor those kind of concerns, and to develop a more equitable and fair place. So those, I think that, how we address those as a collective community over the next 10 years, for instance, is really going to determine what the city of the future is going to look like and whether it's a place that any of us would really want to live.
And if I just may add to that, I think this is really, was just expressed as really a challenge to all stakeholders in here, right? So it's for the cities, how to use the data, and for us as researchers as well, in terms of how we really explain the data, and then we really show, well, these are the limits, what we can do. This is something new that we now can show you as quantitative results, but these are the caveats, and this is where you need to be careful. So I agree with that. Yeah.
네, 감사합니다.
Thank you. Then I would like to present individual question to each of you. First, Professor Conta Costa.
저희도 이제 어반 인포메틱스라고 하는
When it comes to urban informatics, it is fairly new, but we are highly interested, and we've been collecting a lot of information about urban informatics. But in terms of the concept, and more details we're not sure whether we understand fully compared to the existing urban management and informatization or informatics. I would like to hear more about urban informatics from you.
Of course, thank you. I mean, urban informatics and urban science are very, very similar. The way I tend to think about it is urban informatics is much more around the computational methods and bringing big data analytics to the problems of the city. So it's very much a technical discipline in thinking about bridging kind of data science with urban problems. Urban science I see as a broader in scope of kind of a broader endeavor, in the sense that fundamentally we're trying to develop new ways and use new tools to understand the form and function of the city. So to understand those complex interactions between social, economic, environmental, physical infrastructure of the city and resources of the city, and of course, how people interact and benefit from those different infrastructures. So urban science I also see as perhaps much more about a new way of approaching kind of the urban problems, where we think about and take lessons from, say, physics or other sciences, or even if we look at medicine and how we've seen such rapid advances in vaccine development, for instance. Now, this took an incredible amount of resources from multiple disciplines, working together with the latest technologies to be able to take a process that would normally take 10 years into 10 months. And so I kind of think of urban science is somewhat similar to that in how do we take different disciplines, bring them together with the latest technology, the latest tools, the best data, and connect them with problems that people really care about and that are really important to the future of our cities. And so these are problems of sustainability, of resilience, of social equity, of making sure that we're improving quality of life in cities. And it's about bringing the best minds together to figure out how to do that.
네, 감사합니다.
Thank you very much.
다음은 우리 시메커 교수님께
Next question goes to Professor Schmeck. Based upon your presentation, let me pose a question.
실제 저희도 이제 코로나 이후에
After COVID-19, what will happen? What kind of changes will take place regarding people's leisure activities and tour, especially utilizing big data, leisures and tourism activities? We need to actually predict what will happen, and based on that result, we need to come up with the policy for the city. So can you share with us what kind of benefit can city government can enjoy in using big data in predicting and estimating what will happen to the leisure activity tour? We can also apply for the cultural activities. We can also apply in various sectors. So can you elaborate?
Thank you. Yes. Okay, I think we have to start by saying that people will return, and that people will, there is a need for travel. People want to go out, and the more we sit in front of a computer, the more we have the need also to go out then in the afternoon for something different. But there is, as I try to kind of explain in my talk, I see there really this conflict. In one sense, people will return to the popular places. Popular places will remain popular. On the other side, we can have more diversity in terms of when, where, how people travel. There are less constraints. And so encouraging this diversity, even though it's difficult, but that will be one of the main challenges, I think, for a post-COVID world. So encouraging that and maintaining that. And I think we do have chances. And well, what are our possibilities to do that? Well, one is, I think, just keep something that we've kind of been highlighting for a long time, is kind of keep encouraging local development and trying to make sure that the local environments are actually attractive, so that you don't have to go to the most famous place in a city. I think another thing that maybe people start to learn from this COVID crisis is actually the value of going out and the value of being able to travel to the city center. Once it's gone, you realize that how it's missing. So maybe because of this, for example, in introducing reservation systems, maybe even pricing for areas, those kind of ideas were much more difficult to justify before COVID, and there might be now a much better chance to think about this, so to have wider use of reservation systems for a wide range of facilities might be much more acceptable now. And I think the third point I want to add is maybe what we learned. Getting to big data, what we can learn through big data is really an integrated perspective of not just, for example, one site or one shop, but to think about an area. So to think about how the combination of different places actually encourages people to come and to come again. I think this is really something where big data comes in, where it shows us, okay, this all together provides an attractiveness, and this all together provides the motivation for people to travel. And so there I see really how our analysis of how people move and where the locations are and how this can work together to define attractiveness of areas.
예, 감사합니다.
Thank you very much.
교수님 답변 주시는 동안에
While you were answering my question, I guess we have a question from the audience.
박사님 리서치 결과를 공유해 주셔서 감사합니다.
The question goes,
장소와 방문자가
thank you for sharing your research.
복잡한
So it is very
만들어내고
complex network by having the places and visitors. So if there are two approaches, place-based and human-based, which one is more useful and efficient for big data analysis? As like you categorize places, is it possible to categorize visitors? So that was the question from our YouTube audience. Could you elaborate to answer that question?
Good question. Difficult to answer. I think, ideally, I think we need to combine it, right? Place-based and human-based, to consider the characteristics for specific places. And then if we think about leisure trips and tourism trips, of course, it's a very diverse group and very diverse motivations of people. So we should use information about the people itself, and we should use the information about the place itself, and to combine them in an intelligent way. And I think, again, this is what big data can do. We can combine all these different big data sources. And often sensor data, I talked about Wi-Fi sensor data and so on. They don't give us much information about the person itself, but maybe we can infer it. We can infer it from how they have been traveling before, or from in combination with previous surveys, for example, that tell us, okay, those kind of people tend to be at those places. So I think we can mix the human and the place-oriented approach together. Okay. I hope I at least half answered this question.
네, 잘 알겠습니다. 자, 그러면 다시
I think it does answer the question. Now let me go back to Professor Contocosta.
발제해 주신 내용에 보면은 굉장히
According to your presentation,
어떤 관점에서 이 코로나19
there's a broad concept and the perspective of the social justice, sustainability, and climate change issue by utilizing big data, and in the course of the analysis, and you've introduced various cases in New York. In fact, in Seoul,
이슈들과 연계한 도시 정책을 개발하고
we also develop some urban policies and development. So if you would like to add some suggestions for Seoul to develop and improve further of urban policies.
I'm not sure I could give suggestions on ways to improve. I think the Seoul metropolitan government has done a very impressive job integrating data technologies into its governance. You could see what's happening with COVID in Seoul, which is very different than the New York experience or any major city in the United States. And similarly with sustainability and climate planning. Now, so I don't have any suggestions or recommendations for what Seoul should do. But I think what is very exciting and another component of having all of these new data is that we can look at comparative studies, right? We can look at how does New York and Seoul, can we understand policies and evaluate policies in the two different contexts so we can learn from one another using very similar data resources, right? And so I think there's a lot of opportunities since we are, we're both very large metropolitan areas. We both are very dense metropolitan areas, similar challenges. I think that there's many opportunities to look at the data that are available and try to work together to actually find solutions that would work in both places. So that to me seems very promising.
예, 감사합니다.
Thank you.
심메코 교수님께도 간단한 질문 하나 더 드리겠습니다.
Next question goes to Professor Schmeck. COVID-19, in relations with the climate change, definitely there will be a huge impact on tourism and leisure activity. We expect a lot will change. Seoul Metropolitan City Government is trying to predict the future. What kind of response or policies do you recommend to Seoul City Government?
Yeah, again, a very, very difficult question. I also have to say I'm not that expert on Seoul that I can give very specific recommendations. I mean, I think what I see Seoul is also doing extremely well is, for example, in local, from my visit last year, so from a number of these local transport projects around the station area, how it's been rejuvenated and how it encourages people to spend time actually walking around there and so on. I think these are very important projects, and especially maybe after COVID also, where this kind of can ensure how that people also are distributing over a wider space. Yeah, as I also said, I fully agree. I mean, tourism will return. Vaccines are on the horizon, but when? Yes. How quickly do foreign tourists return? Okay, that's a big question. But often then domestic tourists pick up the gap. I think that's what we somehow, for example, observe here in Kyoto, that yes, foreign tourists almost collapsed, but there's a huge domestic market which fills up the gap. So I guess thinking about I put it in my presentation as this idea of demand equilibrium. Then I think the demand will be filled, and we need to think about the tourism concept, as I call it, maybe a sustainable concept where actually for some fewer tourists they enjoy it more and actually bring in almost the same revenue. I think that should be the focus of cities now, and to try to use this gap that we have in foreign tourists, but slowly, especially domestic tourists coming back.
예, 감사합니다.
Thank you for answering. Within the limited time, we try to cover a lot of topics.
지금 또 말씀 주신
And while we were talking, we have some questions for Professor Kontakosto. As we reorganize the question, we will deliver it to you later. So other than the official session of the forum, we usually have networking and over some dinner and some tea. And last year, as Professor Schmeck knows, we had some meaningful discussions in and out of the official forum. So we really hope to see you again on the offline session next year. Do we have time for extra questions? Probably we don't have enough time for more questions.
여러 가지 앞으로 또 이제 이어서 다양한 세션.
Well, we will continue our networking and we will have more presentation from
참여하실 기회가 있지 않을까 하는
different sessions onward, and you will have more opportunity to listen and share some insights. And despite these difficulties, once again, we would like to extend our gratitude for your presence and presentations, and we urge you to continue our network between New York, Seoul, and Kyoto in order to wisely tackle urban issues by collecting our wisdom. And that wraps up our discussion. Thank you very much.
Thank you very much.
Thank you.
Thank you very much for joining us today. 고맙습니다. 이렇게 좌장을 맡아서 함께 해주신 이희정 교수님과
That was Professor Lee Hee-jung and our keynote speakers. Thank you very much for your participation, and it was a great opportunity to listen to various issues related to urban crisis. And that wraps up the first session, the keynote session. After lunchtime, we're going to continue our next session starting from 1 p.m. Korean time. Please stay with us for more sessions. That was the first session of 2020 Seoul Big Data Forum, co-hosted by Seoul Institute of Technology, Seoul Digital Foundation, University of Seoul, and Seoul Institute. And you can join us virtually on YouTube, both in Korean and English channel. And we urge more enthusiasm for your participation.
First of all, thank you very much for moderating the session, the Professor Lee, and also would like to give our special thanks to overseas speakers for your active discussion during the session 1. It has come to the end of the first session of today's forum, and we'll begin the second session at 1 p.m. Please give us your interest to the next session. Thank you very much for your watching. 함께 해주신 여러분께 다시 한번 감사드리면서
Thank you for watching once again, and that wraps up our morning session. That was Moon Sori for your emceeing. Thank you. If you can hear us, can you please wave your hand so we know you can listen to the interpretation? Please, once again. If you can hear this, could you please wave your hand so we know that you can listen to the interpretation service? We're testing interpretation service. Wave your hand if you can hear.
Hi, everyone. My name is Jun Hyo, a professor at Yonsei University. I feel being honored to moderate this wonderful session entitled Urban Data Science for Endemic Responses. So we have quite a few distinguished scholars from different country and from domestic country. And in this session, we are going to discuss about what it can do with urban data science to fight against basically COVID-19. And at the same time, hopefully we can also discuss not only technical issue of how to apply data science for fight against COVID-19, but also discuss about some more issues like governance, at the same time, some even philosophical issue, because data science is somehow associated with privacy versus public benefit. Throughout this session, hopefully we can share our experience. At the same time, we can tackle potential problem in the future, for the future potential pandemic responses again. So we have a list of distinguished scholars in urban data science. And the first presenter is Professor Syed Shabi. He's the department chair of computer science at University of Southern California. And he has numerous honors, such as fellow IEEE and ACM, at the same time president of ACM SIG Spatial. Unfortunately, due to electric outage for this time being, so he's going to present throughout his video tapes. So even though he's not presenting on live, hopefully all of you welcome Professor Shabi for his presentation. Professor Shabi.
Hello, I'm Cyrus Shahabi, and I'm going to talk about our recent work on a platform called Pandemic Risk Evaluation Platform, or PrEP for short. Before that, let me start by defining some terms. First one is contact tracing. This is something that everybody is familiar with these days. This is a process of interviewing a positive case, a confirmed subject, in the case of a contagious disease such as COVID-19. And the purpose is to find all the people that the confirmed subject was in contact with in the past several days. And once you identify those contacts, you might ask them to isolate, for example, or get tested, or depending on the policy, you might force them to quarantine themselves. This is actually a very well-known technique, been practiced for a long time. It requires human interviewers. And one of the main advantages of this approach is that you not only identify contacts, but you can also identify hotspots, where the areas that you see a lot of spread happening, or in general, you understand the behavior of the spread. Disadvantage is that this is very time-consuming process because you have human interviewers. It sometimes takes 2 to 3 days, for example, to inform the contacts. It can't scale if there are too many positive cases. And that's why usually this approach is effective at the onset of infection to stop the pandemic, not while the pandemic is already in progress, because there are too many cases. Also, it relies on the subject's memory to remember the people or the locations that the contact happened. It cannot identify strangers that were in proximity because the person doesn't know them to identify them. And also, I will talk later, it's difficult to capture environmental and direct transmissions with this approach. Now, for COVID-19, let me also explain a couple of terms. The first one is the generation time, which is the time it takes from somebody who's infected to pass the infection to somebody else. It is by analyzing the data of Wuhan. This is basically an average takes 5 days. And then the incubation period is a time between when you get infected and you see symptoms. And that's also another 5.5 days. And in the case of COVID-19, a very important feature is that you can be infected and transmit the disease, but you're still not symptomatic, so you don't show any symptoms. And for COVID-19 contact tracing, sometimes you when you interview the people, you go back to the last 10, 14 days and try to identify the contacts. Now, because the case is asymptomatic cases or pre-symptomatic cases that they can transmit disease, this paper, which was published in April 1st, 2020, you look at the data and made the case that traditional contact tracing latency, which is like 2-3 days, is not going to be effective. That graph shows basically because on the x-axis you cannot identify all the cases because some of them are pre-symptomatic, so you don't know they are sick. You cannot immediately identify their contacts. So given that a small percentage are isolated, among which a small percentage are a small percentage of their contacts are identified, in order to be in that green zone area in the figure, where is basically the area that reproductivity rate is below 0, where we want to be, because the spread would stop at that point, you need to be able to inform the contacts right away. Zero latency, and that's what this graph is about, and that's why traditional contact tracing approaches may not work. So what do we mean by digital contact tracing? What's common is basically using mobile phones to identify contacts rather than interviewing folks. However, there are different approaches. The most popular one that we call here co-location approach is based on the approach actually used by Apple and Google, where they use the Bluetooth signal on the phone to identify if somebody is nearby. The figure shows, for example, that if two people, Alice and Bob, are close enough that potentially can transmit the disease, their phone is also close enough that using the Bluetooth, they can exchange a token or a key. Now, if later Bob is sick, and it's a confirmed case, with his consent, we might basically upload all the keys that Bob collected on his phone in the past, say, 14 days, and then publish them. And if you see your keys in that list, that means that at some point you were in contact with Bob, who was a confirmed case, so you may want to go get tested and so on. This approach has the advantage that the latency is pretty much 0, so immediately you can be contacted by checking that shared database of keys that are released. It does not rely on memory recall. Everything is based on the phone. It can scale very well. It can identify and inform strangers who are in proximity as long as their phone was in proximity. And it's also a very private approach. It has no information of the location of the contact, who was in contact with whom, and so on. However, the main limitation of this approach is that, first of all, it cannot detect environmental transmission. So if, let's say, you're in an elevator and you sneeze or you cough, and then you leave the elevator and somebody else comes into that same elevator 2 minutes, 3 minutes later, they still have a chance to get infected. However, the mobile phone is long gone. So that sort of infection through environment or even through objects, if you touch the elevator and somebody else touches the buttons, those are not detected. It also cannot detect indirect transmissions. Here in the figure, we show that, for example, Alice might infect Bob, and Bob, while pre-symptomatic and hasn't been informed yet of Alice's contact, might infect David. Now, when with this approach, only Bob will be informed, and David would not be informed. Was an indirect. And this is actually, indirect transmission is important to capture for asymptomatic scenarios that we discussed. And we'll talk later about an approach that would capture indirect transmissions. But most importantly, the problem with this approach is that it has a lot of false positives, because people might be not close or have obstacles so that they cannot transmit the disease, but their phone is close enough that their Bluetooth can see each other. So because of this false positive, and because this is a fully automatic end-to-end system that is based on alarms, that you get notification when you are in proximity of somebody with COVID-19, at some point you might get overwhelmed with a lot of false alarms. And this is not how we usually use apps, right? So if you see an app that keeps notifying you, you might actually turn the notification off. And this is exactly what may happen with this approach, that you become numb to the alarm. But another actually major limitation of this approach is that because it does not collect any information about the location of the contact, it cannot be used to detect hotspots, it cannot be used to model the spread, it cannot inform policies, just basically for pure contact tracing. So here is a summary of the co-location approach, the advantages and disadvantages, so that we can compare with the other approaches. Now, the second approach, which we call a location approach as opposed to co-location approach, is that we use the mobile phone to actually record the location of the confirmed subject. So we have a trace of the location of the confirmed object as well as the location of the traces of other objects, other subjects, other people. And as you see on the right, the red trajectory is the traces of a confirmed location. It says which of a confirmed case. It shows at which time they were at which location. That's UC. Now, if you look at the case of a U1, which is the typical case, you see that, oh, the two locations are close enough at time T2. Therefore, that's when the contact happens. So you can capture the direct transmission, but you can also see the case of U3, which you have the trajectory. U3 never met UC. However, U3 did meet U1 after enough time passed from the time that U1 might have got infected from UC. Therefore, you can also detect this indirect transmission at time 3 for U3. And then the final example is U2, which is basically the case where they never meet at the same time at the same location. However, U2 was at the same location as UC at time T4. And even though that was not at the same time 3, but because it was at time T4, later on in the example I gave before, the elevator example, you can detect that case and inform U2 as well. So these are basically main advantages of this approach, because it can capture environmental transmission, it can capture indirect transmission, it still alleviate memory recall and scale, and I'll talk about this later because it can be done fully automatically. It can identify strangers in proximity because it's all based on the trajectories, not based on memory recall. And because it collects the location, it can identify hotspot, and it can be used to understand the spread behavior. So here are the advantages and disadvantages of this approach, as you see. And I guess the challenge here is that either you need to do this automatically, in that case, it might have the same problem as the previous approach, that it has too many false positives. Or if you use this data and put the human in the loop, then you basically cannot improve the latency. So that's one of the main challenges of this approach. So what is our approach? Our approach, as I explained, we call it PrEP. The idea is this. So you start with an app, a digital contact tracing app, but it's for a community, let's say for USC campus, for example. It's based on opt-in and voluntarily, so it's private in that sense. It's own, but it also, and I show examples of this, but it also collects more data than just the co-location data. So in addition to Bluetooth and co-location, also collects location traces and durations. So it's a combination of the previous two approaches, if you may, a hybrid approach. And as a result, I'll show you that it actually results in less false positives, detects both indirect and environmental transmission. But instead of being an alarm base where you either get an alarm or not, it's based on a risk score, where the risk score is calculated. Think of it as a real number between 0 and 1. And based on the risk score, you basically, every time you look at your app, you can see what is your risk score. And it's not alarm based, therefore you're not going to get numb to alarms. This is more consistent with how people use apps. You check your app, you see what's your risk score, and if the risk score is above, let's say 0.8, you might want to go and get tested. We have a couple of complementary toolkits with this, so it's not just the app. We also have some sort of a dashboard for health practitioners so that they can basically use the data collected and address these issues of memory recall, scale, and latency. I'll talk about this a little bit later. It does support privacy-preserving computation, so it's private, and you can also use this data for other purposes, like, for example, to identify risk scores of location or inform this spread models. So here is the end-to-end system. If you want to remember just one slide from my talk, this is the slide. This is the PrEP platform. So let me start by looking at the app. So the app down there on the lower left corner is where the location and co-location data is collected. Just follow the black arrows. So from there, you go and you do your spatiotemporal analysis. This is those trajectories that I showed where you can identify direct, indirect, and environmental transmissions. And these are happening behind the scene, but the way that this is accessed is through the health practitioner dashboard that I'll show a demo of it later on. And then the same dashboard can be used to identify the confirmed cases that is stored in a secure location. And then the combination of the confirmed case information and the location information is going into this risk analysis where it calculates the risk score both for individuals and the locations. Now, these risk scores can be passed back to the individual, to the app user. So that's the red arrow going back to the app, but also can be used in some sort of a policy-making dashboard where, as I mentioned, uses the information about the spread analysis to make interventions, and I show you a little bit of that later on. So here is a demo of the health practitioner dashboard. The way it works is that basically you sign in. Let's say you're a student health practitioner. You can add a new confirmed case. So you add the student ID of the confirmed case. As soon as you add it, it does this trajectory analysis behind the scene and immediately identify the people, the cases who were in contact. Then you can drill down and see the list of the people who were in contact. And for each person, you know what was the risk, what was the total duration of the contact, and so on. So these are the people whom you want to inform. And if somebody's missing, you can manually add the contact. You can even drill down further. You can, of course, see the heat map of the contacts and some statistics on the time, but you can drill in and see for each contact, they might be multiple time that they were at the same place at the same location. So you get the information about the duration and the location that each person was in contact with the confirmed case. So now the risk scores that you've seen in the health practitioner, this is how it's calculated. This is based on a collaborative work we are doing with Emory University and UT Health. The idea is that you calculate the individual risk scores based on the risk of the contacted individuals, that other people that the person contacted, the risk of the location itself, the duration of the contact, the location of the contact, the social strength of the contact. So basically, if the two people are relatives or are friends, the chance of the transmission is higher. That's actually how we reduce the false alarms. If there are any auxiliary data available, like the medical records or demographics, things like age and so on, they can also be used to calculate this risk. In fact, we had a paper that we showed that this social relationship from people can also be inferred from this historical trajectory. So if you have that, you can identify the risk score. The location of contacts is actually very important. So if you know, for example, this was at a high-risk location, then you can also use that to increase the location of the individual. And we have a whole paper, it's a whole different talk about how to calculate the risk at a location. But that's something that can be done also. Now, another component was this spread analysis in PrEP. So if you do have, let's say, all this data about where people, about these location traces, and actually we did get this data, real data from this company called Veriset, which provided us with anonymized traces, and we used that for our spread analysis. As you see, there's like, let's assume for each row of the Veriset data, you get the ID, which is a anonymized unique ID, let's say. and you get the XY coordinates and time. So it basically said this person ID was at this XY coordinate at a given time. Now, if you have all these traces, you basically know how people move, and you can build these simulators, where basic spread simulators, where basically you look at, you kind of manually, randomly infect some people. As you see this case, for example, we infected one person. And then as they move, you basically look at the spread models like SIR model that we have on the left. And based on that SIR model, and based on whether two people are at the same location at the same time for the long enough duration to transmit the disease, you start infecting other people in your simulator. So you see that the number of ones increases, and basically once you have this data, you can pass this to your risk analysis model, which basically calculates the risk for each person as well as the risk for each location. So the output of the risk analysis model are these tuples that shows the risk for each person in each individual and the risk for each location. Now, this information can go to your spread analysis model, where here you can have some interventions. So let's say if somebody's risk is if an individual risk is more than 0.8, then stop the movement. Or if the location risk is more than certain value, then you might stop admission of new people. And once you have these interventions, you can go back and look back and see whether the number of infected people, for example, is reduced. So there are a lot of security privacy issues when you collect the location of people. I don't have much time to go into the details, but it's important to basically have all these considerations in place. And we looked at some basic privacy enhancements. So for example, the location traces don't need to be stored in a server. It can be stored on a local mobile phone, and give the user the full control that basically says how frequently I want this data to be shared, what should be the precisions of the location. Maybe I just share at certain location only a zip code, at certain other location the exact lat and long. You can also do this in an iterative process when basically you identify what sort of location you want to share, and if more information is needed, you're asked to share more data. So this is the last slide I have, is basically list all the main advantages of our approach, which, as you can see, it basically is the combination of all the advantages of the two other approaches. It has all the benefits. And I want to end with acknowledging my team who working hard on this PrEP platform. Thank you very much.
Okay, thank you, Mr. Professor Shahabi. It's a wonderful presentation. And so I really like your approach, the PrEP, which is kind of dynamic nature, and keep tracing down and see the kind of different level of risk for individual. And regarding your presentation, we have a few questions. First of all, no matter what kind of approach is used, collocation approach, location approach, or even your PrEP approach, the level of accuracy or kind of reliability is highly associated with positional accuracy, in which we can confirm that two individuals is close enough. So I'm just wondering, first question is about what's the level of accuracy in the US, particularly in the US, while you're applying such techniques for finding out some risk, indoor, outdoor? That's the first question. And second question is about, particularly for your application, that PrEP approach, so how many students or how many individuals opt in to your system? It's a really critical factor. So I'm just wondering how to incentivize to make students opt into your PrEP application. Professor Cyrus?
Hi, everyone. So there are two questions. The first question was, what's the accuracy of location data that can be collected from the phones? So as you know, the GPS accuracy outdoor is between 5 to 10 meters. There was a study, I think in 2019, that showed on iPhones, for example, about 59% of the locations that were collected had the accuracy around 5 meter, and 98% of them had the accuracy of 10 meter. Of course, indoor, there are other methods that you can collect location besides GPS, for example, using the Wi-Fi fingerprinting approach, using Wi-Fi access points, cheap access points, which should provide you 2 to 4 meter accuracy. More expensive ones can provide you up to 1 meter accuracy. That said, of course, if you want to be very accurate about calculating the distance between two people, of course, the Bluetooth is the best as long as they are within 9 meter. And what I want to point out, though, is that some studies on COVID-19 showed that two people might be in the same room with the same air conditioning, but with distance more than 9 meter, but a long duration of time, let's say 3-4 hours. And there's still there were transmissions. So basically, the fact that two people are at the same location and for how long is more important than exactly how far from each other they are. So that's basically my view on the first question. The second question asks about the fact that if your technique is based on people opting in, students opting in to use to provide their location, what are the incentives? So typical location-based apps, as you know, there are a lot of incentives like giving you Starbucks coupons or things like that. However, this specific application actually is interesting because studies showed that people are willing to participate if they are doing this for good, for basically to help other people. And I didn't get a chance to talk too much about the location privacy aspect of this work. That's by itself is a separate talk. However, I want to point out that for contact tracing, it's actually more important that you release your location where you're in public. So, for example, if you're in a private place, you're in a house or with someone that you know, most probably you're going to contact trace yourself. You're going to call that person and say, hey, I got sick, so you go and get yourself tested or isolate or whatever. But more important is that if you're in a public place, like in a shopping center or in a movie theater, because that's where we want to understand the spread, and that's where we want to identify hotspot. And those locations are actually less private. So people are more willing to share locations where they are in a public location, which is actually more important for the contact tracing. So our approach that we have this back and forth iterative approach between the phone and the server to decide what to share at what quality or what accuracy actually works very well here, because on your phone, for example, you do have a very accurate location of yourself when you're in a movie theater, but you may decide for whatever reason not to release it and release the zip code, for example, but then the server can incentivize you and say, hey, if you give us the exact location you were at this time, we can save five more people, and that's an incentive enough for you to say, okay, I'm going to improve my accuracy reporting here because it's a public place and I don't care much about it. So as I said, that's a whole different topic that I can talk for another 20 minutes about the privacy aspect. But that was it, and thank you again for having me.
Thank you, Professor Cyrus. That's a wonderful answer to the question. And we move to the next presenter, Professor Bin Jiang from University of Gävle, Sweden. And his talk is entitled as Spatial Healing, Bridging Space and Place Through the Concept of Holiness. It's a really wonderful title, I think. Professor Jiang, are you ready now?
Hello, everyone.
Hello, Professor
Last
Jiang.
time, in the Big Data Forum, I made a presentation entitled Living Structure as a Scientific Foundation of Spatial Data Science. And this time, I will continue the topic of living structure or wholeness in order to bridge these two different concepts, space and place. Space is external to our body or mind, while place is internal or about our experience of space. The term spatial healing has two different meanings. First, it is about the healing effect of space on people, while the second, it is about the space to be healed, to become living or more living. Because it is experience-based, so place is personal or subjective. Despite the personal or subjective nature of place, there is still a shared notion of goodness among the people. This is probably the key message I would like to convey with this presentation. The goodness of space or place can be measured through the concept of the wholeness or living structure. Living structure can be compared to temperature. Long ago, there was no thermometer, so people had to rely on their feeling to see how warm something is. Now we can use thermometer or temperature to measure the warmness. Now we still rely on our feeling to know how good a space is. But in the future, we may use Beautimate to measure how beautiful a space is. In this presentation, I'm going to talk about the following key points. A good space has a healing or nurturing effect, while the opposite side is damaging to our body or health. There are two different views of space, which are framed on the mechanical view, inherited from the science of the past 300 years. In contrast to the mechanical view is organic view, first conceived by British philosopher Alfred Whitehead and further developed by Christopher Alexander. Under the organic view, space is seen as living structure or wholeness, which is a mathematical structure of our external space. In essence, place is a reflection of the mathematical structure in our hearts and minds. I will talk about two fundamental laws of living structure, scaling law and turbulence law, and I will make it clear why goodness of space is a matter of the fact rather than opinion or personal preference. Research has long discovered that people who just had a surgery can get a quick recovery if they are exposed to some beautiful or natural scenes. This is a pair of landscape and open scene, but the left is more beautiful or more living than the right. This is another pair of mathematical curves, but the left coastline-like curves are more beautiful or more living than the right, so-called curves. Here is a pair of patterns, but the left is so-called fractal structures, while the right is a collection of Euclidean geometric shapes. Again, the left is more living or more beautiful than the right. This is a pair of skyscrapers, but the left, actually the very first skyscraper, is more beautiful or more living than the right. All these pictures in the left are called living structure. Their counterpart to the right are less living or non-living structure. In terms of the healing effect of space, let me add another story. This is particularly relevant with the current COVID-19 pandemic. It was found that some Russian women who exposed to the 1986 Chernobyl nuclear disaster seemed to enjoy better health than those who evacuated and relocated to other industrial modernist buildings. This is an incredible story. The point here is not that nuclear radiation is not harmful, but that the living structure with which the woman has a good sense of the feeling or belonging seems to overcome the radiation damage. To this point, the audience may have some intuition or sense of the feeling on degree of livingness or goodness. Here is a quiz. Between these two paintings, which one is more living or more beautiful? Composition or configuration? Think about it, and we will come back to it later on. Now let's move on. What is a space? Over the past 300 years, there are two different views of space: Newton's absolute space and the Leibniz relational space. Both are framed under the Descartes' mechanistic worldview. In other words, the world or the external space out of our body is machine-like. This worldview has been so dominated in science, in our thinking, as if it were the only worldview, or as if it were the kind of the fact. Under Newton's absolute view, space is considered to be a container. Euclidean geometry or analytic geometry was developed for describing and measuring the Earth's surface, or even beyond. Under the relational view, graph theory was developed to describe relationship between spaces. Current geographic information system was developed under these two views of space, as space is usually mechanistically represented by geometric primitives such as points, lines, polygons, and pixels. Vector and raster formats are two commonly used representations. The thing is that these geometric primitives make little sense in our hearts and minds. The mechanistic model can be traced back to the 17th century. If you want to know how something works, you can pretend that it is a machine. It was because of this kind of Cartesian thought that one was able to find out how things work in the modern sense. It is important to note that the worldview is excellent, for what we have achieved in science and technology is really because of this mental model. However, this mental model is limited, and it has two devastating results. The first is that the I went out of the word picture. The picture of the world as a machine does not have the I in it. The I, what it means to be a person, the inner experience of being a person, just isn't part of the picture. Second, the picture of the world we have from physics, because it is built only out of mental machines, no longer has any definite feeling of value in it. The value has become sidelined as a matter of opinion, not intrinsic to the nature of the world itself. As any inevitable consequences, the goodness of design or art cannot be objectively assessed, or they lack a hard standard for assessing goodness of design or art. The thing is that the worldview is so dominated, as if it were the only mental model of the world, or even worse, it may be perceived as what itself. As a matter of the fact, the real world is organism-like rather than machine-like. It is the British philosopher Alfred Whitehead who first conceived an organic worldview. This holistic organic worldview contains both external space and our internal experience. In other words, we human beings are part of the real world. The great architect Christopher Alexander has further developed this worldview and formulated the third view of space. Space is neither lifeless nor neutral, but a living structure capable of being more living or less living. Let's look at how space is more organism-like rather than machine-like. This is the historic center of the German city Hamburg around the 19th century. It looks very much like the human brain. What I want to stress is that it not only looks like an organ, but also works as a biological entity. There is a common misperception that urban design is viewed as a Lego-like assembly of prefabricated elements. As a matter of fact, a city is an embryo-like growth with persistent adaptation to its surroundings. Amsterdam presents an excellent example how a city is emerged or evolved very much like an embryo. Another good example of living structure is Venice. What I want to stress is that it is not because of the fish-like shape, but some deeper structure that we call it a living structure. Now let's look at what a place is. A place is human experience space. A good sense of the feeling, such as proud, belonging, well-being, and healing, while a bad sense of the feeling, such anxiety, stress, fear, and uneasiness. A good place means a living structure, while a bad place means non-living or dead structure. It is important to note between the living and the non-living, there are four spectra. So here with a degree of livingness, very much like degree of temperature for warmness. To better understand place or our experience of space, we must first understand what wholeness or what a living structure is. To make it clear the concept of wholeness or living structure, let's look at the two papers. One empty paper and the other with a tiny dot. To examine how these two papers differ from each other structurally or in terms of the underlying living structure. The dot is very tiny, but its effect is devastating. It means one is living structure, while the other is dead structure. Why? The introduction of the tiny dot to the paper is able to induce about 20 substructures or centers in terms of the Alexander. The 20 centers, as shown in the slides, are as follows. The paper itself, number 1, the dot, number 2, the halo surrounding the dot, 3, the left and the right rectangle, the bottom and the top rectangle, and so on and so forth. These 20 substructures are not isolated, but form an interconnected whole. From the coherent whole, we see clearly there are far more small substructures than larger ones, not in terms of their size, but their degree of livingness. So it is apparently a living structure with a very steep hierarchy. On the other hand, the empty paper is only with 5 substructures, the paper itself plus the 4 corners. So it has a very flat hierarchy and a very small number of substructures. So it is a dead structure. Having examined the simple example of living structure, now let's turn to its formal definition. It is such structure in which there are far more small substructures than larger ones, with an inherent hierarchy. It is governed by 2 fundamental laws, scaling law across the hierarchy levels and turbulence law on each of the hierarchy. Note that it is not more small than largest, but far more small than largest. The notion of the far more small than largest does not occur just once, but occurs or recurs multiple times. Scaling law is also called spatial heterogeneity. There are far more small things than larger ones across all scales, ranging from the smallest to the largest in geographical space or the Earth's surface or any living structure. Importantly, the scaling of far more small things than larger ones recurs multiple times rather than just once at different level of scale. Turbulence law is also called the first law of geography, and it is about spatial homogeneity. Everything is related to everything else, but near things are more related than distant things. In essence, nearby things tend to be more or less similar or related. These 2 laws are complementary rather than contradictory to each other. One on heterogeneity, the other on homogeneity. One on interdependency, the other on dependency. One on the far more small than largest, while the other more or less similar things. One across all scales, while the other on each scale. One is long-tailed, the other shorter-tailed. One is disproportional, the other proportional. One is on complexity, the other on simplicity. One on non-equilibrium, the other on equilibrium. Based on these 2 laws, it is not difficult to conclude that the Earth's surface is a living structure at different levels of scale. The global scale, the continental scale, the country scale, the city scale, and the building facade scale. To this point, we can also conclude that goodness of space or structure is a matter of the fact. Herewith, for each pair of these structures, the left structure is more beautiful or more living than the right. Why? The short answer is the left is more complex than the right. A general rule about goodness of space goes like this. The more substructures, the more beautiful. The high hierarchy, the more beautiful. The cathedral facade has over 500 substructures, while the modernist one has only 50 substructures. More importantly, the 500 substructures have 6 hierarchical levels indicated by different colors, while the 50 substructures have only 2 hierarchical levels. Here is another example, 2 UCL logos. Again, the left is more living or more beautiful than the right. It appears that people of our times have lost their sense of the beauty, affected by modernism, postmodernism, deconstructionism, and a host of other reasons. It is time to recover our sense of beauty, which came with us when we were born. Now, let's come back to these two paintings. It is not difficult to find out painting B is more living or more beautiful than painting A. Let's take a close look as to why. Under the mechanistic view, paintings A and B consist of respectively 7 and 9 substructures. However, under the organic view of space, they consist of respectively 18 and 20 recursively defined substructures. Both are emerged or evolved from the empty square in a step-by-step fashion. Importantly, there are always far more newborn substructures than older ones, or newly generated substructures than older ones. For example, from 1 to 4 or from 4 to 6. These two paintings differ only at the last step. From E to F, it is not far more newborns than older ones, because 6 and 7 are more or less similar. However, from E to G, there is indeed far more newborns than older ones. Eventually, painting B is more living or more beautiful than painting A. Okay, it is time to draw a conclusion of this presentation. There are a few points to highlight. Space and place are not separated as currently conceived under the mechanistic worldview, but can be bridged together through the very concept of the wholeness or under the organic world picture. Second, goodness of space can be objectively or structurally judged as a matter of the fact, rather than opinion or personal preference. The more substructures, the more beautiful. The high hierarchy, the more beautiful. Third, the goodness of space can be well reflected as our inner experience with a good sense of the feelings such as proud, belonging, well-being, and healing. Here is a list of my recent papers on which this presentation is based. The first paper demonstrated that not only a map, but also the territory or the Earth's surface in general is a living structure, and argues that it is essentially the living structure that makes maps and mapping possible. The second paper is to defend living structure as a physical phenomenon. Just as air, we cannot see it, but it's in our surrounding. The third paper is to argue that the goodness of space is not a matter of the opinion or personal preference, but a matter of the fact and can be well measured or quantified. The last paper was to establish wholeness or living structure as a scientific foundation of sustainable urban design and planning. For this topic, I have not got much time into the detail in this presentation, but I hope I will have future opportunity to further discuss with you. Thank you very much for your kind attention, and I have enjoyed the presentation. Any questions, comments are more than welcome.
Thank you, Professor Zhang. And we have next presentation, Professor Dr. Junyoung Choi from Seoul Institute of Technology. So his presentation is titled Research Directions for the Epidemic Simulation Model using the telecom mobility data. So Dr. Choi.
Hi, I am Jun Young-chae, Research Fellow of the Seoul Institute of Technology, and I will present the research direction for the epidemic simulation model using the telecom mobility data. This study was a part of the joint research project with SK Telecom and SK Corporation on the development of a smart city epidemic prevention model using the mobile telecommunication big data-based spatial temporal simulation. And also, I would like to introduce my co-worker, Dr. Taeyoung Kim and Mr. Songbom Yoon. South Korean approaches are known as one of the best practices in dealing with COVID-19. In addition to medical measures and social distancing measures, such as the development of test kits, a high number of tests, and the strict application of face masks, the use of this digital technology has played a significant role in reducing the spread of the virus. Contact tracing is an important way to pinpoint those who must undertake the COVID-19 test, and where these contracted people have visited is an important source for further tests. Viral diseases are particularly detrimental to high-density and hyper-connected urban environments. However, Korean cities have maintained low numbers of confirmed cases without the implementation of citywide lockdown measures. The Seoul Metropolitan Area, SMA, a case study area of our research, is intrinsically vulnerable to communicable diseases because of high-density environment, one of the highest population density cities in the world, requiring the fine-tuned strategies that can be supported by digital technology. This study is to develop a realistic model of virus transmission. To do that, first of all, it is necessary to understand the mechanism of transmission of COVID-19. Using the mobile telecom data used by everyone is very necessary to understand the close contact. Next, we use simulation to develop an urban management model for infectious disease prevention. It is to effectively utilize quarantine resources by implementing selective measures for vulnerable groups and places. Finally, sharing knowledge with the metropolitan area in developing countries. It is the sharing of epidemic prevention knowledge based on mobile telecommunication mobility data available in any cities in the world. Our research goal is the spatial temporal epidemic model based on individual contact, effective in responding to COVID-19. And we can get an advancement of the model using information such as changes in mobility and population movement between administrative districts in the model for predicting the spread of infectious diseases. Also, we can predict the spread of infectious diseases by major point of interest such as multi-use facilities, group infectious facilities. Our second research question is how can the countermeasures derived through simulations be applied to the Seoul quarantine policy to stop or alleviate the spread of the disease? Preemptive and proactive response to follow up confirmed patients and contact. Effective transmission of quarantine policy information such as social distancing through target text messaging adjacent to the actual contact person, according to the reduction of the effect due to the indiscriminate sending of text messages. We know that from SARS to MERS to COVID-19 infectious disease, the response using information and communication technology has shown great effect. When large-scale human behavioral changes occur through non-pharmaceutical interventions such as social distancing, restrictions on social gathering, and contact tracing, the reduction and movement of close contact can lead to transmission of infectious diseases. You can change the pattern. It can be said that it is mobile phone data that can understand this behavior well. Mobile phone data includes data that network operators can actively collect, such as call data dictionary and logo event data. On the other hand, there is also data can be collected passively, such as GPS location and Bluetooth data through opt-in application. In the previous slide, call log data were originally collected for quality control analysis optimization, can be used to create population and mobility pattern data. However, it is difficult for researchers to collect data. So for actively collected mobile phone data, spatial temporal and population resolution can be considered. The figure on the right shows the process of generating data in units of 50 meter by 50 meter through regression analysis, after combining statistical information with data in cell tower units. The type of information collected with the temporal resolution are as follows on the left table. On a daily basis, it is possible to obtain data that distinguishes gender in spatial resolution of administrative district, for example, and on a 5-minute basis, data that allow viewing of lifestyle patterns in spatial resolution of smaller census district become possible. But for the epidemiology study, it is difficult for researchers to acquire and process data for epidemiology research. Recently, data products are widely used in infectious disease research using mobility data. If telecom mobility data sets for infectious disease research is made possible, I think three important factors must be considered. The first is the transparency methodology for big data solution provided by network operating company. The second is accessibility to mobile big data for developing epidemic simulation models by various researchers. Finally, and more importantly, recognizing the spatial temporality of mobility data. Two representative algorithms for epidemic simulation can be considered using data collected actively or passively using telecom big data. The first is the location analysis of infected and close contact. By analyzing infected person's routes, high-risk locations can be derived and be used as primary data for quarantine check. That is to derive close contact crowd and visitors to pick out high impact risk groups within short time period and provide support for quick response and inform people for COVID-19 check, self-quarantine, preventing further spread. In this case, data requirement is very critical because it needs a kind of cell phone number of infected person. Through the picture shown in the example, how many infected person can closely contact with other people through the location analysis of infected and close contact. And the second, another application will be disaster short message for infection alert. In Korea, government send disaster short message containing infection alert for the purpose of effective transmission of quarantine policy information, such as social distancing through disaster message. But citizens are fatigued by the sending of numerous disaster messages, and the effectiveness of policies is diminishing. This message uses cell-based broadcasting technology to send the message within 15-kilometer radius of LTE base station. So we need to optimize the disaster short message so that the necessary information can be delivered to the person in need. This disaster text message design can utilize the contact trace information described above. In other words, it is possible to provide customized close contact information to the high impact risk group. In this study, two policy directions were considered for epidemic simulation for the quarantine policy using telecom mobility data. First, by doing precise epidemiological investigation of the infected person with the traditional policy, health authority increases in quarantine cost and decreases in effectiveness. Therefore, in this case, the tracing infected and close contact method can be introduced. The second is to evaluate the effectiveness of policies to strengthen preventive measures by introducing non-pharmaceutical intervention measures, such as social distancing for preventive policy. In this case, we can adopt a social experiment that induces behavioral change through text message using opt-in application. In the case of tracing infected and close contact, it can be assumed that the movement of the confirmed patient 2 days or 48 hours ago can be traced. Detecting close contact can be verified through an epidemiological survey report. Then, can we track the route using telecom mobility data and accurately identify the proximity contact person? But unfortunately, limitation of telecom mobility data's spatial resolution, we need to adopt scientific algorithms to detect and trace close contact. So our next experimentation is a text experimentation. There are many people who are tired of the government COVID-19 text message and disable the notification function. Designing the most effective text message for social distancing is required. Our experimentation goal is to design the most effective text message for social distancing and prevention of COVID-19 infection. Through a randomized controlled experiment, we are planning to send text messages to Seoul citizens between the ages of 20 and 84 for 2 months and observe the movement for 3 months. In this case, the change in behavior of the individual according to the disaster text message is observed by using the personal information that has been consented in advance through the participants' opt-in application. In the text message experimental design, we plan to observe behavior through disaster message related to infectious diseases by applying different message selection method to groups against the control group. In the conclusion, post-COVID-19 city management should apply the lifestyle changed according to infectious disease to the smart city management system. So-called post-COVID-19 urbanism is that data is core of a smart city planning for post-COVID-19. Thank you. Thank you for listening.
thank you, Dr. Choi. And now we have to move to the next presenter, but unfortunately, Professor Seung-Sik Hwang is not attending today due to his personal emergency issue, so that we need to move to the panel discussion directly. So now let me introduce three panelists. Mr. Remy Shechping. So are you with us right now?
Yes, I am.
Okay. Hi. Remy, he is the UN Habitat. His affiliation is the UN Habitat. Nice meeting you. And also we have Dr. Younghwa Hwang. She sitting right next to me. She is a research fellow at Korea Research Institute for Human Settlement. Welcome. And we have the last but not the least, Professor Hyungmin Kim, and he is Faculty of Architecture, Building and Planning at University of Melbourne. Welcome.
Hi, everyone.
Welcome, Professor Kim. So now let us move on to panel discussion. So we have a total, 6 panelists and 3 panels who can introduce your research and your comment regarding the presentations. So this is live session, so that we have live questions from the audience on YouTube. So I'll give you the list of questions a little later. But let us please, introduce yourself from Remy, and regarding your the topic that you'd like to present to this this workshop now. Remy?
Thank you very much for having us, UN Habitat, and having me, Remy Shechping, to this particular forum. I'm Chief of Policy, Legislation, and Governance, and under that program we are responsible for metropolitan management of portfolio at UN Habitat. So very important topic, and we are very delighted to be here. Listen very keenly to the presentations, and I thank the organizers for being so efficient. I have 5 points that I would like to share as UN Habitat contribution and reflection from the discussion we have. The first one is in the context of COVID-19, is that we are not alone. So the message is that multi-level governance is very important in the context of COVID responses. Because what we have seen from our recent data is that achieving cooperation among all different levels of governments, sectoral authorities, have been really key in embracing and engaging with the pandemic and prepare later on the resilience of the population. So that element of cooperation, collective action, solidarity had emerged as key ingredients, and we are releasing in the coming 2 months a global report on urban and pandemics, and this is some of the messages that have emerging. Because we have noted that when you have interjurisdictional cooperation, a mechanism that include evidence, data, information that we are discussing here, then the measure of how we rapidly engage with the pandemic or the type of issues seems to be more effective. And we have seen here that the Seoul metropolitan government had inspired many actors to work together in terms of data sharing or data management to inform the response. Therefore, we at UN Habitat see the leading role of Seoul metropolitan government to further share that type of experience with or how to work with other tiers of government, with other actors out there. So that was the first message. Multi-level governance is key to address the pandemic, which is based on data. I will get back to that in a second. So the second point is relevant, pertinent data. I think the first presentation really put that on contact tracing. Are we really getting what we need? So because what we have seen recently in analyzing metropolitan data in relation to a pandemic is demonstrating that out of the 60% of urban population that live in what we call metropolitan areas of more than 300,000, these are the hotbed of the pandemics. Metropolitan areas are hard hit by in the scale of any type of settlements in terms of the pandemic. So that pertinent data on analyzing where they are in metropolitan areas have revealed the importance of metropolitan areas in the context of COVID-19. And this particular forum is really spot on and timely. Seoul is entering into this group of metropolitan areas of more than 10 million people, and we have only 34 around the world, as shown as by our data. And we know that this trend will continue. By 2063, we're going to have about 3 billion people living in metropolitan area. Going to have by 2035, 2,363 metropolitan areas based on the data we have seen. This is just 15 years from now. So the metropolitan trend is increasing. And with the future pandemic, we have to be very, very alert on how we manage that when we have a larger concentration of people. So for us, we love to encourage, as we do this in the context of big data, for instance, encourage more disaggregated data, more granular data collection at the spatial level, that we are not saying that the whole country have the same level of impact on the pandemic. So that's what will be one of the calls that we're going to have in saying that big data could give us some hints so that we can really use the acupuncture responses to address where the needs are. So pertinent data is key. That was the second message. The third one that I've really heard and appreciated in the presentation was the power of harnessing technology for more informed, timely data. We heard very much that the issue of health becomes an equity, moral issue. Moral dimension should not be ignored. So harnessing data technology for good data, what you may call smart technology, will help. Things like real-time maps, mobile apps, we have heard here, other frontier technologies of things. These are all important and very relevant for metropolitan and local authorities to inform, to have an efficient decision-making. And without reliable, evidence-based, real-time data, decisions in the context of, say, COVID-19, where the situation is dynamic and rapidly changing, you'll be falling behind. But we feel that it's very important to think of equity so that no one is left behind, some pockets are not ignored. We are in the process, in that context of equity, to release a guide on how, again, that context of multi-level governance can improve health equity. So the book will be, the guide will be multi-level governance for health equity especially in metropolitan areas. We also believe that the governance of digital data, we heard here about the issue of privacy, in time of pandemic, it needs an urgent attention. Many metropolitan areas are asking for such guidance on how they can really make sure that the data privacy issues are handled. We are happy to discuss with anyone here interested on how the idea of advancing this area. The fourth message is about vigilance. We have to be vigilant because with the accelerated use of information technology, especially for data surveillance and spying, it is becoming an issue. So that's something we have noted, and I saw that in the presentation, and one of the questions was about that. So while we acknowledge the benefit of the tracing apps and for better COVID response, they also affect the privacy of information and therefore it's a risk of improper use. So that safety guard around the data is very important. We should not keep our eye away from that. Citizens around the world, as we have noticed, we engaged on this during this pandemic, started to argue, to complain about the loss of freedoms due to data surveillance. We have seen the protests in some countries, and this is based on that assurance that data will be used with good intention and not for other ill-intended purposes. Therefore, if not properly managed, this can undermine the democratic governance, human rights, and leave some populations behind. Because when we are using, say, for instance, the mobile app, not everyone all around the world have smartphones. So how do you reach out to this population that do not have, the technology that is used? How do we democratize the access to this information while we don't undermine the privacy? So these are questions that we still need to work on and have a conversation around. We should be more than happy you should be more sensitive to mitigate the risk of population profiling. Because there are some groups now that we are saying, okay, people who are maybe elderly, who are men, who are on the land conditions, that becomes a profiling, and that will undermine their self-esteem. So let's also be very critical and understanding of the importance of profiling and not neglecting. So we have to develop some regulations and data property and data use that will safeguard some of these things. And the other thing we have noticed is the data duplication. There are many actors that are out there collecting almost the same data during this pandemic, but we don't have a federal element to bring all that together. So the last part is, my last message is the role of the Seoul metropolitan area. We believe that Seoul can be a global, as we are showing today in this forum, a global champion for better metropolitan management and governance through data, through technology, as you have shown in this case of responding to the pandemic. So the experience and initiative presented today and throughout this forum, from the Seoul Institute of Technology, for instance, and the Seoul National University, illustrate how the cases of Seoul can inspire metropolis from all around the world to move towards more good, effective, inclusive management of system, of data, of prompting subject of health, governance, data, and technology. We at UN Habitat believe that Seoul can be a good partner to joining us in establishing the global Metro Hub Center exactly to respond to that purpose. So that's what we have prepared and would like to share with you, and congratulations again. Over to you.
Thank you, Remy. Oh, it's wonderful and really pertinent summary of what you see regarding this pandemic, worldwide pandemic. So in summary, if I can repeat your point, that I really love to listen to your summary, particularly for kind of governance issue, not only vertical, but also kind of horizontal governance. You name it, like multi-level governance issue. And then pertinent data and smart technology. And fourth of all, I believe the most important part, like how to deal with the privacy issue. So that is one of the key parts. And also I like that the final comment regarding, this is about what we have to discuss and what we have to meet here. So like sharing our experience for that, for the future, all the notable researchers like tell that in the near future we might have another round of pandemic. For that case, we might be able to share this kind of experience together, and then we can react in more proper manner, then the damage is much more reduced. So I love your summary and comment. Thank you very much, Remy. And let us move to the next panelist, Dr. Hwang. So please give us some comment regarding the epidemic response from Korean government perspective.
Hello everyone. My name is Myung-ha Hwang. I'm from Korea Research Institute for Human Settlements. Actually, I prepared some English note about this forum, but just because they provide some translation service, I will just use in Korean. So. My major is 저의 전공 분야는 공간.
My specialty is space data analytics, so especially all kinds of big data that comes from the city, how we can respond to the pandemics. There are a lot of discussions going on, and I'm very pleased to hear your views today. Especially today, we are gathered to discuss about big data gathered within the city, especially utilizing that big data to respond to the epidemic from the perspective of the government and also from the citizens. I'd like to start my comments. Although there are a lot of discussion going on, I believe the actual utilization is only possibilities. Of course, we are applying that, but most of the technology, we continue to research them because we believe in their potential. But in practical sense, what's the best way to use that? I'd like to make a suggestion. Let me re-emphasize that all the views that I'm talking about is purely my personal view, not the KRIHS view. Now, when we are faced with epidemics, we need to stop the spread of the epidemics, and at the same time, we need to respond to the socio-economic side effect. We need to provide ways to deal with that. In case of COVID-19, nothing is widely known about COVID-19, and also we don't know how it started, what's the mechanisms, how it evolved. We had no ideas. So data-based approach is critical in light of that. So most of all, today, upon listening your presentation, all the data that we gather within the city, we need to analyze that so that we could come up with a mechanism to respond to the epidemics, especially in terms of the predictability and also in terms of responding to the epidemic. Second, medical resources are very important every day. Especially, we try to analyze how many beds are available in certain regions. We need to allocate the medical resources in certain area, and that kind of work is done by the government. In light of that, once again, the data analytic role is critical. Another thing that I'd like to take note of is that, together with this, when the epidemic disease are spreading to the level of pandemic, we need to take a special approach. For example, social depression can spread because of the isolations and quarantine, and also obesity can increase, and also there are a blind spot or the area that are sort of disregarded or disadvantageous area that we need to pay extra attention, and we don't have enough capacity or capability to make investment. And post-COVID era, how are we going to address the people who have been hurt or who have been heavily damaged by the COVID-19? In light of that, Professor Bin Jiang, your speech or your presentation is quite relevant to the work that we do. So from the city government position, there is crystal clear directions that we need to take, and the presentation that I heard, totally I agree with that. And another important thing is that we need to change individuals' way of behavior. We need to change that. Like, for example, which area can we go and what kind of activity can we do? For example, if we go to a certain space or place, there could be some extra dangers, or the pandemic risk could be greater or less, and our daily activities or our behavior can influence the spread of the epidemics. If that is true in case of the urban city, whenever there's a people movement, we check the transportation data, and also we need to analyze how it can impact the social movement within the urban city. So in light of that, if the data analytic can play the role, they'll be very critical, especially the space utilizations and also the personal behavior can be relevant to the data analytic. Currently, people cannot move around freely, but in the future, we can use this big data when we can secure a certain level of the people's movement. Definitely, data analytic can play the role. In order to facilitate that, we need to think about what can be secured. There are three areas that we can think about. First, there are a lot of different approaches, telecom, data, or there are platform businesses which gathers a lot of consumer behavior data, and of course, sometimes it violates or it's related with the privacy information or personal information, but still we need to extricate them to use to respond to the crisis that we face in the city. For example, of course, we need to take a certain legal actions, and in light of that, we need to monitor certain trend, and also the urban data trend-wise, we need to take initiative to understand the people's movement, and then we need to categorize their movement, especially the health authority need to gather information based on our research result. Maybe we can provide a tool based on our analysis of the data. A couple of things are crystal clear recently, and especially the presentation that we heard today. I believe data sharing is very important. Mobility-based data is also important, especially when the country is under quarantine and isolation. We can prove whether that kind of border closure can be effective or efficient or not. In light of that, science-based urban data, how we can analyze and mobilize them, should be clearly decided. Next point that I want to talk about is the efficient utilizations of the data as a social goods needs to be secured. Now's the time to do that. With the COVID-19 pandemic, in response to that, what's impressive is that a lot of public agencies and private companies, they took initiative. They came up with the data, they create the data, they generate that, and they share the data. In Korea, we have a lot of telecom operators' data, and quickly they provide the data so that the government health authority could use that, analyzing how people move from one place to another, how the virus can be moved. In case of Korea, we have the KakaoTalk that provide a lot of information. So in responding to the pandemic, people realize that gathering of the knowledge information is also important. So considering that point of view, in the future, there could be another unexpected pandemic that could occur. And in light of that, we need to use this data for the social goods, especially data that belongs to the credit card companies or like a Google or telecom operators or platform business, the data that belong to them. We need to secure the data as well. We need to use that. So this telecom operator or platform business, they gather the data and use that to create profit. But voluntary contribution, or how should I say, they need to provide this data as a responsibility for the society or for the community. As a CSR, they need to return this data. If they do that, it'll be very helpful and beneficial to the society. Dr. Che talked about that as well, especially in response to the epidemic. He shows how the telecom mobility data could be used. And when the telecom mobility data is accumulated, we can definitely use that as our foundation. Last but not least, in case of the analytic tool, we need to develop that, and we need to create an ecosystem to use that data. Currently, in each city, starting from the movement to the analysis of the data itself, there are a lot of new ideas and also techniques that can be used, but can really apply that to the real situation. It takes a lot of time to do so. And in case of Korea, the K-testing kit that was spread widely, there were collaborative work arrangement. That is why, based on that, we're able to come up with the techniques and also tools to test, track, and also prevent it. So at least in Korea, the analysis of the urban data, it is a little bit too premature to use that, but in the future, we need to collaborate so that we can use that. So I believe that the SIT and Seoul Digital Foundations and also Seoul institute, we all need to work together. So research institute, when they come up with a technique or tool, we can immediately apply to the real world. I sincerely hope that can be possible in the future. Maybe a knowledge tool, systems to nurture them, or system to create that, we need to think about. Then now's the time to do that. So that's the comment that I have prepared. Thank you very much.
Okay, thank you, Dr. Huang. She kind of opened new horizon of how to utilize urban data science when we fight against COVID-19, not only from government perspective, but also from personal perspective. In summary, let me summarize her comment. I like her comment, particularly regarding personal issue. We have been focusing mainly on how to make the best use of urban data science to fight against COVID-19. But at the same time, she mentioned that we can utilize urban data science technology for dealing with personal issue, like aftermath of COVID-19, for example, kind of depression level of all the society that can be reduced a little bit using urban data science, for example. That's kind of new horizon, I believe. At the same time, she suggests 3 major points: what we have to do and what we should do for the future. And first of all, she also mentioned regarding privacy issue. At the same time, while we a little bit sacrifice that privacy issue, then we can improve and increase that the public benefit. So she mentioned that we can share the value of sharing our privacy information under certain limited amount constraint. Then we might be able to enhance the public good. That is one of the points that I really like. And at the same time, she suggests that we have to consider that urban data and some spatial data and the urban related data as a fundamental public goods. It's somehow associated first comment, but that has to be kind of archived and designed and prepared in advance. Then we might be able to more resilient society to combat and fight against COVID-19. At the same time, she also just suggests, this is also interesting idea, that we need to think about build an ecosystem, can react quickly when we have new epidemic or pandemic, where it requires some new technology where we can adopt and deal with such formidable epidemic or pandemic issues, so that we can quickly adapt and our technology to deal with such problems. Thank you very much for your comment. And last but not the least again, Professor Hyung-Min Kim from University of Melbourne. Could you please share your vision and idea and experience of urban data science for epidemic response? Professor Kim.
Thank you. My name is Hyung-Min Kim. I'm working at the University of Melbourne as a senior lecturer. My major is urban planning, and I'm so pleased to be part of this prestigious event. I have recently published one book entitled Smart Cities for Technological and Social Innovation. Although this book was produced before COVID-19 started, it has some elements about smart cities and COVID-19. And I will start with a quote from this book. The responses to COVID-19 demonstrated the role of technological innovation when unexpected, irregular, and uncertain circumstances appeared. As in-person interactions were discouraged to prevent the coronavirus from transmission, ICT infrastructure and high-speed internet connections established virtual platforms. Citizens were not socially isolated due to alternative ways of communication, work, study, and entertainment. In this sense, smart cities, assisted by technological innovation, can be resilient to sudden external shocks, mitigating devastating impacts. COVID-19 has made extreme outcomes and devastating outcomes. No one can deny. And I'm living in Melbourne, Australia. There is almost no time difference. Here it is 4:40. I think in South Korea it's 2:40. There is only 2-hour time difference, but the weather is different. We are heading to summer, while South Korea and for Northern Hemisphere is heading to winter. Oh, even now it is winter now. There was very hard lockdown in the city where I'm staying, over 111 days. Over this long period of time, many people were basically limited in their mobility. If there are two options between the limitations on your physical mobility, such as very hard lockdown, and some degree of invasion in your privacy, which one would you choose? Melbourne has done, Australian cities and Australian country has done a pretty good job because there is no local transmission for many days, like over almost 1 month now. So because of the hard lockdown, the final outcome so far is pretty great, but there was a very devastating effect on personal mobility. People were not allowed to move around after 8 o'clock in the evening. They are only allowed to go up to 5 kilometers within their house. And with the working permit, they are allowed to go out. Even a lot of companies and universities were closed down. Even the president of the university worked at home. He or she can't come to the university because of the regulations. So the topic of this conference is data science. The data is what we have now. It can provide us more freedom to move around. So the initial question between the physical lockdown and the freedom of mobility with the data assistance can give us a good implication on how we can manage the cities. I think South Korea as a whole has done a great job in managing the coronavirus in terms of various measures. It has invented the toolkit, the test toolkit, which is from the medical part. But not only that, but also how it encouraged test and contact tracing was kind of the exemplar amongst many countries. So South Korea is kind of the reference when many other countries want to compare how they are performing well or bad. In that process, what has supported was the use of data. I think the infrastructure to make use of existing data has been already established, which is very advantageous for managing this pandemic. Before the COVID-19, when I discussed with many people about the death of distance, I think no one believed the death of distance because face-to-face communication is much more encouraged and desirable because we can get implicit information from face-to-face conversation. But now, because of the COVID-19 restrictions, face-to-face interactions are highly limited. But instead, what we are experiencing, as you can see in this conference, is acceleration of virtual globalization. Before, we talked about hyperconnectedness between cities and regions, and transport network like air transport network were highly connected, but everything was frozen. With this frozen environment, we can still exchange information through this virtual platform and this ICT platforms. So we are not socially isolated. We can communicate lots of information and knowledge throughout the period and across the city. I think in Sweden here, the second presenter, Bing Jiang, is from there, although it is very early in the morning, and we are from many places to discuss this global issue, which shows the virtual globalization at a very advanced level. So the COVID-19 has given us an opportunity to create further values, and this is a new era of globalization. It is not about physical movement, but also beyond the national and city boundaries. We can do many things together. So ICT is supporting in many ways. I believe this will give us a long-term changes to the way of our life and the way we work and live. So, however, the COVID-19 and ICT infrastructure has social implications, and many people have become busier because they have to contribute to the society as a scientist, a data scientist. But at the same time, many people are becoming more and more marginalized because they lost their job and their physical work has been disappeared in the society. So they are now unemployed and they need social welfare desperately. And in some cities, more marginalized and more poor people were highly affected by the coronavirus in terms of economic gains and also the mental illness. The first presentation about contact tracing and the third presentation by Dr. Choi presented a very important ways to manage the coronavirus in terms of how we can identify the people who had close contact. I think this is a great example that show how we can make use of the available data. Although there is an issue around privacy, I think if someone is dying, privacy is not an important matter compared to this urgent health crisis. By using this contact tracing by mobile data, what you can precisely point out is the time and the space. These are two major important things from the analysis. When people are there and where these people are there. So which gives us high chances to precisely identify who are in danger. So by using the mobile phone signals, the time and space information can be analyzed. But at this stage, what we can do is analyzing backwardly. For instance, where did you visit and when did you visit in the past 48 hours, something like this. But by analyzing the past history, the project that Dr. Choi presented can give us a more grounded hint that we can understand how the future looks like for next 48 hours or next 1 week, something like this. So what we have, data and information, which is very important values for that urban management. I have initially questioned to Dr. Choi about to what extent the model can be used to technologically less advantaged cities and countries. For instance, Seoul is very advanced in terms of technology and ICT management, but in some other countries don't have such infrastructure as good as South Korea has. But as I listened to the presentation, what came up in my mind is that everyone has this simple device, mobile phone, which is very essential now everywhere. Not only in advanced countries, but also everywhere has these smartphones, and the signals are very essential for information exchange. So I think the well-developed, tailored models from the project can provide lots of implications to many cities, which will help other countries as well. And many medical experts are saying that plagues can be with us many times over. So this coronavirus is not the end of the plagues, but we can face another plague or another contagious diseases, which is pretty sad. But by overcoming this COVID-19, I believe we have now the source of data, and now we are developing analysis skills, and we have consensus that this can be used for the public purpose. Then we can be more prepared for the next time. We don't know when this can happen, but if that is the case, we are much more prepared for this sudden external shocks. And thank you for your listening.
Thank you, Mr. Kim, Dr. Kim. So his point and comment is mainly making a point of like a positive side of COVID-19. Let's say, for example, I like his point that thanks to, it's not really thanks to, but I mean due to COVID-19, we can connect each other internationally through Zoom and or this kind of online platform. We know that this technology is out there, but we rarely use this kind of technology, but now it's everywhere, right? For those kind of positive aspects. And I think his comment regarding that positiveness of COVID-19 is like, it occurred to me that William Gibson's adage that the future is already here, but it's not evenly distributed, but it has to be changed. The future is already here. Due to COVID-19, it's rapidly distributed. So new era is coming. And he also mentioned about some positive aspect that we learn from COVID-19. So due to this kind of, it's not a practice, but due to this real world combat against that formidable the epidemic, that we can train and we have more resilience. We breathe and foster our kind of levelable resilience throughout this, the course of effort, not only in urban data science, but also some political issues and government issue, governance issue, and some society issue. While we're dealing with such problems, that the body of human being can be grown up for the future potential, another round of kind of epidemic or pandemic, which will occur to the human being in the near future, or hopefully not, but sometime soon. So thank you for the comment. And now let us move to kind of question and answering and questions from. We have a few questions from YouTube and kind of live questions. So I would like to share those questions to all the panelists. One of the questions is about what do you think is the most important and most critical information in urban data science, which is for fighting against COVID-19? That's the first question. And second question is about, actually, it's from me. While we're talking about this data issue, urban data science, one of the key issues about privacy, right? Then what's the level of privacy? It's really appropriate to deal with COVID-19. So two questions. What's the most critical data, which is critical that to fight against COVID-19? And second question is about what's the level of appropriateness? How much we can disclose the privacy data from your own perspectives. Professor Jiang, could you please start?
Can you hear me?
Yeah. Yes, I can. Please.
Yeah, thank you. And you see, my presentation is pretty much not in. If you put it in the context of this session on the issue of the COVID-19, my presentation seems a little bit out of the topic. But what I really want to stress that is the technology, of course, is big data technology is really advantage to the high level. So we can track individual and through the mobile phone and the GPS technologies. But we tend to probably have to focus on the other aspect, how space itself, the space people are living is not like completely Euclidean space. We transport through networks, buses, So all this underlying infrastructure is very important for understanding human behavior, movement, epidemics. Okay, so to cite the British Prime Minister Winston Churchill, who famously said that we ship our space first, and afterwards the space ship us. So this is exactly the approach which I adopted. That if we could better the underlying space, underlying the transport or network, road network infrastructure, then we can really better understanding the human travel behavior. So this is also linked to the second issue which you raised about the privacy. The research we have done on the space syntax is really trying to understand this kind of underlying living structure. Then we can predict 80%, up to 80% of human behavior without tracking individual. So of course, I said technology, tracing technology, GPS things are really advantaged. So we can really track. But the issue is, the privacy issue and also the signal issue, whether it's available, and also the difference between indoor and outdoor, all this risk issue. So that's why the approach which we have been developing is really holistically, not mechanically, to look at the space, and then how this space or underlying structure, which we can clearly define. So for better understanding the space and also the human movement over the space. So that's my perspective on the two questions.
Thank you, Professor Jiang. He gave us big picture perspective, how to, in space, we change the space that makes us changed, and then it can one way of fighting against COVID-19. Thank you. And let us go for, how about Dr. Choi? Could you please answer the two questions that I raised?
네, 동시통역이 제공돼서.
Well, because we have interpretation service, I would like to speak in Korean this time.
교수님께서 첫 번째 말씀하셨던 도시
Regarding the first question,
감염병에 가장 민감한 도시 데이터를 말씀하셨는데
you mentioned about the information that is the most sensitive to the pandemic. Well, cities are related to space. Well, I will say spatial temporal information to be specific. So regarding pandemic or infection, you may be interested in where it's originated. And as I mentioned before in my presentation, I mentioned mobility. There are many kinds of mobility, and I just focused on the context of creating data. So I just define as telecom mobility. However, to trace how human behaviors change and how human behaviors affect. So in terms of that, it's important to understand the concept of spaces. So if you want to be in the context of urban technology, space is important, and cities are where people live together. And there are lots of information will be important related to these people living. And there's a POI in my presentation, a point of institute, and then in scale and at point, there are some dots you can mark where people live together, and that's how you show where people live on the map. But when you contact people, and if somehow the concept of space is deteriorated, maybe you need some information to redefine the concept of the space. And maybe that's something that interior design deals with. So I think this type of information may be important in terms of urban management. And the second question was about privacy and dealing with COVID-19 and pandemic. Of course, privacy is very sensitive. And as Professor Kim Hyung-min mentioned, in Australia there was a choice. There was a chance to choose between physical lockdown or some allowance of personal information. But at the end of the day, there should be proper control devices or control means to deal with the privacy. And of course, you need some consent. And as Remy mentioned, it's important to use such information in a sound way in order to maintain the resiliency of the city. So we should seek some guidelines to use these privacy-related information in a sound manner. So I believe in that sense UN Habitat will be very useful for that.
Thank you, Dr. Choi. And now let's move to Dr. Huang. Could you please answer the question answer the question.
Well, the moderator asked a question, two questions actually, and let me answer directly. First question, what data is the most important element in responding to the epidemic? Well, I guess the infected or confirmed cases movement is critical because we need to treat the patient. And of course, there's an issue of the privacy and personal information protection, but we need to secure the data regarding the people's movement. How well does the city respond to the epidemics? Well, overall, I believe that we need to understand about the livingness of the space. What Professor Bin Jiang mentioned, the livingness is important. But of course, people's movement from one place to the other place, who the confirmed case has met or what he did or she did, the activity information is also important. We need to understand that first so that a city can respond to the epidemic. We need to identify the patient or the confirmed cases or the one who could spread spread the virus. So once again, within the urban space, people to people, the people to structure, and also people to nature or structure to nature, all of these interactions and related information needs to be secured so that we can respond to the epidemics. And as I mentioned, I'm specializing in space data or the space-related data, and what kind of data should we digitalize? And whenever I do the research, once again, most of the data are quite static, and the government provides all kinds of static data, not the dynamic one. And right now, what's the current status? What is happening in that place or space? We need to present that. We need to demonstrate that. I'd like to call that as a place or space profile. And that kind of profile data is required more than anything else. Regarding the second questions the moderator has raised about what's the appropriateness of the privacy protection, it's a very, very tough question. So I honestly don't know the answer. But I hope that the level of the disclosure of the personal information should not be clear so that someone can identify me immediately. So I believe that we need to aggregate the personal data. The scale of the aggregated data needs to be to a certain level so that we can use the personal data to understand the dynamisms of the city, which is also our target to be researched in the future. And to a level that each individual is not easily disclosed, but still we can detect what's going on in that city. So that kind of scale and size of the information needs to be disclosed as a privacy protection. So that's my answer, and it's really hard to answer that question. That's all. Thank you.
Thank you, Dr. Wang. And now, Professor Kim, could you please give us wisdom regarding the questions?
Yeah, I think you're asking very difficult questions. Yeah, thanks a lot. I think in terms of privacy, it varies depending on how urgent we are. If we are in for instance, in a battlefield in the war, I think privacy doesn't really matter because we need to survive. But in a normal, ordinary conditions, privacy is very essential and important. We have to protect the personal information thoroughly. So it varies. So, and it depends on how we perceive this coronavirus now. But many think this has generated very negative economic loss and health crisis. So this is pretty equivalent to the war situation. So I think many people understand the invasion of privacy to some extent is still acceptable when dealing with this pandemic. And which data do we need? Indeed, we don't have many data scientists. We are training people, and we want to focus and emphasize data science a lot, but it's very difficult to find analysts in reality. So this is an emerging area. So my suggestion is to make data as available as possible so that anyone can tap into this data science and to provide analysis outcomes. So the role of the government is to provide and create a platform so many people can access the data without the invasion of critical information about personality. Then just anyone can access the lots and lots of data to analyze. For instance, analyzing and providing the profile or dynamic of the space. As discussed just before. And even the secondary school teenagers can do the data analysis by learning from various sources. That is the way that we can take advantage of kind of competition and open source data. There's no reason to limit the data to just only selected people. That is my stance. However, we are discussing the privacy issues. If there is a very essential and sensitive privacy information, then those information must be given to very limited people with the consent that it is only for used for this crisis only, something like this. Yeah, thanks.
Okay, thank you, Professor Kim. And the last but not the least, Mr. Xie Ping. So could you please give your wisdom regarding these problems?
All right, thanks a lot. Yes, I agree with others that these are tough questions, but let me try. On the first one, on the level of appropriateness, I would say first, if you just use the assumption that can anyone disclose the same information and not feeling targeted? Meaning that can the same information be disclosed for everyone? If the answer is yes, then the issue of privacy becomes, a non-issue. The second, and I think Professor Kim just mentioned, is really the purpose. Is it for the sole purpose? But what we have noticed earlier from one of the interventions that if credit card company and other are collecting the information and using that for other purpose, that's abuse. That's actually stealing. And that's where the privacy comes in. So that's the second part. The third one is really about the context. And I think there was an answer already provided. You can generalize to some extent and say, okay, this is the pattern, these are the things happening, without no one feeling that personally, individually, they are targeted. But in some contexts, especially in the health, to provide really targeted solution for your health problem, you might have to go to your personal DNA to understand how your body is and constitute, so that it can give you the really, a personalized solution. But the privacy, as I said, is a bit context-specific, elastic, dynamics, but the simple question when it comes to privacy, would everybody be comfortable saying that, okay, age, we don't have to disclose the age, or we have to disclose the, where you live, or whatever. What is established, it becomes a non-issue. And this context is very important for the simple reason that I mentioned earlier, the issue of profiling, victimizing, feeling that you are being targeted for other reasons. So that would be, for me, the level of appropriateness. When it comes to critical data, I would say perhaps data is I agree, it's an evolving field, but I would say we can use it at 3 levels. At the prevention level, what type of data do we need? Is it those who have preconditioned exposures or cities that are less prepared than other? When it comes to now reaction responses, what type of data is needed for rapid, efficient, and useful responses or treatment? When it comes to the management of the crisis or your city or your space, time and space, what do we need? Are we just trying to save lives, and what do we need at that point? So data is also context specific. It's about the issue that we are having. But my last point here is about cross-tabulation, cross-analysis of data. We cannot afford to just have a single source or single data collection and make decisions. Now with this element, that's why the big data is very important, because you can get from different dimensions, different sectors, different sources, cross-tabulate, and then you can start having really a pattern and see where the needs are, not to overgeneralize just by a simple or one method or one tool. So that's what I would say. Very enriching, but good questions that make me thinking a bit more. Over to you.
Thank you, Mr. Xie. So now it's about to wrap up today's session. Oh, Professor Zhang.
Can I just just to supplement what I have shared today on the data and the privacy issue. And in terms of data, that the government data, of course, usually it's copyrighted and also with a sensitivity issue of the privacy issue. But there are lots of the open big data, which I want to particularly share with you, like OpenStreetMap, which is it's global, and also it's in terms of the underlying the transport networks, it's completely open. And then second is nighttime image, which is also open. And every year they have like 2 or 3 satellites which cover, at least yearly this kind of. In terms of the hotspots, the point of interests, all these hotspots basically shape the underlying living structure of space. So you can easily say where people gathering, in terms of the hotspots. Yeah. And thirdly is the social media data, like tweets, and which I have geolocation. So the location can up to a couple of meters. So this this 3 kinds of data set really help to, because it's open and also it's very massive, very big data. So it's global available. So which allows comparison between city to city, country to country. So this is the data which we have been working on. And I just put in the chat window some animation. We look at the COVID-19 cases for the 6 months before summer, daily, monthly, and even weekly, and to compare the underlying population of the USA. 300 million population shaped the underlying space. And then we check the correlation between COVID-19 cases and underlying population. We got like an 80% agreement. So basically, this kind of the open data really help to develop insights into the pandemic issue. Yeah, thank you very much.
Thank you very much, Professor Zhang. Additional comment. I like your idea that using best use of an open data set as well, not only for personal data. Thank you for the comment. And so now it's about to wrap up today's session. First of all, I just like to summarize answers to the questions. So all of us agreed on basically the urban data science and data is very critical. And it could be like trajectory data and some open source data, even like remote sensing data could be useful for fight against COVID-19. So we can all agree on the value and importance of data science is we have a consensus. And second of all, regarding privacy issue, well, this tough question, there's no single answer to the question. As I mentioned when we start this session, this is not only like applying data science, urban data science to fight against COVID-19. It's not only simply technical issue, but also like political, even philosophical issue from that perspective, because we each of us have a different boundary, which is really privacy, and this is public good. So while we're discussing, for example, Professor Kim mentioned about if it's a matter of life, live or die, then privacy really matters. Problem is that this pandemic or epidemic is in between. If it's that clear, then definitely everyone can release their privacy data, but there are certain different kind of conception. Which one is really privacy and which one is really public goods? But one thing that we can share throughout this session is that we all believe that appropriateness comes from mutual trust. That as long as every single individual believes that government or any single institution do not misuse, abuse my data set, then we're willing to release the data to improve the society, the safety of society and country, and even the world. So I believe throughout the course of fighting against COVID-19, every single institution, government try their best effort to make people convinced that government make only use of your data set for public goods. As long as that is achieved, then I believe, for the next course of pandemic, maybe someday, we can fight much better against the formidable disease. And finally, I love that Mr. Xi Jinping's comment that multi-level collaboration. I like collaboration, cooperation effort. Say, for example, we share this idea and experience and vision and value of urban data science, how to make the best use of fighting against COVID-19, that has to be shared, and eventually they can improve our safety and resilience, fighting against any formidable epidemic in the future. That's the final comment that I would like to make. And thank you very much, all the participants, and your wonderful presentation and talk and comment and visions. And now it's now wrapping up today's session. And I have a short announcement that we're going to have session 3, which starts at 4 p.m. in Korean time. So people on YouTube, please wait a little more and then join us, session 3. Again, thank you very much for all the participants and the wonderful presentation. And while we're sharing this, our knowledge and experience, we can eventually prevail and win over COVID-19. Thank you very much.
네, 지금부터 2020 서울 빅데이터
Now let us begin session 3 of the 2020 Seoul Big Data Forum. Good afternoon. My name is Kim Eun-young, the Director of Planning Department of Seoul Digital Foundation. This session is hosted by Seoul Digital Foundation under the topic of AI and Big Data approach for urban innovation. Since this morning, we have lots of presentations and discussions under the topic of big data. There are lots of phenomena around big cities. Accordingly, big data analysis is important. However, more important thing is to predict the future based on the big data we can utilize at this moment. That is why this last session will focus on AI and big data approach for urban innovation by sharing best practices of other big cities, and so that we can create some blueprint for the Seoul's innovative urban planning in the future. Now I would like to invite three presenters, followed by the panel discussion.
오늘의 첫 번째 연사분을
First speaker
멀리 미국에서
is from the US and he's connected online.
기술과 도시의 미래.
His topic is Revisiting Technology and the Future Cities, Lessons from Chicago's Food Inspection Forecasting Model for Seoul's Air Pollution Management by Professor Matthew Sapiro. Professor Matthew Sapiro is a professor from Illinois State of Technology. His major interest is the innovative scheme and in Asia, and then policy, and also climate change and innovation is his research area. And let us ask his presentation now.
Greetings from Chicago. I'm Matthew Shapiro at the Illinois Institute of Technology. I'm very pleased to be able to share with you at the Seoul Big Data Forum my research on technology and the future of cities, lessons from Chicago's food inspection forecasting model, and attempting to compare some aspects of that with Seoul's air pollution management. Before getting into the urban landscape and talking specifically about Chicago and Seoul as a comparison case, what I want to do is highlight specifically some of the work that I've done that focuses on the air pollution problem. From 2013, a Pacific Review paper that I wrote looks at how coordination problems between Korea, Japan, and China are struggling and difficult. But I also highlight the opportunity for there to be some cross-national coordination among the researchers in those countries, as well as among the environmental ministries of those countries. In the Korea Economic Institute paper that I wrote, I look at this issue even in more detail, focusing now on some of the local effects, specifically how media-related content could influence the understanding of the Korean public. And this is important in a couple of additional papers that I've written with Toby Bolson in the East Asian Community Review and in Energy Policy, where we look at how the general public is affected by specific frames. So there are some framing experiments that have been done to assess exactly how the general public views this air pollution problem, both in terms of whether it's transboundary in nature or whether it's homegrown. And this all speaks to the importance of the public's view in terms of implementing new policies, revising existing policies, how the public's opinions play a crucial role in terms of the policymaking process. This is an ongoing research project. Most recently, I'm working on a paper with Toby and Young-Woo Kim at Ewha National Women's University. So this is an ongoing research topic for me. But this all speaks to that importance of the air pollution problem in Seoul itself. I also want to highlight as preface the importance of new initiatives that we have at the Illinois Institute of Technology, where we are focusing now on urban reinvention, smart cities, sustainable cities, how we can address some of these very, very important themes of big data as well as environmental orientations. And more importantly, at the Illinois Institute of Technology, we are now emphasizing this focus on subpopulations of Chicago, specifically in the neighborhoods that surround Illinois Tech, the largely more economically impoverished and black populations, in order to address these inequalities that exist across the city, in the south side versus the north side, or the west side versus the north side. There are some very clear racial delineations and economic delineations that have to be addressed. And this is also part of what we intend to do, not just by focusing on them in a design landscape approach, but in terms of attempting to connect with stakeholders in those other areas in order to address their concerns specifically. And I think this is extremely relevant. This initiative is extremely relevant for the kinds of ideas that are perhaps being discussed at this conference. It's not just about big data, it's about asking the right questions with big data. In today's presentation, I want to cover 3 general points. And this will be framed by, first, the 2016 President's Council of Advisors on Science and Technology report that focus on certain areas of the urban landscape that are relevant for us, namely the health effects of things like food inspections and how there is variance across urban areas in terms of food inspections, and the environmental implications of air pollution and things of that nature, which is what we'll be talking about in the context of Seoul. So basically what I'm saying is there is a focus on this at the policymaking level, and I want to draw that out by first highlighting some of those different points from the 2016 PCAST report. Let's turn to that now. The PCAST report specifically focuses on identifying opportunities to improve people's lives through modernizing infrastructure, through the use of information technology. And the specific focuses are actually energy efficiency, renewable energy technology, connected and autonomous vehicles, waste and wastewater management systems, improved connectivity, urban farming. I think these are all themes that are relevant to everyone here. How we can use big data to address some of these themes is the more pressing issue. There are some key dimensions, though, that we have to examine to understand how this all fits together. Let's turn to those. These issues, these dimensions, are measured across socioeconomic issues like clean air, clean water. These are efficiency-related issues or more sustainability-related issues, but they're also measured in terms of the convenience factors that they generate. So looking, for example, at the socioeconomic dimension, we see safer neighborhoods that could result, or more affordable transportation. And as an ultimate outcome, you could have better education and training. You could have social capital that's generated across communities, these opportunities for network-related benefits. And you could ultimately address things like poverty and reduce poverty. Looking at transportation, you could have on the green or efficiency side a reduction of CO2 emissions and a reduction of pollution, noise, and the improvement of land uses. But in terms of convenience-related factors that are related to transportation, you could have increased walkability or decrease in vehicular congestion. And again, moving to the far right column, the implications are, in terms of long-term outcomes, universal access to transportation, a reduction in time for citizens and residents, and the increase in health comfort and productivity that would result from all of those things. We see this across all of the remaining 4 dimensions. 4 of these overall are, I think, very significant for what we're talking about in this presentation, namely health-related implications as well as environmental-related implications, but really they're all relevant. And I just highlight these 4: socioeconomics, transportation, buildings, and health, because those are perhaps the greatest contributors to health-related outcomes as well as to environmental-related outcomes like air pollution. Let's zero in on this a little bit more. In the Chicago case, the PCAST report highlights its array of things, which is an initiative that was put forth by the city, by Argonne National Laboratory scientists, as well as researchers at the University of Chicago, where they deployed sensors to monitor traffic congestion, air quality, crime, etc. And these are the aspects that I want to get into that are very connected to what has been done in the Seoul case in terms of some of its air pollution monitoring efforts. I want to give you just an example of how this works. Just to detail this, the array of things is really looking at the environmental conditions and using environmental sensors and air quality sensors and attaching these to telephone and electrical poles in order to capture important data about these points, basically air pollution related data that is an indicator of what is considered important in the Chicago case and looking at variance across city parts of the city. By the way, this is also a function of serious environmental injustice factors like there being greater levels of pollution in certain poorer areas of town than in other areas of town. Matching that up to the Argonne servers where it's curated, analyzed, and made available through open data portals. I mention this here not so much because it relates to the health inspection discussion that we'll get to in a minute, but because it relates directly to what is being done in the Seoul case with regard to its Internet of Things measures that are provided through the Korea Telecom effort. We'll get to that in just a minute. But the real statement that is relevant for us here, and especially in terms of this food inspection model that I will present now, is the claim that this information technology needs to be increasingly of an open nature, an open data nature, that this can be accessible, it can be used by individuals in order to understand problems and to help improve what we understand through some sort of deeper analysis of these different problems, not just by one set of individuals like at Argonne National Laboratory, but for any individual that wants to engage in a more comprehensive or, in their mind, more improved model of how things work. That's very relevant, and that's what we believe we've done with this project. We can actually align this goal from PCAST and that report on what the census data set provides regarding the amount of open data projects that exist for U.S. cities. Along the first column, we see the listing of cities, and along the different columns, we also see the different categories of open data that are available. The one that's of interest to us is here, the one that's just been highlighted in row 6 all the way across to restaurant inspections. For Chicago, we have these data available, and so these are the data that we will be focusing on in particular. But if you were interested in looking at these open data projects and potentials across different cities, this would be one place where you could do some research to see if, in fact, it was even logical to make that sort of comparison between Chicago and Los Angeles, or Chicago and any other place for a particular open data set. Some of these are not available, as you can see here. The open data portal at the City of Chicago's website, and you can see the web address here, data.cityofchicago.org, has a lot of different data regarding food inspections. The inspection ID, the name of the restaurant, the address of the restaurant, the inspection date, the type of violation, etc. And we can use this as a basis for other types of data and triangulating this data with other types of data in order to make an assessment of food inspection models, whether we can predict them, whether existing models that predict them are in fact robust. I want to highlight the source code and data availability for the study of the model. You can go to the GitHub platform here to download all of the code as well as the data that we have used. And I also want to point out that the model is trained only on routine inspections, meaning that there are not these impromptu calls by customers, perhaps, that might say, we saw a rat in the restaurant, or we saw a worker handling food without washing his or her hands. This would create reporting bias and are excluded from the analysis. It's basically only on routine scheduled inspections. This is an important distinction that has to be made clear. Let's talk first about some of the literature, though, that helps drive some of this overall approach to try and predict food violations at the urban level. The literature is actually divided in terms of whether or not inspection results predict outbreaks. We see that the Irwin et al. Study claims that inspectors are more consistent on temperature violations, and they also, I present here in this slide some of the critical predictors. I'm sorry that my face, I suspect, is covering the bottom two, Cruz et al. And Jones et al. Studies that don't show inspection results predicting outbreaks. Yet there are some critical factors like vermin and insects predicting outbreaks. In Jones, it's the storage of toxic items, and good hand washing are also very strong predictors of these outbreaks. But largely, the Irwin et al. Study is the one that claims that there is a connection between the inspection results themselves and the ability to predict outbreaks further down the road. Essentially, there isn't a clear consensus about whether or not it's possible. And we want to provide additional information to perhaps explain why or why not that is the case. It also has to be made clear that we acknowledge the presence of bias that exists when it comes to any of these big analytics projects. And it's also important to note that there is a possibility that with these massive amounts of data that are being analyzed, one is generally prone to have greater confidence in them, given the fact that there are these massive amounts of data, and that generally creates much more robust results. That would be incorrect if there are biases at work. And these biases are embraced by us. They're acknowledged by us. We address them head on, we believe, in this study. And I'll talk about that more in just a minute. But in terms of the existing research that shows that this is a problem if we ignore them, think of, for example, child abuse hotline related research that shows that those who are involved, the child welfare professionals themselves, are going to have some sort of human bias that could have an implicit or explicit effect on the work that they're doing in terms of assessing whether or not child abuse occurred. If one population calls and says there's child abuse going on, or if a specific instance of child abuse in one subpopulation, racial, for example, is occurring, perhaps the child welfare professionals would view child abuse for that subpopulation differently than another racial subpopulation. Same thing for the awarding of bail, counterfactual fairness concerns. If a defendant had been given bail instead of being kept in jail, would they have fled or committed another crime? What about judges that are providing different levels of leniency when assessing a defendant? And this Kleinberg 2017 study shows that there was clear bias by the judge who was awarding sentencing based on racial subpopulations. Really, we have to be concerned also about whether we as evaluators have explicit biases. What are those biases that exist? What if I'm a big fan of a particular restaurant and I'm doing a food inspection model and I am prone to look away from some of the results that would be identifying that particular restaurant? That would be stupid, but you get the idea. Or what if I was less prone to highlight Asian food, certain aspects of Asian food restaurants and focused instead on American food because I had this prior belief that it was not a problem in Asian food restaurants, they're much cleaner. So the big problem is in the American food restaurants. This kind of bias has to be held in place and acknowledged, and we do that. We do that, we believe, or at least we make the call to do that. And certainly there are other biases that I'll get to, but I want to return to that awarding of bail issue. In response to that Kleinberg study that we looked at just before, we do see clear differences in terms of the amount of time that is allocated for sentences to blacks and whites. in terms of different levels. And some of these look significantly different from each other. Certainly burglary and robbery and first-degree murder, those are some clear gaps between blacks and whites in terms of the number of days in lockup for each of these different crimes. We also need to keep in mind that if we don't acknowledge these kinds of differences, that there are certain aspects of our model, our predictive capabilities, that would be overlooked. What if we are focusing on certain areas of the city of Chicago? In this case, the darker shaded regions represent greater predictions for crime in certain areas. And we see that the predictions show greater amounts of crime in the west and south side for a particular day. But what if that prediction was based on the omission of certain areas of the city that existed? Or what if that prediction was based on the fact that there are certain patterns of crimes that are more likely to occur in those areas because of the fact that I just discussed, namely that those areas of the city have people that are sentenced to greater numbers of days in prison? And what if those numbers of days in prison are going to predict greater amounts of crime in those areas of the city? That means that we're going all the way back to how sentencing practices exist, back to the fact that the evaluators themselves could be biased, and human bias plays a role here. So this idea of human bias, we don't ignore and we embrace, and actually I'll show you how we embrace it directly by looking at the food inspectors themselves. Let me get to that. Our interest was to identify the effectiveness of the Chicago Department of Public Health's predictive analytics model for food inspections. Basically, whether or not they would identify more inspections, which is what we see on the left-hand graph. And we see that by the increase in the number of inspections for the city model compared to the random or the usual model, which is what we can argue is currently in existing. And also in terms of the anticipated speed with which they would be able to identify these, the increase in speed in identifying potential violators, which we see by the dashed line through this model, an increase of probably about 7 days. It looks like maybe 6 or 7 days, more quickly identifying violations based on the Chicago Department of Public Health's model. The question remains, though, are there any biases in this model? Are there any flaws in the model? Exactly what is the model measuring and how do they measure it? These are the questions that we need to ask. So we reran the Chicago Department of Public Health's model, and we looked at what, in fact, were the significant predictors of that model, breaking them down into the first 6, which are the actual food inspector groups. The Chicago Department of Public Health groups them into the purple, blue, orange, green, yellow, and brown groups. There are also a number of other significant predictors of food violations, namely whether there was a past serious violation, past critical violation, the amount of time since the last inspection that would play a role. Other things like towards the bottom, the daily high temperature, which is of course important. Chicago and Seoul both have similar climates. And in the hot summer months, there's a tendency for there to be more violations because of the fact that this muggy hot temperature could lead to greater amounts of bacteria being grown. But what I want to point to are the significantly higher values for some of these sanitation clusters, which have implications in line with the human bias factors that I mentioned earlier. Namely that the purple sanitation cluster is, if basically this says that if you are assigned, if your restaurant is assigned to be inspected by someone who is from an inspector that is a part of that purple sanitation cluster, you are much more likely to be predicted as having a violation, even if you had no violations before then. And the same might be true for the brown side. You could be a high violator before, but if you were assigned to be inspected by someone from the brown sanitation cluster, you would have a much lower tendency of being identified as a predicted violator in the future. And so this, again, speaks to the human bias related concerns that exist. Not necessarily implicit biases, but or I should say explicit biases, but implicit ones, simply by how these sanitarians are clustered among themselves. Perhaps these clusters need to be broken up, and we can't have clusters of sanitarians, but we should have instead individual sanitarians that we could control for. Indeed, that's what we found. that focusing on sanitary and cluster-based biases, we see that if a restaurant were last inspected by purple with no critical or serious violations before that, the odds ratio is extremely high, 4.7. So about 470% greater chance of being predicted as having a violation, despite the fact that you had none prior to that. And if you were last inspected by brown but had critical or serious violations before, there was an odds ratio below 1, which means that you're half as likely to be predicted as having a violation. These are clear concerns for us in terms of the robustness of the Chicago Department of Public Health model for predicting potential violators at the restaurant level. In terms of our findings, thus, violation hit rate is likely not the ideal metric for inspection forecasting. We have to revise that. The feature set is not sufficiently rich to predict food safety issues. Perhaps, again, we need to include new measures, or perhaps we have to, in fact, break down those clusters into individuals. Using sanitarians as predictor variables unfairly changes predicted risk. For example, and this is something that we thought of doing, perhaps it's worth matching up some of these available data through the Chicago Data Portal and other publicly available big data portals, and matching them up to other sources of data that might play a role in helping confirm some of those data or validate some of those data. And in this case, we looked at online searches by individuals for certain restaurants and matching them up for whether or not there was a greater propensity for there to be some sort of violation identified by a food inspector. And we found some positive relationship between them, but it was not a large data set. It was simply a preliminary effort to address what we believe is a measure of untapped potential, and that's what we would argue for: greater triangulation of these multiple data sets, bringing them together, not relying on a single data set per se. When we take these findings about the Chicago case into consideration, we can segue now to the relevance of that Chicago model for the Korean air pollution model in terms of big data portals and the analysis of them, making predictions based on them. First of all, we have to be aware of the potential biases that exist from the perspective of who the evaluators are themselves. And then we have to think about the biases that might exist in those data that we're using to do the analyses. And finally, we have to be aware and cautious of the administrators and designers of any particular predictive analytics program, whether it relates to health-related matters like food inspection models, or in terms of talking about how data can be used to address Korean air pollution. Let's talk, though, about the latter. Thinking about air pollution updates for Seoul citizens and residents, we have a very familiar map to those of you that are familiar with Seoul and are well aware of the air pollution problems that exist there. Here's a map that shows different areas of Seoul, the amount of pollution in those areas. It could be a measure of pollution that is based on a composite of different qualities of air pollution, like smog as measured by the amount of carbon monoxide, but it could also factor in things that are very specific to the air pollution problem in Northeast Asia, like PM 2.5, PM 10, and so on. These factors relate to one of the recent measures that we've collected in this survey data that we've been studying in the framing experiment context. Let me turn to that right now. Specifically, in 2019, the question was asked to Seoul residents, when air pollution is bad in Korea, how frequently do you check for air quality updates in general? Basically, looking for information like that presented on the previous slide. And we see that on a 7-point scale, checking for air pollution updates is quite high. It's well above 4, which is the midpoint. And the greatest percentage of people are looking at 6 on a 6 to 7 point scale. Our data also span 2 different time periods, so we're able to capture a change in the public's opinion toward the importance of Korea coordinating with China and the satisfaction that the Korean public has with regard to the Korean government's efforts to address the air pollution problem. We actually see a decrease over time in the importance of Korea coordinating with China, and we see an increase in satisfaction with the Korean government's efforts to address the air pollution problem, which means that this might be something worth thinking about when we're talking about the implications for our data. What would it mean, for example, if people started using one of these check update apps, knowing that this would prompt greater activity by the government to act? Is that somehow related to this? Is the satisfaction with the Korean government's efforts somehow related to that big data that we would collect from using an app-based measure? These are the kinds of factors that we need to keep in mind if we're going to do an accurate and unbiased as possible, assessment of one of these big data projects related to Seoul or any big city. I'm running short on time, but I also wanted to show some important changes that have occurred across political parties. For example, comparing 2017 to 2019 patterns of behavior among progressive, conservative, and non-affiliated or non-identified members of the Seoul public with regard to their partisan affiliation. And we see that wearing masks, for example, has consistently grown, although there's really no significant change from 2017 to 2019 for conservatives. Using an air filter at home has steadily grown. The use of air filters at work has grown. The potential for staying indoors has dropped. These are not significant differences for the latter behavior, but we see this consistent pattern, albeit at a more significant level for some of these subpopulations than others. Again, we have to wonder whether or not this would have any bearing on our data for being biased or not. But this brings us to the clear description of what in fact is going on in terms of air pollution updates for Seoul and Seoul citizens and residents. We see for the Korea Telecom's approach a number of different sensors that are in place, an air map, so to speak, that addresses the percentage of air pollution, the quality of air, and it captures these data sources through a number of different ways. This has a clear resemblance to something like that array of things model that we saw in the Chicago case. So there is clearly an overlap in terms of what Chicago is attempting to do and what Seoul is attempting to do in terms of a proper measurement of its air pollution problem. This addresses a clear Internet of Things, array of things, a big data approach to understanding the problem, so long as we are addressing these biases that might exist. This really has taken the air quality related concerns in the Chicago model for the array of things and has, through the KT Giga Internet of Things air map, shown how these data can be integrated and synthesized into a clear description of the nature of the problem at any given time. The issue remains, though, what if these data are used in some sort of predictive analytical way? What are the biases that we should be concerned about? And these remain open questions that I think are very important ones for any sort of big data sort of study, if we are going to go the predictive data analytics way. There are a number of different conclusions that we can make based on the presentation here. One, the 2016 PCAST report has a number of goals that remain unmet. It's a strategic model, but not yet fulfilled. Two, the Chicago Food Inspection model has a number of modest benefits, but still there are a number of modeling issues that we believe are at the center of those merely modest benefits that arise from it. And third, with regard to the Chicago Food Inspection model, we have to account for these human biases. We have to account for the diverse features that exist when we're engaging in any sort of predictive analytics. We also have to be aware that a supervision of the model by humans is in fact a crucial part of it. We can't just let these models run unsupervised. And finally, from a policymaking perspective, we have to be aware that governmental agencies have to be willing to revise and update their work based on public scrutiny, based on the conference that those governmental agencies have with researchers like us, as well as stakeholder bodies that are able to identify different types of factors that may have been overlooked by those governmental agencies. With those points, I'm going to conclude. I look forward to further discussion about this in the Q&A.
네, 교수님 발표 감사드립니다.
Thank you very much, Professor.
안전 예측 그리고
We were talking about safety prediction in Chicago and the cases of the urban management, and to give some suggestion for air pollution issue of Seoul metropolitan city. And after all the presentation, we can further discuss what he just touched upon. Second presentation will begin soon under the topic AI-based defect detection and recognition system for sewer pipes assessment by Professor Moon Hyun-jun of Sejong University. Professor Moon Hyun-jun is in engineering department and the dean of the engineering department, and then the pattern recognition and big data analysis is his specialty in Sejong University. Let's give him a big round of applause.
The title for my presentation is AI-based defect detection and recognition system for sewer pipe assessment using deep learning model. I'm Hyun-jun Moon, and I'm a professor in Department of Computer Science and Engineering at Sejong University in Seoul, Korea. The contents of my presentation includes 6 main sections. The topics are introduction, dataset, methodology, experimental results, conclusion, and future works. In introduction section, I will present the AI-based defect detection and recognition system for sewer pipe assessment using deep learning model. I will be showing the fundamental roles, the defects appear in the sewer, and the methods for AI-based detection using deep learning algorithms. Sewer is an important public infrastructure that stimulates the economic development of our community. The structural, civil, and functional operations of any sewer network can deteriorate at accelerated levels due to harsh environments inside the sewer pipes. Currently, manual visual inspection is the primary method of evaluating a sewer pipe. The CCTV videos captured by robots have been used to inspect and maintain the sewer network at this moment. Our research goal is to develop an AI-based defect detection and recognition system for sewer pipes dataset in Seoul City using deep learning model, especially VGG19 algorithm. First, let me introduce the background and the dataset used for this research. This study was performed by the support of Seoul Digital Foundation. A total of 13,733 CCTV videos were provided by the City of Seoul, which is collected from March through July 2020. Based on those data sets, we manually validate and collect images for 10 classes of sewer data. The data set contains a total of 5,234 images of defects and 1,061 images for non-defects. The dataset was fed into the VGG19 deep learning model. As a result, our model achieved an average accuracy of 95.2% accuracy. We have utilized limited number of images since we have only 4 months of research period compared to the previous work, which was performed for 2 years in city of Daejeon. For this research, we divided the dataset into 2 sections. Defects 8 classes and non-defect 2 classes. For the defect section, 8 categories were utilized, which is most common images. Those categories include crack longitudinal, crack circumferential, pipe broken, lateral protruding, joint faulty, joint open or separated, debris silty, surface damage. For normal types, 2 classes has been utilized, which is in and out. Let me present the sewer defect database construction. The data collection was performed by capturing defect areas appearing in the CCTV videos. And let me present some examples by showing the example of defects in the video. Figure 3 shows a sample defect frame from the sewer CCTV video. There are 10 classes, a total of 5,295 images collected. Table 3 describes in detail about the number of images for 8 classes of defects, whereas Table 4 describes in detail about the number of images for 2 classes of non-defect. In total, there are 5,295 images utilized for this research. And I would like to present dataset description. This section describes each type of crack in detail. The first defect type class is crack longitudinal. There are a total of 513 images used. This defect is a diagonal or vertical crack in the sewer wall, result from settling in the concrete foundation as concrete shrinks while it cures. Second class is crack circumferential. There were a total of 531 images utilized in this class. This class often indicates a more serious problem compared to the longitudinal crack. It suggests any damage that is parallel to the channel axis. This type of defect commonly show up any place in the circumference of the pipe. Third class is called pipe broken, and we have about 564 images in total in this class. Pipe broken indicates that the pipe structure has collapsed and required maintenance as soon as possible. Fourth class is lateral protruding. We have total of 538 images in this class. It happens when a part of a connecting pipe protrudes from the primary sewer system. Fifth class is called joint faulty, and we have total of 531 images in this class. Joint faulty refers to physical deterioration occurring in the pipe joints. Sixth class is called joint open, separated, and we have total of 546 images in this class. Joint open refers to a displacement happening in the pipe joint. Seventh class is called debris silty, and we have total of 477 images in this class. Debris silty is referred to as gravels and silts left in the sewer pipe. Moreover, the sediments of grease or other obstacles also belong to the debris silty class. Eighth class is called surface damage, and we have total of 534 images in this class. Surface damage happens due to small damage on the sewer's surface, defective pipe, brittleness, erosion by abrasion, or chemical corrosion. And there are two normal type classes. Ninth class is called in, and we have total of 515 images. In class indicate non-crack images that contain no defect. And the last 10th class is called out, and we have total of 546 images in this class. Out class indicate non-crack images that were recorded outside the sewer network. Next, let me describe the methodology used for this research. So let me present AI-based sewer pipe assessment system in this research. Based on the collected dataset, we develop an AI-based defect detection model based on CCTV videos. We apply a CNN, which is called convolutional neural network based VGG19 model, to classify data with 10 different classes. Dataset construction was performed for training and testing process. In addition, the framework can also detect defect context information based on a text detection and recognition model. This model was based on a Google Tesseract OCR, and we modified this algorithm to utilize Korean characters. Output defect context information and automatic report generation feature was added and produced automatic PDF file report. Finally, we also solve AI black box problems by applying explainable AI method to provide reasons for the results. Figure 4 describes the overall architecture of the proposed sewer defect detection framework from the input CCTV video to the output defect report. From the CCTV video, we have frames extraction, and we create crack dataset. The training was performed based on VGG19 deep learning architecture, and the testing was performed based on the trained model, and we test crack images with explainable AI method and we create automatic report generation in PDF format. And this is the overall structure of our AI-based detection model for damaged or faulted sewer pipes. Figure 5 is our proposed VGG-net structure, and it shows the architecture of our VGG-19 model. VGG-net is a model developed by a research team at Oxford University. The VGG research team made a performance comparison with a total of 6 different structures, which includes A, LRN, B, C, D, and E. They measure the performance according to the depth by creating several structures. We have utilized the model with a VGG-19, which is a structure E. VGG-19 contains 5 convolutional blocks, 3 fully connected layers, and the softmax output layer. A kernel of 3 by 3, which is a small convolution kernel, was used to produce parameters, extract more image features conveniently, and to increase the network efficiency. Let me present the experimental results for this research. Before the testing process, we evaluate the performance of the trained model to solve overfitting and underfitting problems. We create an optimal model by adjusting the epoch to solve overfitting problem. In this study, we trained with 50 epochs and 64 batch sizes. At the 49th epoch, the accuracy is 97.6%. The loss rate is gradually improved and stabilized below 0.1, which is our optimal experiment. We have designed the data set to perform the testing process. Data collection was performed for 8 classes of defect type, 2 classes of non-defect type. Our testing process used a model trained with deep learning VGG-19 algorithm. The accuracy measurement of the defect fault of sewage pipe was performed after testing process. Table 12 describes in detail about the number of images for 8 classes of defect, whereas Table 13 describes in detail about the number of images for 2 classes of non-defect. The total number of test images are 500 images. Let me present the classification performance. Table 14 shows the confusion matrix for the 500 testing images. The average accuracy is 95.2% for 10 different classes. I would like to present the automatic final report generation function. Automatic final report is automatically produced using PDF file with the generation of class-related information and image corresponding to the damaged area after AI-based analysis of CCTV video of sewer pipe. By recognizing the subtitle information printed on each frame of the CCTV video, important information including robot location, time can be recognized automatically. The two images are final report generated by the proposed framework, which contains all defects appear in the input CCTV video and their corresponding contextual information. The common problems of AI is the black box model. Because users cannot know the process of result derived through the AI model, so we apply explainable AI to visualize the process of deriving results to help users understand what is inside the AI model. In our research, explainable AI methods are applied to interpret decisions made by the proposed model. We applied a total of 3 XAI methods, which includes activation visualization, gradient weighted class activation mapping, which is called GradCam, and the smooth gradient method. I would like to explain the activation visualization. The intermediate activations are useful to gain an understanding of how successive layers transform their input. The intermediate activation of the CNN were visualized to show how the model learns specific abstract features. Also, it can be displayed by visualizing feature maps from a specific convolutional layer. Each feature map is dedicated to one particular part of the input. The most appropriate approach to represent them is by separately displaying each feature map contents as a 2D image. We visualize the output from a specific activation layer with 64 active maps. The activation layer visualization becomes less visually interpretable. The second method used was gradient-weighted class activation mapping, which is called GradCam. Class activation mapping provides a visual explanation. When GradCam obtains the cam, it produces a rough area map that highlights the important part in the predicted image. The area corresponding to the defected area is visualized in red, yellow, sky color, etc. CAM allows humans to monitor primary regions of the image relevant to the prediction by projecting class-specific weights of the softmax layer back to the feature maps from the last convolutional layers. The defect regions for a specific type of crack are accurately highlighted in the corresponding CAM image. Third method was smooth gradient. We find the influential part of the image and find it again through the sample image with noise added to the image. It is effective in finding the sensitivity map in the normalization method by adding noise in the training process. The results are visualized as a white dot on the sewer defect site. The smooth gradient method is also one of the XAI techniques that help users understand the model's prediction. We perform the gradient basis analysis with multiple random perturbations of the input and average the explanations. Let me present AI-based sewer pipe assessment system verification process. The data set for verification includes selection of 66 CCTV videos with different lengths and environments. For the last experiment, we verified the performance of the proposed model using 6 different CCTV videos instead of fixed images. The table describes the number of defects and the video length for each CCTV video. The results of the automatic recognition of damage in 6 videos shows that 123 frames were recognized and 62 images are recognized for damage classification with accurate recognition rate. In addition, we also compare the performance of the AlexNet model with the VGG19 model. AlexNet detected only 15 defects for 6 videos, whereas 62 defects were detected for the VGG19 model, which is proposed in this research. Let me present the conclusion from this research. We proposed an AI-based sewage pipe defect automatic detection and classification with deep learning model, specifically VGG19 algorithm. The manually collected data set contains 10 classes with 8 defects and 2 non-defect classes. The model used in this research was VGG19 deep learning model. Finally, we applied 3 different explainable AI methods that were applied to interpret decisions from the proposed AI model. Let me present the future research topics. In the future, several methods can be applied to improve the proposed system performance. There will be more classes with crack types added to the existing dataset. We will improve the previous collected dataset by adding more images for each class. And we will try to solve the imbalanced data problems by applying meta-learning techniques. We will solve the problem of over 2 types or multiple types of cracks appear on the same frame by customizing the deep model loss function as shown in figure 1. And we will solve the blurring effects by applying different computer vision techniques as shown in figure 2. In addition, for the deep learning model, we can apply more complex deep architecture like DenseNet or LessNet to improve the system performance. We will perform real-time crack classification based on lightweight model, includes MobileNet or EfficientNet. We will replace the existing text recognition model, which is using Tesseract OCR to the latest algorithms for suitable for Korean characters. And we will apply more advanced XAI techniques to measure the defect information, includes length or thickness. Finally, we will integrate natural language process-based approach and deep learning to process raw data measured by different types of sensors regarding a sewer, such as temperature, humidity, length, etc. We will build a 3D map type sewer network and apply the model to notify user in real time about the position that has a high risk of collapse so that the timely action can be conducted properly. This is the end of my talk, and if you have any question, please contact me by email as shown here. I would like to express my gratitude to Seoul Digital Foundation to let me perform this research. Thank you very much for listening my talk.
네, 문현준 교수님 발표
That was Professor Moon-Hyun-jun.
그 발표해 주신 하수관로 같은 경우에는
We got to see some defect detection. So only after accidents, if you try to fix it, it costs a lot of money and time and effort. So it is very helpful. You can detect the defection in advance and also to enhance the current condition. And I hope that the existing research will continue. And let's move on to the next presentation. Next one is the topic called Where and Why, the novel approach for prioritizing implementation point of public CCTV using urban big data by senior researcher Park Ji-hye of Seoul Digital Foundation. Currently, she's working in Seoul Digital Foundation in order to get involved in the efficiency of public work based on the big data. Let us invite senior researcher Park Ji-hye.
네, 안녕하세요. 저는 서울 디지털 재단의 박지혜입니다.
Hello everyone, I am Ji-hye Park, Senior Researcher of Seoul Digital Foundation. Today my presentation is about Where and Why, a novel approach for prioritizing implementation point of public CCTV using urban big data.
진행 순서는 먼저
These are the contents of my presentation. First, I'd like to share with you the background and also objective of my research, and also the literature review and the methodology that I have used, and I will share with you the analysis and result, conclusions, implications, and limitation and future research.
먼저 본 프로젝트의 배경에
First,
대해서
why did I start this research? Let me share with you the background. There was a high citizens' demand for public CCTVs installations, and the demand continued to rise along with the increase in various crimes and social problems in the city. If you look at the number of CCTVs in 2016, it was about 845,000, and annually about 100,000 additional CCTVs were installed as of last year. 1.148 million CCTVs were installed.
자치구 관할분을 기준으로 하면
Let's look
서울시
at
같은 경우에도
in a more specific
매년
manner.
신규
According to
CCTV를
citizens'
설치를 하고
demand, Seoul
있는데요.
Metropolitan
서울시
Government
같은
has
경우에 지금
installed
현재
new
약
CCTVs
2만
every
5천
year,
대의 공공
and
CCTV가 설치되어
65,100 public
있습니다.
CCTVs have been installed in 25 districts. As the end of 2019,
11,000대
10
정도가
years
설치가 되어
ago,
있었고
it was only 10,000 some CCTVs were installed,
수준이라는 점을
and
생각을
that's only
해볼 때
17% of what we have installed.
전년
And 10
설치되기
years ago,
신규로
merely
서울시에
19% were
설치되어 있었다는 것을
installed, but
저희가
now
알 수가 있습니다.
65,000 public
다만
CCTVs were
이
installed.
공공 CCTV가
However,
설치에
more
대한
than 10%
수요가
of the
많은데
public
비해서
CCTVs are newly
설치를 하는
installed each
비용이
year from the
한개 지점
previous year,
개소에
but huge
카메라가 한
budget
대만
is
설치가
spent
되는
on
것이
them.
아니라
So decision
최소
on new
3대에서
location
4대가
require
메인
reasonable
카메라 외에도 설치가
standards.
되기 때문에
Usually 4 to
생각보다
5
많은 재정이
cameras need to be
투입되고 있습니다.
installed.
그래서 시민들이
Therefore,
수요로 하는 모든 설치
the citizens'
지점에
need,
CCTV를
if we
저희가 다
meet,
설치를 할 수가 없는
then
것이
it's really
현실입니다.
difficult because that's the reality, and public CCTV
이러한
install location
배경에서
with
저희
4
연구는
cameras.
크게 세
So,
가지 목적으로 추진이
our
되었습니다.
the purpose of our research, there are 4 goals. First, the study is to improve the existing related models to establish methodology for analyzing Seoul-type public CCTV's priority regions and propose new mid to long-term installation goals by data utilization. The reason is because currently we have selected a goal and we have already achieved our installation goal. And we have revised our goal and we are now presenting a new goal. Third, in addition to using the improved methodology, we derived the status of CCTV's priority regions from 25 autonomous districts across Seoul and calculate the goals. Next, let me share with you the previous literature that has already been conducted. Since the 2010s, related research on location and also the identification of CCTVs based on spatial and location data has been continuously conducted as public CCTV installation have spread in Korea. Main trend is to select the optimal location to prevent any crimes. Well, we calculated the population, the usage of the buildings, the features, and the streets information. All of these data were used. And based on the literature that were conducted, especially in 2017, if you look at the research done by Ministry of Public Administration and Security, they talk about that since its development and distribution of this model, it was clearly found out that there was a more usage. In case of Seoul metropolitan city, it is a huge metropolitan city. We have our unique characteristic, and reflecting and considering that, we identified a couple of items to be improved. So this is the process of how we have conducted our research, and also let me explain the data that we have input. There are 11 types of the data that we have input. Before I elaborate, let me tell you that the unit or the number of the grids in Seoul, when I say grid, it means the horizontal and vertical. The distance is about 100 meters. That's what we call as grid. And it's about 10,000 square meters. So grid cell is equal to 100 meters multiplied by 100 meters. And that's the level of the data that we have used for the area grid. And secondly, the existing CCTV installation location were used, latitude and longitude. Third, status of the 5 major crimes. Fourth, commercial store data. Fifth, location of the financial establishment. And sixth, living population data, especially the movement of the people. And all the details I will explain later on. Now the data source out of 11, 9 types are the public data. For the continuous usage of the data, we would like to continuously use not only this year but also next year. So securing continuity is important. That is why we have used the public data as our data source. So the 9 types of the data, we got it from data.seoul.go.kr and also data.go.kr, which is the official data portal. And another point is that we have collected the data from crawling, and also we got the data from the 25 autonomous districts. You can see here that we have also gathered some replaced data. First, crime location data by the National Police Agency. Well, in the past, depending on the number of the crimes that have occurred, we mostly use the address, but in our research, there was some difficulty in acquiring the data. So instead of using the 5 major crimes data, we have used the crime location data by the National Police Agency. Secondly, originally the Ministry of Justice provided the address or registered foreigners' address, but it was difficult for us to get those data. So once again, we access the open data portal and acquire the data. And also, we have gathered financial data. And in case of the floating population data, we need to purchase the data because it's a living population data. But in case of Seoul metropolitan city, we can use the data. So we get access to data.seoul.go.kr and then use that data as a replacement data. Now, the level all of the data that we have used, as you have witnessed, we have the replaced data. That's why there are 5 levels. First, the most fundamental or the standard level of the data is a grid cell, 100 meter to 100 meter grid cell, and most idealistic data unit. And in each grid cell, we try to calculate the final priority index or the index classification. Second, latitude and longitude. Third and fourth, we try to use the replaced data, so 구 district or 동 district. Last but not least, we have used the address, and when we receive the information based on address, we have converted them to latitude and longitude information. And also another data that we have used is, unlike the existing model, usually those data were used in one district like 구 or 동, but in our case, the research that we have done include 25 autonomous districts. Therefore, for example, like the 구 or 동 district, there are some overlapping area. For example, in case of 중구 district area or 종로구 area, 2 or 3, when overlapping happens, we come up with the average points. So that's the additional work that we have done. Next, let me tell you the process of our research. There are 6 steps that we need to undergo. Among 6 steps, let me categorize them into 3 groups. First, data acquisitions and pre-processing. So first, the grid cell, around 61,000 grid cell. Out of that, we need to exclude, for example, the Han River space is huge, so we have excluded them, or the mountain area, and then the area where we cannot install public CCTV because they belong to the private person, we have excluded that. And from step 2 to step 5, we try to calculate the urgency or the priority of installing the CCTV. And in case of the 6th stage, as I've mentioned before, we have used the index to prioritize or grade them, and using that, we have tried to come up with the mid to long term. And also, we try to calculate the vulnerability index, especially the crime vulnerability index. In case of the 3rd stage, the CVI, crime vulnerability index, were calculated, and under that, there are 3 additional elements. 4th stage, of course, these are calculating the grid cell's weight. There are 3 elements. And 5th stage is calculating priority index, so calculating PI for each grid cell by adding MVI and CVI and multiplying the weight in previous steps. In case of 6th stage, we try to grade index and setting mid to long-term goals. So the 6 steps that I have explained before, we have used that, and we carried out our analysis, and everything we have used open source data. More specifically, in case of the data processing, we have used Python, and also in case of the addresses that we have, we changed that to latitude or longitude. That's why we have used Python. And in case of the spatial analysis, we need to calculate this through open source data. So for this, we have used a tool called QGIS. Now, in each steps, what kind of sub-items we have used, let me explain. Through 3.3 model, among the stages that we have taken, we need to calculate the priority, and I have explained to you that there are a couple of items. The first element is the monitoring vulnerability index, or MVI is the acronym that I have used. In case of the MVI, is an index that evaluates the vulnerability of CCTV coverage by grid cell and the CCTV that are already installed before, and the surveillance radius is set, and when monitoring is fragile or vulnerable, then the value will become larger. So the highest value is 10, the lowest value is 0.
최종 우선설치 지수의 두 번째 확인
Now,
요소는
the second element is CVI, or Crime Vulnerability Index. The CVI, there are three elements.
이첫 번째 구성 요소의
First element
경우에는 범죄 요인이
is
되는데요.
the occurrence factor of the crime. In that case, as I have mentioned before,
각 범죄별로
in each crime category, we input the address and we try to calculate. However, the locations of the crime information is quite sensitive, so instead we selected the major 5 crimes and then we try to categorize that. And
모든 격자의 자치구별
in each
점수가
grade,
형식이기 때문에
we give the same points, so we try to reduce that, so it's 2.75 points will be awarded for the sum of the number of the crimes in corresponding to 구, 2.25 points for the lower 5th, and 2.5 for each 구 between 6th and 19th place. The second one is the environmental factor, or EF. In case of EF, it's the total number of the stores present in each cell multiplied by 5 in the proportions of the entertainment, lodging, and finance sectors. For cells with a total less than 5 stores, we also calculate the percentage of the lodging or financial sectors or entertainment. In this case, the minimum is 5 points.
최대 5점에서
maximum is 5, minimum is 0.
다음으로 범죄 취약
Next, let me tell you the Crime Vulnerability Index. This is about the floating population factor, and FPF gives points for each percentile segment based on the number of the crime-prone female floating population during the night time, which is after between 6 to 11 p.m. and late night 0 to 6 a.m. And also, if the top 20% are included in the section, 3 points will be awarded, and the influence of the factor was reduced in accordance with the utilization of dome-level data, and 2.75 points will be given, and 2.5 point or 2.25 points will be given. So between 2 to 3 points were given. That's the range that we have given.
그래서 앞서서 말씀드린
As I have explained 3 models, we add that, and then we calculate the weight.
다음으로 웨이트 부분입니다.
Now, let me tell you about the weight.
격자별로 세 가지 타입의
There are 3 different kinds, and individual characteristics of each cell are reflected through 3 types of the weight: vulnerability female weight, detached house weight, and foreigner's weight. And only 2 elements that can reflect every single item, so through additional process, we need to supplement that. So if you look at the 3 weight element, first was VFW.
이 부분은
VFW stands for the area where the proportions of the female population resides, and when the population is much larger than the average in Seoul, then we give additional points. Second weight is detached house weight, THW. For example, apartments are better placed, but if there's a detached house or one-story house, then the proportion is higher. The next one is a foreigner's weight, and foreigner's weight will be given additional weight.
다음으로 이제 PI 부분입니다.
Next, let me touch upon the priority index, or PI.
과정들을 모두 합산을 하는 과정인데요.
PI means calculating everything that I have already mentioned before, and also monitoring vulnerability, crime vulnerability index will be added, and on top of that, we will multiply VFW, DHW, and FW.
그리고 이후 저희가 합산했던 이
After that, using this, we just don't apply that, but according to derived PI points, we also categorize the level. If it exceeds 15 points, then we select them as the highest level of the crime vulnerability and we grade them separately. And also if PI is above 10 to 15, it's a B. If it's 11 to 13, it's a C grade. And then we have all the way down to grade A. A means the superior area with the least risk, and A is the most desirable place, but E grade means area that requires urgency to install the CCTV. So based on this process, our metropolitan city try to resolve or get rid of the second grade. And that was the idea that we have presented.
저희가 앞에 설명드린 모델을 기반으로
Based on the model that we have explained, this is the map that we have gotten. Of course, there are numerous processes that we have undergone, but let me just give you the result. So, throughout this whole Seoul city, we have visualized this. The red colored one is a grade E, which is the high risk area. Grade A, the gray color, is the least risky grade. Area, and on the right column you can see the grade, number of the cells, and the percent of the total. 19,129 grade cells were analyzed, and 2,036 cells categorized into E grade, which accounts for 10.6%, and grade E requires CCTV installation immediately.
이것을 기반으로 이제
Based on
자치구의
that,
현황을 저희가 도출을 해보고요.
we have also calculated the number of the grade by district. This is of course absolute value. Based on the E grade, we calculated the urgency and 종로구 and 5 additional areas required immediate action. And the bottom 5, there are 5, including 중구, there are 5 areas that doesn't require immediate action.
여기 이 화면에서 보이는
However, if you look at this slide, you can see that the absolute number were calculated, and while we calculated relatively, you can see that
붉은색으로 표시한 5개 자치구 같은 경우에는
red color area, the 5구 area, excluding 종로구, the 4 areas have some differences, but in case of the least risky areas, bottom 5, from the absolute terms, 중구 is the most desirable place, but also when we convert that, we found out that 종남구 area becomes number 1.
저희가 여기 이제 표기한
So here, the tables
여러 가지 과정에 의해서 조금
through various process can be different also, and just use that for your reference.
그리고 앞선 테이블과 더불어서
And together with the table that I've shown you, we also try to understand why each district show different results. And due to the limited time, I will only explain 종로구 area. In case of 종로구, it received grade E, and the proportions of the grade we tried to calculate, and then we found out that the grade is 2 that requires urgency. The reason is because if you look at the table bottom, both category, the number of the cells and also ratio of each grade at the district are the highest. What are the causes? Well, first, if you look at the monitoring index, it's 6.35, and which is much higher than other 구 area. Because it's 4.49, about 1.5 higher. So Seoul average is 4.49, but compared to Seoul average, 종로구 area is 1.90, much higher.
그리고 이제 이러한 장표를 바탕으로
And based on that, we analyze once again how meaningful this number is, especially the grade E grade. When we provide it, does that really has a meaning? We try to visualize that, and as you can see from this PowerPoint slide, page 29, you can see the color.
앞서 말씀드렸던 것처럼
So as I mentioned before, in case of 종로, the monitoring vulnerable index is really high. That means the result of this visualization is also high, and the CCTV monitoring value is low, which means that they don't cover every area. Let me now give you the conclusion and also the implication. The research that we have done, we did it in order to support the scientific research by Seoul Metropolitan City, and we propose a systematic and objective method for analyzing CCTV priority and method for calculating the number of the mid to long-term installation goals, and actual data were applied to 25 autonomous districts in Seoul according to the methodology developed, and the result of the analysis were derived and shown as example. As a result, grade E, which is very urgent to install CCTVs across city, is 10.6%. Number of the mid to long-term installation target is 2036. We have interviewed the relevant departments about the result, and the interview shows that our research results are practically important. And also, the 2036 is our target to be installed. That was the goal that we presented. So based on the result of our analysis, it has numerous implications. First, compared to the existing analysis model, the input data secures sustainability, and second, in case of the existing model, not only Seoul Metropolitan City, but throughout Korea, this model can be applied everywhere, and once again, there are some restrictions that we can apply to every single urban area. Thirdly, in case of Seoul Metropolitan City government, they have 25 autonomous districts, and they must apply that. However, in case of the existing models, they were allowed to use only one district. So, once again, let me reemphasize my model. Yes, it allows 25 autonomous districts to use the model. On top of that, the practical implementation, yes, starting from this year, we have introduced this to our policy, and also until next March, we'll actively use this. And also, this research has some limitation, and I strongly believe that we need to have a further research. First, we wanted to secure sustainability, so sometimes the data levels were different, and also in case of the components that we have identified, we need to adjust the weight of the index compounds, and when we analyzed that, we realized that the information that we got from the CCTV sometimes are incorrect, not precise. Therefore, we need to improve all of these shortcomings in the future research. Of course, until December, we are in the process of completing this research, but we hope that in each cell, we would like to secure the accuracy of the priority index and grade calculated by cell, so we will secure the right location information of each CCTV, and through data supporters project, we will secure exact locations of the CCTV and also the compounds of the data that are input on the autonomous district level. We will once again narrow down the information so that we can gather more accurate information. For that, we will collaborate with the private sectors as well as private entities. Not only that, some of the analytic models shouldn't be a fixed one, but rather we need to constantly work with the parties so that we can improve our research. That concludes my presentation. If you have any question, please let me know regarding the approach that we have taken to prioritize implementation point of public CCTV using big data. Please let me know if you have any questions. Thank you.
That was Senior Researcher Park Ji-hye. Thank you for your presentation. The CCTV that Ms. Park talked about is the most important element for smart city infrastructure. It will be more sophisticated in the future and more advanced. Data-based public CCTV installations and prioritizing
implementation point was explained by senior researcher Park.
네, 이상으로 세 분 연사의 발표를
That
모두
wraps up all three
마쳤습니다.
presentations of session
이어서
3.
패널 토의가
And next, let's
진행될
get into
예정인데요.
panel
조금 전
discussion.
발표를 마치신 세 분의 연사님들과
Along with the speakers, we will invite two more panel discussants to continue talking about today's topic.
네, 그럼 오늘 토의를 함께 진행할
Now I would like to introduce our panelists today.
고윤석 본부장
Chief Director Go Yoon-seok from Department of Global ICT Corporation of NIA.
글로벌 협력 본부장으로서
He is the head of the department, and while getting involved with the ICT companies, and he does the general management for the international corporation. Next to Director Go, we have Professor Kim Jang-hyun from Sungkyunkwan University.
대구 경북 과학기술원을 거쳐
After GST in Daegu and the Hawaii University, and he's now the Dean of the Science College of Sungkyunkwan University.
조금 전 발표를 해주신 연사분들이 함께 자리하셨습니다.
And we also have our presenters, Senior Researcher Park Ji-hye from Seoul Digital Foundation,
세종대학교 문현준
Professor Moon Hyun-jun of Sejong University,
그리고 멀리 해외에서 일리노이
and from overseas, Illinois Institute of Technology, we have Professor Matthew Sapiro online.
네, 그 온라인으로 진행되는 본 포럼의 특성상 논의해야
Due to the characteristic of the online and hybrid forum, we've prepared some questions in advance, and so I would like to ask some questions, and I would like to hear from each presenter and panel discussant.
먼저 첫 번째 질문을 좀 드리겠는데요.
Let me bring first question.
첫 번째 질문은 매튜 사피로 교수님께
And that goes to Professor Matthew Sapiro.
일반적인 질문을
Maybe it could be a general question.
조금 전 발표 때 공공 데이터 수집과 활용에 대한
You talked about the data collection and the utilization of a public data. Probably not all the data projects are successful, but then a public sector data collection needs some kind of a success key. What do you think the key factor for the public sector data?
Especially comparing the Chicago model.
Yes, that's a great question. First of all, can I just add one point? The Chicago model paper was written with my co-authors Vinesh Kannan and Mustafa Bilgic. Vinesh is at Google now, and Mustafa Bilgic is at IIT with me in the Department of Computer Science. And the paper was published in the proceedings of the 2019 AAAI conference. So to answer the question, I think that there are a few things that are important for public database projects to be successful. First, and a lot of this I'll tie in with the health inspection model that we analyzed. First, the data projects have to be fully transparent with regard to how the data is collected and how the specific predictive algorithms are designed. In the case of the Chicago model, the health inspection model, the collected data was clearly identified, but the design of the predictive algorithm for the Chicago Department of Public Health was not particularly clear, and it required actually for us to engage in quite a bit of discussion with members of the team at City Hall in order to understand what was in the model. I would say second, success for these projects is a function of our ability to watch out for any sort of problematic predictors. And I mean any sort of algorithmic error that might be unable to accurately assess certain attributes and characteristics. I think a classic example now is the fact that dark-skinned people really can't
be assessed and identified using things like photo recognition. If these individuals are not being accurately identified, we can't have something like smart policing projects that are reliant on those kinds of algorithms. And I don't think we had this kind of problem in the Chicago case because we had no variable that was really on par with those kinds of biased photo recognition problems. But we did seek out these flawed measures too. So we engaged in some sort of search, expecting there to be some sort of bias. And like, for example, we focused on patterns of violations during the hot summer months for restaurants that had fish served on the menu. And we would, expect there to be higher predictions there, and there weren't in that case. If I could just give one more example, I think we also have to ask questions about important topics. We believe that the food inspection model is such a topic, right? If we're focusing on important topics, then we can have even greater implications as a result of the study, as a result of the use of this predictive analytics model. We can predict where food violations are likely to occur. We then will have a considerable amount of time that people will spend out of the hospital or out of the doctor's office, which means they could spend that time more productively at work, and they will have fewer health costs from a financial perspective. But we have to recognize that there is a caveat. If the model is poorly designed or not properly vetted, there could be problems similar to the ones that we have identified in this study. The fact that we have 1 to 2 indicators that are most important, and this shows that there are many others that would be ruled unimportant in quotation marks, meaning they are just basically pushed to the side because of the strong power that exists from these indicators. But these indicators are not necessarily making the model more accurate. They actually challenge the overarching logic of the model, and in the sense that we shouldn't be predicting health violations based on who the inspector is. And this is where the Chicago model falls short. So I'd say we just have to use some common sense and look for face validity on in terms of what we expect to happen from these models. Yeah, there's another thing I could talk about, but I'd like to leave it there and hear other people's responses. Thank you.
네, 사피로 교수님 말씀 감사드립니다.
Thank you, Professor Sapiro.
공공데이터 프로젝트의 핵심 성공
The key factor of the public data is mentioned as transparency and then prediction capability when detecting problems, and it's also important to figure out any factors that may be affected in a biased way. So regarding that, maybe
핵심 성공 요인 생각하시는 부분
anybody else, if he or she has any other idea to add,
김장현 교수님
maybe Professor Kim Jang-hyun.
네, 방금 개인적으로 저희 친구이기도 한 샤피로 교수님.
Professor Matthew Sapiro is also a good colleague and friend of mine, and I totally agree with him.
데이터의 투명성과 또 예측.
Data transparency and the prediction capability is also important, yes, but on top of that, maybe
잘 기술하고 있느냐, 디스크립션하고 있느냐.
The description is also important. What I mean by description is whether it describes well of what the data is looking for. So we used to talk about some data with mainly created by numbers, but now we have more qualitative aspect of data we started to look into. For example, for socially vulnerable people can be represented by certain data if we look into some elements of the data. So on top of what Professor Sapiro mentioned, I want to mention about some qualitative, it's called thick description, or a qualitative part of the data. I believe that is important as a key factor of the success of a public data. Thank you, Professor Kim. And my second question is about the presentation by Professor Moon Hyun-jun. Active participation is also important among the stakeholders, but as Professor Sapiro mentioned about the data transparency, yes, data itself is the key, and you introduced the AI-based defect detection and recognition system with a high accuracy, and I believe that you worked very hard to enhance that accuracy, and this is also a great contribution to the public property. Then how do you think it's a good way to open public data and utilize public data? Yes, I've looked into a lot of data, public data, and I would like to share some ideas with you. By utilizing public data, yes, it is important to expand and enlarge the scope of the data, but in the course of dealing with these public data, it's important to establish and disclose this data at the end of the day. Well, we have some great achievement in the quantitative measures, but to verify the accuracy of that data is another key, and I believe data processing here is important. So in the past, we had some restrictions related to laws and regulations, but this year some regulations are eased, and that enabled us to utilize more public data this year. But if you look into the detail, of course there are some accurate data, while there are some inaccurate and the data that needs to go through more processing. So maybe the qualitative achievement and improvement should be done more. Thank you, Professor Moon.
데이터의 양적 확장도 중요하지만
So in summary, you believe that not only quantitative but qualitative elements of the data is important. Okay, I would like to add more question to you, Professor Moon. Let's say even if you have a great data disclosed to the public, here the key is the utilization of the data. To enhance the utilization rate, what are the ways that you believe we can do? Regarding the question, this year our government started a project called Digital New Deal, which support establishing some learning data and then apps, and I'm part of the advisor committees. And through these projects, it helps to enlarge the scope of the public data projects. As mentioned before, common requirements include qualitative achievement of the public's data, and to that end, the government and other stakeholders need to do some adjustment and the collaboration. So not only establishing such data, but utilizing such data will be a great result from the cooperation. Thank you.
그럼 다음 질문을 한번 이어가도록 하겠습니다.
Let me move on to the next question.
질문은 박지혜 책임 연구원님께
I would like to ask senior researcher Park Ji-hye.
오늘 그 CCTV에 관련된 연구 과제에 대해서 발표를
Thank you for making a presentation regarding prioritizing implementation point of public CCTV. Well, at the same time, using big data, but also you have used CCTV data, but also I realized that you have used more than 10 different kinds of the data, right? Data are open, so you can get data from various sources, but also it could have been very difficult for you to use the data. Didn't you have any difficulty in securing the data that you need? Well, we have conducted our research targeting the Seoul city, but some of the data reside within Seoul city, but sometime Seoul Metropolitan City Government, but sometimes Seoul Metropolitan City Government does not have the data. For example, the crime-related data belongs to the police agency, and there are data that we can get from the government, but anything related to crimes or crime vulnerability or the registered foreigners, those kind of sensitive data we cannot get from the Seoul Metropolitan City Government. And there are a lot of hurdles in getting those data. The purpose of our research is to prevent any kind of crimes. Therefore, because this is for the public good, and we had a hope that there could have been a better system or a certain way to get the data, because when we conduct the analysis, sometime acquiring the data and then process it and then also categorizing that kind of process, it requires more time than actual research itself. So I sincerely hope that if the research and gathering the data is for the purpose of the public good, I sincerely hope that we can have a certain process that can guarantee us easy access. Thank you very much, Senior Researcher Park Ji-hye, for your answers. When we talk about data, we always talk about data openness and also data protections, and I guess it always conflict each other. Now, if the data is used for the purpose of the policy making, or if the data is used for the sake of the public as a public good, then we need to create a certain environment where accessing the data could be much easier. Now's the time to do that. Now here comes additional question to Senior Researcher Park Ji-hye. In your research, you have mentioned models, especially you mentioned that the standard analysis model developed by the Ministry of the Public Administration, and can this data be used by any kind of government agency or anyone? Because in order for this data to be used for the Seoul Metropolitan Government, some of the unique characteristic needs to be considered. So, you mentioned that you have a future plan to conduct any additional research using the data published by Ministry of Public Administrations and Security. Well, not only from the data perspective, but also I briefly mentioned during my speech that our research is an ongoing process. It will be completed sometime in December in case of Seoul Metropolitan City. Of course, it can be applied to other cities, but in case of the apartment complex, when the apartment scales is really huge, the grid cell, because the unit of grid cell calculation is 100 multiplied by 100, but it could be much larger. And also the existing area where the public CCTV is already installed, we have to calculate the weight, and calculating the value based on the weight could be quite complicated, but we need to do that. And sometime in December, we will utilize more sophisticated and advanced model, and then we will select a certain district or dong or gu, and then when we do that, we will definitely apply a more advanced model. Thank you.
아무래도 서울시의 특수성을 반영된 모델이
Well, by reflecting the characteristic of a Seoul metropolitan city, any other cities can utilize that method to wisely use the public data. I'm looking forward to the follow-up research. Let me continue to the next question. Next one goes to Professor Sapiro and Chief Director Go Yoon-seok. Due to COVID-19, we are going through unprecedented crisis at the moment. And in the morning of this forum, we also talked about this COVID-19 response. The scope of the social issues are expanded to the level of international cooperation. Not only the pandemic like COVID-19, but environmental issues, including fine dust, may be resolved wisely and in a better way if we collaborate internationally. So the necessity of the international cooperation in terms of data is what I would like to hear from you, Professor Sapiro.
Sure, that's a great question. I think I'm very happy to actually be asked this question. I think first, with regard to air pollution, data sharing has typically been problematic in Northeast Asia, as maybe those of you in the audience and on the panel know, because of the transboundary nature of the air pollution problem. So to avoid shouldering the blame, receiving the blame, China has limited its data sharing with Korea or Japan traditionally. And this makes sense if it's trying to avoid being blamed or being identified as the source of any sort of pollution that lands in Korea. But today, so that was traditional. But today we have seen a remarkable increase in research collaborations among the atmospheric scientists across Northeast Asia, and also the data that's used in the publications that they generate is also being made available through online appendices. But more directly to the point of the question, there is now real-time sharing of air quality measurements between the two countries, which is likely a function of some of these earlier efforts like the East Asian Acid Deposition Monitoring Network from 1998. But in terms of general data blockages between countries, most of the blockages exists the largest blockages are in terms of tax or financial data, personal data, public data, or digital services. And China is probably one of the more limiting, maybe the most limiting country in terms of not sharing its data with other countries. Korea, though, does it as well. And I hope it's okay that I'm focusing on Korea and China here. I think that's relevant for this conference. Korea is also not allowing the exporting of its data without the consent of each individual in its data set. Credit card related information can't be stored on servers outside of the country. Mapping data also can't be stored outside of the country. And so these kinds of institutions work against any attempt to promote the free flow of data across countries. During the pandemic, it's essential. During COVID-19, it's essential to share the health-related data, though, across countries in order for there to be a greater understanding of what needs to occur in order to limit the spread of the virus, as well as to assess the nature of the disease itself, like what are the symptoms, what are its tendencies given an individual's comorbidities. I think there's a really important World Economic Forum document that came out in June of this year that speaks to all of these issues. And I would recommend everyone look that up. I know that I found it very provocative, but the most important thing to keep in mind is this will require a lot of political negotiation, both domestically and at the international level, meaning we have to get the support from the local level to allow the data to be shared abroad for this common good, which is either decreasing air pollution or addressing and understanding things like coronavirus.
Now I would like to ask the same question to Chief Director Ko Yoon-seok.
Regarding data sharing, from three perspectives, I'd like to make a comment. I believe every country in the world, including Korea, we are very passionate about creating or producing the data or generating the data. As you know, data is regarded as a second oil or petroleum, which can bring a great impact to the industries. And the one who has the greatest amount of data can excel in everywhere. There's even premises that the one with the data can exercise the greatest power and become the superpower. Then, if you look at if you can reduce the boundary on a regional basis or a country basis, of course, we have to have a data like that. But also think about the COVID-19 pandemic. COVID-19 pandemic forces us to share the data. There must be a data that needs to be shared. We witness the importance of that. First, thinking about COVID-19, fortunately, COVID-19, depending on each regions, it doesn't require a different vaccine or different drugs to treat, or depending on the races, we don't have to produce a different drugs, right? However, when a new virus emerges that require different approaches, that means if one person dominates the data and becomes the winner, it doesn't make sense. Every single country in the world needs to come up with ways to respond to that. Therefore, especially from the public goods perspective, countries need to commonly work together, share the data together, collaborate, and then work to resolve the pending issues faced by the global community. Second, according to the research done by the global multinational country, 90% of the data possessed by the whole world were generated during the past 2 years. It means if you look at the whole history, human civilizations of the human being, actually it amounts to this 2 years worth of the data. If that is true, then this 2-year worth of the data, this data should not be generated by one country or one company or one person, which means the data of the humanity must be shared. That's very, very important. The third point that I want to talk about is we need to think about the reason why we are creating or processing the data. We generate the data so that we can learn from it. AI, the greatest issue of the AI is the issue of the virus. I mean, no matter how much data we input to the AI and trained it, if we don't give an accurate, precise data to train the AI, then AI have some prejudice and then can have biases, and then we cannot overcome the biases of AI, which means that more diverse data needs to be input and then train the AI so that we can come up with a universal AI that can work in everywhere. So still, when we talk about big data, the data itself is really limited. And we need to have a greater amount of the data that needs to be accumulated, and only when this tremendous amount of data that are input to data, AI, and then AI learn, then we can come with the true sense of the AI that we can use. So the public data, especially the public data that our country has, how can we share the big data globally? We need to talk about the importance of that. So we need to work on that so that everyone can benefit from that. Probably global big data alliance need to be created. And of course, we cannot disclose every single data and make it as an open data, but at least we can have a big data global alliance and then have a systems where, based on which we can share the important public data.
네, 샤피로 교수님, 고윤석 본부장님.
Thank you, Professor Shapiro and Director Ko Yun-seok. You have one thing in common, that sharing and cooperation of international at the international level about the data. Of course, there are some format and guidelines, and update interval may vary among countries. But in the longer perspective, standardization of the data sharing and I think we need someone who can take the lead for the data. So now our session is also on air on the YouTube. Our audience may have some questions that we collected, so I would like to continue with those questions. Senior researcher Park may want to answer this first question. We talk about first CCTV and any unintentional impact of CCTV that you never imagined. So in case of your presentation, some areas that is utilized as from a certain area, and that area may be stigmatized as a area with more crimes. It's a little bit concerned, but we didn't use crime data only. We also touch upon population of female in their 20s and 30s and industry characteristics, and our research results all include these information. So it is too soon or too early to name it areas with more crimes, but I don't think we should call these areas like areas with more crime. Well, it is more subjective concept, so maybe some areas are marked as with a higher chance of crime, but one advantage from our research is that we didn't have any record of such information. So after legislation of this, based on this data, we were able to keep tracking of any installation like CCTV, or after the first and second and third round of installation, we were able to provide some decent information regarding crimes. So like I said, it is it's my concern, but it's also important and helpful to share this information. Thank you, Researcher Park. Let me continue to the next question. Maybe Professor Kim Jang-yeon and Professor Moon Hyun-jun can answer this question. Developing public data and utilizing it and maintaining the ecosystem is important, and to that end we need to create a decent ecosystem. There have been lots of planning around, but institutionally sometimes you have a hard time to create such ecosystem. In terms of systems, which part do you think we need urgently to improve? Maybe Professor Kim Jang-yeon can start first. Okay, recently we've seen 3 data-related legislations were passed at the Congress. We have we heard some exciting voices that the regulations are eased, but of course others are concerned about it. But I met some people from medical data area. Well, because their data is very critical, maybe new hardware or software for new development, it didn't go through tests due to some privacy and confidentiality issue. So there are lots of regulation-free areas. I believe we can move forward, but it was pretty surprising that these people concerned about more regulations. So if you think of other cultures, for example, to open our market to the foreign culture, we used to have, in cultural area, we said we had screen quote, but then our Korean movies showed its excellency, so I believe we can do many trials only if we can guarantee the privacy maintenance, and especially in medical area and the health area. Maybe they should allow little more effort and trials within the firm framework of privacy. I think what Professor Kim said was very important. We have some achievement of amending current laws and regulations, but in particular in medicine and health, they have lots of data for analysis, but then if we can utilize it in the public sector, we can create great values. But again, these areas need a strict framework to protect such personal information. How about Professor Moon to answer the same question? As we went through various projects, we had some difficulties which I would like to share now. At this forum, I talked about defect detection for sewage pipes. In cooperation with Seoul Digital Foundation and Seoul Metropolitan Government, we were able to get provided enough data, and we had no problem with the data supply. However, when I collaborated with other local governments, which was related to the car plate recognition, even after the digital-related laws and regulations amended, still we haven't received the data even after 2 or 3 years. So the data we need to utilize for our research comes from overseas, but the problem of overseas plate has a different system from Korean plate numbers, which caused some problems for our research. So this year, I also have another collaboration with the Seoul Institute of Technology to deal with human face recognition. We started this December, just now, and it's a part of the data voucher project. Medium-sized companies are supposed to obtain data and process, and then they were supposed to get data from the public organization, but of course it's not easy to get provided with face information. Well, now as an alternative, they are wondering they should import the face recognition information and data from China. So we talked about medical information, cell phone numbers, ID numbers, human face for data analysis. is probably for a very long time we won't be able to conduct any analysis on those type of data. My PhD was in the field of human face recognition in the States. Back then, US was the leading country, but right now, there's a competition for the face recognition, and US can win any of these competitions these days. I'm sure that's related to the data supply issues. And the first, second, and third winner of these face recognition competition was done by Chinese entities. So any data, including personal information, will still go through the same problem for the next couple of years at least. So in some, we have some laws and regulations eased, but still we are suffering from data supply because different governments and public organizations have a different rules. And I just hope to see standardization of data supply from these public organizations. For example, eventually we get rid of these laws and regulations in order to pursue further development of technology in the future. Thank you, Professor Moon.
그 제도 측면과 그리고 무엇보다도 빠른 의사 결정과
quick communications and the governance to standardize for data supply was highlighted by your comment. Thank you.
오늘의 마지막 질문.
And let me ask the last question of today's session. This question may go to Professor Kim Jang-yeon, Dr. Go Yoon-seok, and senior researcher Park Ji-hye.
조금 전에 이제 나왔던 얘기들에도 포함이 되어 있는.
I'm sure part of it was already covered from the previous question, but open data, including public data, sometimes are related to personal information, so we have some concerns of the data process, and that results in the fear of data disclosure. But to boost data utilization, we need some measures. So what type of measures do you think it will be possible? That's what I would like to ask. Not only personal information, but boosting the ecosystem of the public data will be also handy. So if you have any suggestions for that, I would like to ask you.
무엇보다 이제 공공 데이터 측면에서 중요한 것은
The most important thing regarding public data is, as you know, the government is preparing to facilitate my data, which is very important. Let me explain what this my data is about. Until now, the main entity of the data was always government. So the government has all the individuals' data, and there are a lot of controversy going on whether the government needs to disclose the individual data or not. However, through my data business project, the main owner or entity or the holder of the data will return to individual citizens. So data business can be developed, for example, health data.
건강과 관련된 데이터
Any data related with the health, well, including Ministry of Health and Welfare, and also the National Insurance, and also National Insurance Evaluation Agency, they all have health-related data of Korean nationals. And these are very sensitive data. We already talked about it, whether we need to disclose the data or not. We cannot decide overnight. Each individual might have a different views. Therefore, the data itself we need to give all the right of the data to each individual citizens, and if the citizen decides to open his or her own data, then it can be open. And if a certain person decides not to open the data, then it should be protected, which will free the government from the responsibility of protecting the data, and there will be a higher credibility regarding the government, and at the same time the ecosystem of the databases can also be developed, and also we can have a greater room to use the individual data. So in relation to that, I believe that my data needs to be further utilized, and when that happens, all the issues that we have can be resolved. Now, systematically, if you look at the institution itself or the directives itself, if you look at Korea's system, Korea has the strongest and also the most toughest privacy in protection law, and I guess our main focus should be how we can use the data, and in light of that, we should not lose the sense of balance from the government side. It's not easy to make a decision whether to use or not to use, how, to what extent. It's not easy. So the data ownership or the data, the ownership itself should be given to the individuals through my own data business, so that each individual can decide.
고윤석 법부장님 감사드립니다.
Thank you, Director Ko.
정부에서 개인으로.
So who will provide the data is an issue here, and then he emphasized the My Data system, and by utilizing the privacy-related laws, he suggested good ideas. And next, I would like to ask Professor Kim. You mentioned about innovation in a system, and I mentioned that it should go more bold, and My Data sounds great because you can assign the right to deal with your own data as the entity to provide the data, and then that data can be also utilized for the sake of the public. On top of that, I would like to add one more. The concept of understanding of data also is highly influenced by culture. And remember, if we park the car and if we leave the phone number on top of dashboard, you may experience the phone number theft. So as a collective defense manner, there has been some strict rules. But then it's more important to see how these information is safely protected rather than how strong these laws and regulations are. And after that, we can think of the measures to boost the data utilization. Well, if you think another way to think of the importance of the data protection, it's also important to start doing that from early days, maybe from primary school. So maybe My Data can be experienced by the primary school pupil, so that they can get more used to the culture of sharing data. So I believe that it is important to have some education from primary school to junior high school in order to get rid of any fear without any specific reasons. That's what I think. Thank you, Professor Kim.
어떤 그 제도도 중요하지만
Well, as far as I understand, a system is important, but also a culture to protect the such concept of a data utilization is also important, I guess. And next, I would like to ask the same question to senior researcher Park Ji-hye.
두 가지가 있다고 생각을 하는데요.
There are two things. First is the data that belongs to the institutions or agency, and second category is an individual data. So there are two kinds of public data. In case of the previous one, the data that belongs to the agency, yes, we can open that. In case of the individual data, participation by the citizens is very important. In case of the second category, continuous participations of the citizen needs to be induced. And for that, I believe we need to have a certain mechanisms that systematically or institutionally guarantee the individuals to protect their data so that they should feel free to open their data. Through the three legislations that the government has adopted, when we think about the citizens, I am citizens, so thinking about the citizens' perspective, once we agree and then later on, we don't know what will happen to my own data. There's no way to trace back where and how my data was used. So that is why I mentioned that the government should increase the credibility about protecting the data. Once that is guaranteed, then the individual will feel at ease to disclose their data. So I believe that privacy protections and information of the individual data must be protected so that people will feel assured to open their data. Thank you.
네, 이상으로 한 약 2시간
That wraps up our 2-hour session under the topic AI and Big Data Approach for Urban Innovation. We've listened to a lot of cases of utilizing data, and through our discussion, we get to know about this AI and this big data approach for urban innovation, which requires some international collaboration. And we also talk about the dilemma of the protection of the privacy. We also talked about laws and regulations that could somehow be eased, but at the same time to be strengthened in some areas, and maybe by providing data to the public could be beneficial for individuals. These are the things that we talked through the panel discussion. Seoul Digital Foundation was the host of this session, and we hope to continue innovation in public sector in collaboration with various entities. And that wraps up the first day of 2020 Seoul Big Data Forum, and tomorrow we have more prominent presenters and speakers, and I urge you more participation for tomorrow. Thank you.